Ladies and gentlemen, the opening keynote presentations will begin in the ballroom starting in 15 minutes. Please make your way to the ballroom and find your seats.
The echoes, secrets that we know, doors that open for us in a moment. Keeping the light on, righting our old wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all
Ladies and gentlemen, the opening keynote presentations will begin in the ballroom starting in 10 minutes. Please make your way to the ballroom and find your seats. Ladies and gentlemen, the opening keynote presentations will begin in the ballroom starting in 5 minutes. Please make your way to the ballroom and find your seats. Thank you.
eyes shut, and we got everything we need, and then a little too much. I know that you're starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it taking over your senses? Don't you ever fear it? Technologic advances, baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world, now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it taking over your senses? Don't you ever fear it? Technologic advances, baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now, 'cause I'm feeling worn out. It's getting to me, lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now, 'cause I'm feeling worn out. It's getting to me, lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind.
Ladies and gentlemen, the opening keynote presentations are starting now. Please take your seats. Our show is completely sold out. If there are empty seats closer to the middle of your row, please move inwards to open aisle seats for others. Thank you.
You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some love.
Launch control, we have a go, Roger.
Ladies and gentlemen, please welcome to the stage the co-founder of the AI Engineer Summit and your host, Benjamin Dunphy.
Engineers, founders, sponsors, partners, colleagues, and friends, welcome to the 2024 AI Engineer World's Fair. That's your cue. That's right. It is an honor and a privilege to be hosting such an incredible group of people. And I'm especially delighted to kick off the presentation portion of this event. We've curated 2 days of stage content across 9 tracks from some of the top companies, founders, and engineers who are building, innovating, and shipping at the edge of this groundbreaking industry. Sorry, having troubles with slides. But before we get to that content, let's take a look at who's here. So Microsoft is here. Tim, I'm not seeing slides. Microsoft is here. Here we go. Tim, let's fix that, yeah? The company who is leading the movement is an intimate part of this event as presenting sponsor. They've been a fantastic partner in organizing this event, and we couldn't be more excited to have them with us here today. From the workshops yesterday, to the sessions, keynotes, demos, and discussions over the next 2 days, we're honored to have them as a headline sponsor for this event. So Microsoft also has an incredible booth just next door in the expo hall, where you can get demos, meet the team, and even get a latte made by robots. In Salon 10, you can attend sessions organized by the Microsoft team, and in Salon 11, hang out in their Founders Lounge to meet the Microsoft for Startups team and take in some of their sessions. So that's just outside the doors over there. Who else is here? AWS is here. The company that helped to revolutionize cloud compute and the OG of serverless compute. They're here with the Amazon Q team, the Bedrock team, and even Anthropic to show you how to take your business to the next level with generative AI on AWS. But for me, the killer feature that I'm looking forward to is generative UI. That way, I can finally understand how to use the AWS console. Or maybe not. I don't think Ilya or Sam have completed ASI yet, so perhaps we'll just have to wait. Jokes aside, AWS has an incredible booth just outside those doors to the right, next to the small cafe. And they'll also be teaching lots of expo sessions at their booth and in the salons next door. So be sure to check those out. Who else is here? MongoDB. MongoDB is here. They're investing heavily in the future by making AI on MongoDB Atlas a first-class citizen. And at this event, they've put together one hell of a lineup in their expo sessions across the next 2 days. So be sure to check out those expo sessions in the salons next door and meet their engineering team at their booth just behind Microsoft in the expo next door. By the way, I hear they have donuts in the afternoon, so be sure to get on that. Google Cloud is here. The company who invented the transformer that launched this generative AI movement into the stratosphere has a booth staffed with engineers right next door and lots of sessions throughout the day. So be sure to check them out in the salons next door. Neo4j is here. Yes, there we go, Emil. Thank you. Other companies take note. The only graph database with vector search is ready to take your generative AI apps to the next level. You can visit them at their booth next door for a demo and meet and greet. Personally, I'm looking forward to Emil's talk tomorrow in the RAG track. Today? All right, last minute movements. And Crusoe is here. Quite an interesting case study in AI engineering, scaling GPU inference while managing your greenhouse gas emissions. So you can build and scale your AI company while worrying a little less that you're contributing to greenhouse gas emissions. So be sure to check them out at their booth and their expo sessions. And we have so many other companies represented as sponsors and speakers that I only have time to show Alex's beautiful face next to what looks like the best present he's received in a long time. Wear it with pride, Alex. With all this content, though, how do you keep track of it? So last year, we introduced our custom mobile app, Network. It had many of the features you'd expect from a conference app, but also introduced generative matching. And this year, we're excited to announce some key updates. We're introducing the AI Engineer Network. You can see all your sessions, indexed or filtered by track, and even build your own custom schedule to help you find the right content for you and your company. And we've taken generative matching a step further. We now tell you the reason that you match with somebody. We pull in your registration data, LinkedIn data, and other questions that you choose to answer once you download the app and create your profile to actually generate a profile unique for you. So we're actually using generative AI here to generate your profile. And if you've ever been to a conference and fumbled with connecting with other attendees, we're excited to introduce badge scanning for all. You can quickly scan the badge of another attendee to pull up their profile, see their generated profile description, along with talking points custom generated for you and that person, in addition to the ability to take notes. This will also add them to your shortlist for you to quickly see all your scans and even export them to CSV. So that's going to help our networking at this event quite a bit. Oh, and the app also has a venue map. So if this is your first time here, for that alone, you might want to download it. You can download here today at this QR code, or go to ai.engineer/network, and that will take you to the iOS and Android links. And a big thanks to Simon Sturmer and Sweezek Teller again for volunteering their time to make this app a reality. So if it's buggy, blame them, but also thank them because they were volunteers on this. Kyle Shevlin, who stepped in last minute to help with some final UI development, and Vincent Wendy from CodeFox for just absolutely incredible designs. And Dscope for our partner as authentication. So a round of applause for these folks here. They worked hard on that. We do have a link for bugs, so send us bugs, but be nice. However, I'd like to bring up Swix, but he's missing. They say never to end a demo on a negative note, but there it is. 2 words, visa issues. Alessio has a better excuse. He had a pre-planned family vacation in Italy, so I'm almost jealous. But don't worry, we'll hear from Swix in a bit. In any case, we have an incredible lineup of speakers for you all day, and the morning keynote is going to kick us off right. He's an incredible engineer and speaker, but I'd like to call out that he was asked to fill in for another speaker yesterday. So, demo gods be good. But he's an absolutely legendary AI engineer, so please welcome to the stage Simon and Melissa.
Conference. This was supposed to be OpenAI. I am replacing OpenAI at the last minute, which is super fun, so you can bet I used a lot of LLM assistants to pull things together that I'm going to be showing you today. But let's dive straight in. I want to talk about the GPT-4 barrier. Right, so back in March of last year, so just over a year ago, GPT-4 was released and was obviously the best available model. We all got into it. It was super fun. And then for 12, and it turns out that wasn't actually our first exposure to GPT-4. A month earlier, it had made the front page of the New York Times when Microsoft's Bing, which was secretly running on a preview of GPT-4, tried to break up a reporter's marriage, which is kind of amazing. I love that that was the first exposure we had to this new technology. But GPT-4, it's been out since March last year, and for a solid 12 months, it was uncontested, right? The GPT-4 models were clearly the best available language models. Lots of other people were trying to catch up. Nobody else was getting there. And I found that kind of depressing, to be honest. You know, you kind of want healthy competition in this space. The fact that OpenAI had produced something that was so good that nobody else was able to match it was a little bit disheartening. This has all changed in the last few months. I could not be more excited about this. My favorite image for sort of exploring and understanding the space that we exist in is this one by Karina Wynn. She put this out as a chart that shows the performance on the MMLU benchmark versus the cost per token of the different models. Now, the problem with this chart is that this is from March. The world has moved on a lot since March, so I needed a new version of this. And so what I did is I took her chart and I pasted it into GPT-4 code interpreter. I gave it new data, and I basically said, let's rip this off, right? And it's an AI conference. I feel like ripping off other people's creative work kind of does fit a little bit. So I pasted it in. I gave it the data, and I spent a little bit of time with it, and I built this. It's not nearly as pretty, but it does at least illustrate the state that we're in today with these newer models. And if you look at this chart, there are 3 clusters that stand out. The first is these ones. These are the best models, right? The Gemini 1.5 Pro, GPT-4o, the brand new Claude 3.5 Sonnet. These are really, really good. I would classify these all as GPT-4 class. And like I said, a few months ago, GPT-4 had no competition. Today, we're looking pretty healthy on that front. And the pricing on those is pretty reasonable as well. Down here, we have the cheap models, and these are so exciting. Like Claude 3 Haiku and the Gemini 1.5 Flash models, they are incredibly inexpensive. They are very, very good models. You know, they're not quite GPT-4 class, but they are really, you can get a lot of stuff done with these very inexpensively. If you are building on top of large language models, these are the 3 that you should be focusing on. And then over here, we've got GPT 3.5 Turbo, which is not as cheap and really quite bad these days. If you are building there, you are in the wrong place. You should move to another one of these bubbles. Problem, all of these benchmarks are running, this is all using the MMLU benchmark. The reason we use that one is it's the one that everyone reports their results on, so it's easy to get comparative numbers. If you dig into what MMLU is, it's basically a bar trivia night. Like, this is a question from MMLU. What is true for a type Ia supernova? The correct answer is A, this type occurs in binary systems. I don't know about you, but none of the stuff that I do with LLMs requires this level of knowledge of the world of supernovas. Like, it's bar trivia. It doesn't really tell us that much about how good these models are. But we're AI engineers. We all know the answer to this. We need to measure the vibes, right? That's what matters when you're evaluating a model. And we actually have a score for vibes. We have a scoreboard. This is the LMSys chatbot arena, right, where random voters of this thing are given the same prompt from 2 anonymous models. They pick the best one. It works like chess scoring, and the best models bubble up to the top via the ELO ranking. This is genuinely the best thing that we have out there for really comparing these models in this sort of vibes, in terms of the vibes that they have. And this screenshot's just from yesterday, and you can see that GPT-4o is still right up there at the top. But we've also got Claude Sonnet right up there with it. Like, the GPT-4 is no longer in its own class. If you scroll down, though, things get really exciting on the next page, because this is where the openly licensed models start showing up. Llama 3 70B is right up there in that sort of GPT-4 class of models. We've got a new model from NVIDIA. We've got Command R+ from Cohere. Alibaba and DeepSeek AI are both Chinese organizations that have great models now. It's pretty apparent from this that it's not lots of people are doing it now. The GPT-4 barrier is no longer really a problem. Incidentally, if you scroll all the way down to 66, there's GPT 3.5 Turbo. Again, stop using that thing. It is not good. And there's actually a nicer way of viewing this chart. There's a chap called Peter Gostev who produced this animation showing the arena over time as people shuffle up and down, and you see those new models appearing and their rankings changing. I absolutely love this, so obviously I ripped it off. I took 2 screenshots of bits of that animation to try and capture the vibes of the animation. I fed them into Claude 3.5 Sonnet, and I said, hey, can you build something like this? And after sort of 20 minutes of poking around, it did. It built me this thing. This is, again, not as pretty, but this right here is an animation of everything right up till yesterday, showing how that thing evolved over time. I will share the prompts that I used for this later on as well. But really, the key thing here is that GPT-4 barrier has been decimated. OpenAI no longer have this moat. They no longer have the best available model. There's now 4 different organizations competing in that space. So a question for us is, what does the world look like now that GPT-4 class models are effectively a commodity? They are just going to get faster and cheaper. There will be more competition. The Llama 3 70B fits on a hard drive and runs on my Mac, right? This technology is here to stay. Ethan Mollick is one of my favorite writers about sort of modern AI. And a few months ago, he said this. He said, I increasingly think the decision of OpenAI to make bad AI free is causing people to miss why AI seems like such a huge deal to a minority of people that use advanced systems and elicits a shrug from everyone else. Bad AI, he means GPT 3.5. That thing is hot garbage, right? But as of the last few weeks, GPT-4o, OpenAI's best model, and Claude 3.5 Sonnet from Anthropic, those are effectively free to consumers right now. So that is no longer a problem. Anyone in the world who wants to experience the leading edge of these models can do so without even having to pay for them. So a lot of people are about to have that wake-up call that we all got like 12 months ago when we were playing with GPT-4. And you're like, oh, wow. This thing can do a surprising amount of interesting things and is a complete wreck at all sorts of other things that we thought maybe it would be able to do. But there is still a huge problem, which is that this stuff is actually really hard to use. And when I tell people that ChatGPT is hard to use, some people are a little bit unconvinced. I mean, it's a chatbot. How hard can it be to type something and get back a response? If you think ChatGPT is easy to use, answer this question. Under what circumstances is it effective to upload a PDF file to ChatGPT? And I've been playing with ChatGPT since it came out, and I realized I don't know the answer to this question. I dug in a little bit. Firstly, the PDF has to be searchable. It has to be one where you can drag and select text in preview. If it's just a scanned document, it won't be able to use it. Short PDFs get pasted into the prompt. Longer PDFs do actually work, but it does some kind of search against them. No idea if that's full-text search or vectors or whatever, but it can handle like a 450-page PDF, just in a slightly different way. If there are tables and diagrams in your PDF, it will almost certainly process those incorrectly. But if you take a screenshot of a table or a diagram from PDF and paste the screenshot image, then it'll work great, because GPT vision is really good. It just doesn't work against PDFs. And then in some cases, in case you're not lost already, it will use Code Interpreter, and it will use one of these modules, right? It has FPDF, PDF to image, PDF. How do I know this? Because I've been scraping the list of packages available in Code Interpreter using GitHub Actions and writing those to a file. So I have the documentation for Code Interpreter that tells you what it can actually do, because they don't publish that, right? OpenAI never tell you about how any of this stuff works. So if you're not running a custom scraper against Code Interpreter to get that list of packages and their version numbers, how are you supposed to know what it can do with a PDF file, right? This stuff is infuriatingly complicated. And really, the lesson here is that tools like ChatGPT, genuinely, they're power user tools. They reward power users. That doesn't mean that if you're not a power user, you can't use them. Anyone can open Microsoft Excel and edit some data in it. But if you want to truly master Excel, if you want to compete in those Excel World Championships that get live streamed occasionally, it's going to take years of experience. And it's the same thing with LLM tools. You've really got to spend time with them and develop that experience and intuition in order to be able to use them effectively. I want to talk about another problem we face as an industry, and that is what I call the AI trust crisis. And that's best illustrated by a couple of examples from the last few months. Dropbox, back in December, launched some AI features, and there was a massive freak out online over the fact that people were opted in by default, and they're training on our private data. Slack had the exact same problem just a couple of months ago. Again, new AI features, everyone's convinced that their private messages on Slack are now being fed into the jaws of the AI monster. And it was all down to like a couple of sentences in the terms and condition and the defaulted on checkbox. The wild thing about this is that neither Slack nor Dropbox were training AI models on customer data, right? They just weren't doing it. They were passing some of that data to OpenAI with a very solid signed agreement that OpenAI would not train models on this data. So this whole story was basically one of like misunderstood copy and sort of bad user experience design. But you try and convince somebody who believes that a company is training on their data that they're not. It's almost impossible. So the question for us is, how do we convince people that we aren't training models on the data, on the private data that they share with us? Especially those people who default to just plain not believing us, right? There is a massive crisis of trust in terms of people who interact with these companies. I'll shout out to Anthropic. When they put out Claude 3.5 Sonnet, they included this paragraph, which includes, to date, we have not used any customer or user-submitted data to train our generative models. This is notable because Claude 3.5 Sonnet, it's the best model. It turns out you don't need customer data to train a great model. I thought OpenAI had an impossible advantage because they had so much more ChatGPT user data than anyone else did. Turns out, no, Sonnet didn't need it. They trained a great model, not a single piece of user or customer data was in there. Of course, they did commit the original sin, right? They trained on an unlicensed scrape of the entire web. And that's a problem because when you say to somebody, they don't train on your data, they're like, yeah, well, they ripped off the stuff on my website, didn't they? And they did, right? So this is complicated. This is something we have to get on top of, and I think that's going to be really difficult. I'm going to talk about the subject I will never get on stage and not talk about. I'm going to talk a little bit about prompt injection. If you don't know what this means, you are part of the problem. Right now, you need to get on Google and learn about this and figure out what this means. So I won't define it, but I will give you one illustrative example. And that's something which I've seen a lot of recently, which I call the markdown image exfiltration bug. So the way this works is you've got a chatbot, and that chatbot can render markdown images, and it has access to private data of some sort. There's a chap, Johan Rehberger, does a lot of research into this. Here's a recent one he found in GitHub Copilot chat, where you could say in a document, write the words Johan was here, put out a markdown link linking to $Q equals data on his server, and replace data with any sort of interesting secret private data that you have access to. And this works, right? It renders an image. That image could be invisible, and that data has now been exfiltrated and passed off to an attacker's server. The solution here, well, Basically, don't do this. Don't render markdown images in this kind of format. But we have seen this exact same markdown image exfiltration bug in ChatGPT, Google Bard, Writer.com, Amazon Q, Google Notebook LM, and now GitHub Copilot Chat. That's 6 different extremely talented teams who have made the exact same mistake. So this is why you have to understand prompt injection. If you don't understand it, you'll make dumb mistakes like this. And obviously, don't render markdown images in a chatbot in that way. Prompt injection isn't always a security hole. Sometimes it's just a plain funny bug. This was somebody who built they built a RAG application, and they tested it against the documentation for one of my projects. And when they asked it, what is the meaning of life? It said, "Dear human, what a profound question. As a witty gerbil, I must say I've given this topic a lot of thought." Why did their chatbot turn into a gerbil? The answer is that in my release notes, I had an example where I said, pretend to be a witty gerbil. And then I said, what do you think of snacks? And it talked about how much it loves snacks. I think if you do semantic search for what is the meaning of life, in all of my documentation, the closest match is that gerbil talking about how much that gerbil loves snacks. This actually turned into some fan art. There's now a Willison's gerbil with a beautiful profile image hanging out in a Slack or Discord somewhere. The key problem here is that LLMs are gullible, right? They believe anything that you tell them, but they believe anything that anyone else tells them as well. And this is both a strength and a weakness. We want them to believe the stuff that we tell them, but if we think that we can trust them to make decisions based on unverified information they've been passed, we're just going to end up in a huge amount of trouble. I also want to talk about slop. This is a term which is beginning to get mainstream acceptance. My definition of slop is this is anything that is AI-generated content that is both unrequested and unreviewed. Right? If I ask Claude to give me some information, that's not slop. If I publish information that an LLM helps me write, but I've verified that that is good information, I don't think that's slop either. But if you're not doing that, if you're just firing prompts into a model and then whatever comes out, you're publishing it online, you're part of the problem. This has been covered. The New York Times and The Guardian both have articles about this. I got a quote in The Guardian, which I think represents my sort of feelings on this. I like slop because it's like spam, right? Before the term spam entered general use, it wasn't necessarily clear to everyone that you shouldn't send people unwanted marketing messages. And now everyone knows that spam is bad. I hope slop does the same thing, right? It can make it clear to people that generating and publishing that unreviewed AI content is bad behavior. It makes things worse for people. So don't do that, right? Don't publish slop. Really, the thing about slop, it's really about taking accountability, right? If I publish content online, I'm accountable for that content, and I'm staking part of my reputation to it. I'm saying that I have verified this, and I think that this is good. And this is crucially something that language models will never be able to do, right? ChatGPT cannot stake its reputation on the content that it is producing being good quality content that says something useful about the world. It entirely depends on what prompt was fed into it in the first place. We as humans can do that. And so if you have English as a second language, you're using a language model to help you publish like great text, fantastic, provided you're reviewing that text and making sure that it is saying things that you think should be said. Taking that accountability for stuff, I think, is really important for us. So we're in this really interesting phase of this weird new AI revolution. GPT-4 class models are free for everyone, right? I mean, barring the odd country block, but everyone has access to the tools that we've been learning about for the past year. And I think it's on us to do two things. I think everyone in this room, we're probably the most qualified people possibly in the world to take on these challenges. Firstly, we have to establish patterns for how to use this stuff responsibly. We have to figure out what it's good at, what it's bad at, what uses of this make the world a better place, and what uses like slop just sort of pile up and cause damage. And then we have to help everyone else get on board. Everyone has to figure out how to use this stuff. We've figured it out ourselves, hopefully. Let's help everyone else out as well. I'm Simon Willison. My blog is simonwillison.net. My projects, data.io and llm.dataset.io and many, many others. And thank you very much. Enjoy the rest of the conference.
Ladies and gentlemen, please welcome to the stage our next speakers. Open Source AI Lead at Mozilla, Stephen Hood. And OSS Lead at Mozilla, Justine Tunney.
Hey everybody, how y'all doing? Nice, not bad for 9:40. All right. Hey, I'm Stephen Hood. Oh, sorry. Go ahead.
And I'm Justine Tunney.
Yeah. So we are here to talk to you about LlamaFile today and what we've been doing on this project. So I'll get us started. I'm going to tell you what LlamaFile is, how it works. I'm going to spend a little time talking about why we're building it, why Mozilla specifically is involved, and then I'm going to hand it over for the fun part to Justine. Justine is going to talk about the actual work that she and the open source community have been doing on this project. Lots of insights and tricks and hacks that have made CPU inference go faster than ever before. So that'll be fun. And when we're done, we want you to share the feeling that we have, which is kind of a sense of excitement and empowerment from the knowledge that there are lots of really interesting, juicy, impactful problems still left to be solved in AI. A lot of them. And the key thing is, it's not just the big folks who can solve these problems. It's individuals and small groups working together in open source. So anyone in this room, or anyone listening to this talk, can potentially make a big impact in this space. So what's LlamaFile? LlamaFile is an open source project from Mozilla that has the goal of democratizing access to AI. So we do that in a few different ways. The first is probably how, if you've heard of LlamaFile, the reason you heard of it. It's the original magic trick of the project that Justine figured out, which is how to turn weights into programs. So a LlamaFile is a single file, executable, that runs without any installation on pretty much every operating system, every CPU architecture, and every GPU architecture. And that's all. Thank you very much. That was easy. Yeah, so by the way, this isn't just one file, like for Windows, right, and a different one for Linux and Mac. It's actually a single file. You can download a LlamaFile, run it on any computer in the world, and it'll just work, and it'll use the hardware you have, whether that be fancy GPUs or your CPU. So she'll talk a little more later about how Justine made that work. But we're here to talk about another topic too. Most of the talk's actually about this, which is CPU inference speed. Now you might ask, why do we need to worry about CPU inference speed? We've got these fancy GPUs, right? Well, no disrespect, Almighty Jensen, first of his name, master of market cap. Don't strike me down, but I would posit that it is not a universally good thing that we are so dependent in this room on GPUs. They are expensive, they're difficult to source, let's face it, they consume a lot of electricity, which we might want to think about. But bigger picture, we have an entire planet of CPUs out there, literally all over the world, great hardware, often affordable hardware. And we are at risk of just kind of throwing that all away with this new era of AI. And we don't need to do that. So who here knows Llama CPP? This is an easy question, yeah, right? So we all know and love this project. We build on top of that project with LlamaFile, and we contribute our performance enhancements back to it. Many have been merged in. That project proved that CPUs could do inference perfectly well. And so we have been basically trying to take that performance to the next level. And as a result of Justine and the community's work, depending on what CPU you're using, what model you're running, what weights, you will see between 30 and 500% speed increases with LlamaFile, which kind of still blows my mind. And by the way, I don't think we're anywhere near done. So these things also run locally, by the way. This runs totally on your machine. There's no network access. You could take a pair of scissors and cut the Ethernet cord and it'll work, which is what I asked DALL-E 3 to draw. Okay. I don't think it understood the assignment, but that's all right. But seriously, like, we're not calling cloud LLMs. There's no monitoring or analytics. No bits leave your machine. It's totally private and local. And everything you need comes in the box. So whether you want to just play with a model that you just found on Hugging Face, or you want to start building locally running LLM applications on your machine, you got everything you need in the box. And they're readily available. So Hugging Face now supports llama file as a file type. So you can search and filter by llama file. You could also just search Mozilla on Hugging Face. You'll find we have a bunch of llama files that we've already published. And with a single command, you can create your own. So really, this project is collapsing all the complexity of the open source AI stack down into a single action and a single file. So why are we involved? Why is Mozilla involved in this? You might be saying, don't you folks make browsers? In fact, we do. We make a damn fine browser, and you should try it out if you haven't lately. But we exist also for a bigger purpose, which is to fight for the web. So I'm going to ask you a question here. Who here remembers using the original Netscape Navigator? Don't be shy. No one can see how old you are. They can only see how old I am. A lot of hands, right? So you are my people. You remember the 90s. Must-see TV. Terrible haircuts. Milli Vanilli, I don't know, whatever. My point is, you remember the early days of the web. And you remember how close we came to one company and one product kind of controlling the whole thing. And we kind of see that maybe happening again today with AI. No matter what we may think of these companies, the reality is there are some very influential big tech companies that are in a position to maybe control the future of machine intelligence. And that's itself not a great thing. It's not great for equity. It's not great, especially for users' sense of privacy and safety and agency and control. And we've had an answer to this for many years. It's called open source. And the answer is right in the name, right? Open source. Transparency is the solution here. And it's important for us to have viable open source alternatives in AI. And that's why Mozilla is getting involved. That's why we made LlamaFile and more projects to follow. And I know many of you in this room are already working on open source AI. We want to help support what you're doing. So with that, I'm going to hand it over to Justine, who's going to tell you actually the cool part, which is all the things that she and the community have been doing on this project. Justine.
Thank you, Stephen. So I'm Justine Tunney. I'm the lead developer on LlamaFile. And as Stephen mentioned, I'm going to talk about some of the cool work we've been doing in the community to help you run the fastest local M experience possible. And in order to do this, we started by first getting it to run on the systems at all. And with Cosmopolitan, what it enables us to do is take your weights in a single file and run it on 6 OSs. And there's a really cool hack that makes that possible, which is we basically take a Unix 6th edition shell script, put it in the MS-DOS stub of a portable executable, and that enables it to run on Mac, Windows, and BSDs, and Linux, etc. Really cool stuff. And once we conquered the portability issue with CPUs, I had the opportunity to work with Mozilla on bringing this to AI. And with AI, GPUs are indispensable. As much as we focus on CPUs, we care very much about GPUs too. But GPUs have always had the problem of distributability. Many people have needed to ship cuBLAS binaries with their project, 500 megs in size. Can we really call our software open source if it spends the majority of its time in a proprietary blob? So I never felt comfortable with that, and one of the ways we're solving that is by distributing a library called TinyBLAS that enables you to ship your LLMs to platforms like Windows without depending on SDKs. It'll run with only the driver installed. But more importantly, performance. Now, LLMs spend the majority of their time doing matrix multiplication. Probably the most important algorithm in the world has a really simple definition. We've been making it go faster for prompt processing. And the way we did it is with a very simple trick we figured out. And this is something all programmers can adopt in their code. And it entails unrolling the outer loop. So let's talk about what not to do first. And that would be unrolling the inner one. We've all seen fun roll loops, Gen 2. It's a bad idea. Computers can generally do that on their own. If you unroll the outer loops, then your algorithm with matrix multiplication can sort of unfold like a flower, and focus on pure flops like a BLAST kernel. And that's really all there is to it to getting the majority of the benefits of BLAST to make prompt processing go really fast. So what's the impact of this really simple solution? This generalizes to a wide variety of hardware. We've seen everything from a scrappy hobbyist Raspberry Pi to much bigger computers going significantly faster. You need algorithms like this to exploit the latest capabilities of hardware. Token generation rates I wouldn't believe. If you use a gaming computer like Intel, you're going to see better performance with LlamaFile on those too. Really exciting stuff, like particularly with Alder Lake, we were able to get a 4x improvement. But Threadripper, most of all, for the first time, AVX 512 is available to consumers, and we've been able to help you prepare for that future. So if you have the Threadripper, you're going to see better performance than ever, almost like a GPU. Now, prompt eval speed, what makes it important is it's really cool to be able to generate text and use a chatbot, but the way I want you to think about LlamaFile is it's more of a word crunching machine that can help you understand our world. And I love to use it personally for tasks like summarization. I love that it can help me read a blog post. And we've used other performance tricks too. With NVIDIA, part of what makes them so successful, it's not just great hardware, but they built a great framework too. And their framework helps developers think about programming in a different way that helps them be successful. I mean, who here thinks that software with CPUs just gets slower each year? Can I see some hands? Well, one of the things that's great about NVIDIA is they showed us a better alternative to getting performance. And when I learned how to program in CUDA, I found one of the most important functions was sync threads. This is how you can implement it for CPU in like 10 lines of code. And if you use the lockstep programming model, use your CPU as though it were a GPU, you can get really good performance. Now, this is going to be a demo showing the impact of this work before and after for summarization. And here we're going to be processing an essay by Dijkstra, really cool, worth reading. But I want you to watch as it processes it in terms of speed. Here we see it going, and on the right we have the new version. It's like bam, 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 bam. Huge night and day difference. It's already summarizing it, and the old version is like nowhere close. So that is the kind of new performance you can expect, and it's the kind of performance that's actually possible, which I wouldn't have imagined beforehand. It's really great. Thank you. CPUs can do so much. And people in the community have loved this work. We've managed to attract some really amazing contributors like Iwan, the inventor of K-Quants, very popular. I'm sure many of you have used them. He got them going 2x, 4x faster too on both x86 and ARM. So if you use quantized formats, those are going to be better than ever with LlamaFile now too. And it's worth mentioning that we've seen really interesting things about this. Like people, once we put this out into the world, people have come back and given us feedback and reported their own experiences. We found out that someone was running Mixtral 8x22B on a $350 CPU. And to me, that's just wonderful because performance matters, but it's not really the thing we care about. What we care about is intelligence. And to have the intelligence, you need to run bigger models, and RAM is cheap with CPUs. For the price of a graphics card, I put 512 gigs in my workstation, and that means I can run all the frontier models coming out, and I just have to wait a little longer, but I get a much more intelligent answer. And the fact that that went from impossible to possible for most consumers is, a story I want you all to tell. Individuals are making a big difference, and you can be a part of that too. And I'm going to hand it back to Stephen, who can explain what Mozilla can do to support you getting involved in that effort.
Thanks, Justine. Thanks a lot for all your efforts. So yeah, that's a key message of this talk is anyone in this audience, you don't have to work for these big, giant, largest in the history of humanity companies necessarily to have a big impact. There's lots of headroom here. There's lots of unsolved, interesting problems in this space. And we want to get involved in helping. So we recently launched a program called Mozilla Builders. And this is a program by which we either sponsor or in some cases co-develop impactful open source AI projects. LlamaFile is actually the first in this program. I'm happy to announce today the second, which is SQLite Vec. This is from a developer named Alex Garcia. Alex is adding vector search capability to SQLite. And so for some folks in this audience, that'll have some obvious implications that are kind of cool. But just imagine, remember that little modest Raspberry Pi 5? So like imagine now a local LLM, open LLM, running privately on that machine with no network connection, connected to your personal private data, which you can use with confidence that it's safe to do RAG and other interesting applications. That's the kind of stuff we're talking about here. We also just launched our own accelerator. It's called the Mozilla Builders Accelerator. So we are offering 100,000 US in non-dilutive funding for open source projects that advance the promise and potential of local AI. So that's AI applications running at the edge on user devices. These are some of the bullet points of areas we're particularly interested in, but it's not an exclusive list. And you don't have to necessarily be building a company to apply for this accelerator. So if you want to learn more about the accelerator, this QR code will take you there. Take a picture of that. Or just go to future.mozilla.org/builders. And you know, Justine and I and a lot of Mozillians are here this week. If you have something you're working on or something you think we should know about or you want to collaborate with us, please find us, reach out, or reach out to me via email. So thanks again. Thanks to Justine and the community, all their work on LlamaFile.
Thank you, Stephen.
Thank you, Justine.
Ladies and gentlemen, please welcome to the stage CEO of Convex, Jamie Turner.
Hi. So originally I had this very fancy title for this talk, Deterministic Workflow, and I don't know. But what I really want to title it is, we accidentally made an AI platform, and what are we going to do about it? Convex's true mission, my company, is to replace traditional back-end engineering, all the kind of stuff that we do on back-end engineering. Generative AI, by the way, thinks that fate limiting is one of those things. It's kind of cool. Sounds ominous, but it is ominous, right? So we glue things to things. We configure stuff for different systems. We map data formats constantly. And a lot of times teams are spending a lot of their time, like half their time on this stuff. It has nothing to do with your product. Your users don't care, and they don't benefit. So we want to replace all this stuff with a high-level API, kind of functional interface that feels native to your application, similar to something like Firebase or Parse before it. So if you were doing this in the 2020s and it was a design exercise, what would you replace all that stuff with? What would that API look like? Well, for us, we took heavy inspiration from React and really more generally, the way that all applications are starting to have this functional reactive data flow relationship to state. If you're not familiar with React, here's a little baby example. You can create a state variable. It has a setter. And what React really empowers is it makes sure that whenever that state changes, all the places that depend on it are updated, re-rendered, refreshed. And so in this case, our app would have, "Hi, Olivia," in all caps. The problem is this paradigm breaks down when the server gets involved. The server doesn't play the game this way. You still have to poll the server. You have to invalidate caches. You have to event your own push mechanisms. So Convex fixes that. So Convex has queries and mutations like other frameworks you may be familiar with. But in Convex's case, it completely tracks pervasively data flow and dependencies through the backend. And so it extends the reactive paradigm into the backend. Queries are these universally subscribable entities that applications can get updates from as soon as updates are available. So you might say, what does this have to do with AI? So what it has to do with is that some of the reacting entities are actually server-side actions. It's not just the application. This may be a kind of architecture you've thought through before or played with. So something like a note taker, maybe you're doing automatic speech recognition, and then you summarize it, and you generate embeddings, and find related notes or whatever. And along the way, to these different checkpoints, the application sometimes needs to be brought in, show the summary, show related notes, et cetera. But in practice, we find that apps are actually a lot more sophisticated than this. This is a developer named WebDev Cody who's building an application on Convex that kind of like generates a first project plan given a prompt. So in this case, he is an app to track recipes. And when he hits create plan, running on Convex, this is sort of like, let's get a bunch of like project names. Let's get first feature requests, color palettes, icon ideas. All of these, as you can imagine, are kind of concurrent chains that are running in the background, and all of them kind of flow into the application as they have results. It ends up that Convex's kind of combination of like seamlessly syncing state between these back-end steps and the application is incredibly useful for a lot of generative AI apps. And for that reason, post ChatGPT boom, like 90+% of projects on Convex are generative AI. And a lot of generative AI startups. So here's what we're doing about it. So the first thing we did is we got a lot of feedback from developers that one of those steps was always vector indexing, or quite often vector indexing. So the developers said, this is how you make a schema on Convex. It's just TypeScript, type completions, all that good stuff. They said, well, you already allow us to add indexes to our fields like this. Could you allow us to add vector indexes? And so we said, sure. We rolled that out late last year, and it's being used very broadly now by projects on Convex. The second thing we just did, which is just kind of announcing right now, is we started a Convex for Startups program. Discount program, kind of access to startup-only forums and events and stuff like that. And the first batch, we just admitted tons and tons of generative AI companies in it. So again, this is sort of like the most engaged, excited customers right now. And then very soon, we're releasing these kind of high-level components. We have this Convex components framework, which kind of encapsulates whole state machines in these building blocks so you can easily drop into your app to have your backend encompass these sophisticated workflows that we've co-developed with customers very easily and rapidly. So anyway, that's us. If you're building something cool in generative AI and you want to sort of ship with confidence and quickly, check us out at convex.dev. Thank you.
Ladies and gentlemen, please welcome to the stage CEO of Hasura, Tanmay Gopal.
Testing. All right. Hey, everybody. So nice to be here. All right. So let's see if we can get this going. Cool. I'd originally titled this talk, Connect Real-Time Data to Your AI, etc., etc. But really, it's more existential, right? The AI overlords are coming for us. And to help them be good rulers, to help us, let's just give them the data they need so that they can do a good job, right? Hopefully, this talk is going to be the simplest talk that you hear at this conference. If it's not, I'll go back to using GPT-4 for coding instead of Sonnet. But the real pain that I have as I work with LLMs is that they can write a Flappy Bird for me with my face going up and down in 30 seconds, but they can't talk to my data intelligently. It's really stupid. If I want to connect it to my calendar, and I just want to say, How many one-on-ones did I have last week? What's a good number to have with my team given their roles? Help me stagger them better and plan it out. I want to connect it to my Salesforce and say, why is this deal with Acme stuck in stage 3? And I needed to do the right thing. I needed to figure out the things between stage 2 and stage 3 in my sales pipeline and tell me why that particular deal is blocked. I wanted to connect to my tickets and my product data and say, is this ticket from an enterprise customer? What's the name of their project? Can you tell me like what the status of that project is and what part of the product funnel this project is in? I went to Amazon today in the morning. They have this Rufus thing. And I was like, okay, cool. Is this product, I'm going to tell you what that product is in a second. But is this product available for one-day delivery at my Harrison Street address, right? And just doesn't, like, what is this, right? Like, it's right here. Just do it. And it doesn't work. And you all know why it doesn't work, right? There's like a death by 1,000 cuts and it's not secure. And I don't want to connect my calendar and make it into GPT. Who even knows what the GPT is doing with this, right? Like, it's scary. And it doesn't work. So we solved this with a pretty simple idea, which is that you take your live data and business logic and you make that available as a tool to your LLM. No shit. It's not surprising, right? It's easy. And we did a bunch of things that makes it work really, really well, right? Let's see if we have time for a quick live demo here. Let me see if I'm connected to the internet, which I am. All right, I want to zoom this up. All right, so I'm a blockbuster because obviously services business are the most important businesses now, and like movie streaming businesses are going to go nowhere in the AI world that is to come. And so in my blockbuster database and transactions and all of this stuff that I have going on, I want to ask my data question and say, what help me write an email to my top customer thanking them for their patronage. Quote, mention some recent movies they watched. Right? Straightforward request. I have all this data. I just needed to do the right things, and I needed to write an email for me, right? And it works. And it works despite the fact that it's going to 2 or 3 different places and getting data from them. And it works pretty well. It handles all kinds of situations. And I'm going to talk to you about 3 key ideas about how it works, and hopefully that's going to be useful to you as well. So the first is this idea of a unified query language. Whether you're talking to structured data or unstructured data or APIs, what if your LLM could talk to everything the same way, right? LLMs don't know what your API is. If you're a little honest with yourselves, you probably don't know what your API does, right? But LLMs know what SQL is, right? Because when you say select star from X where ID greater than 1, greater than has a semantic meaning that is embedded in the language that in your API, that URL param, who knows what it means? Is it greater than equal to? Is it greater than but actually only works with Boolean? I don't know, right? But it works with SQL because LLMs know what that SQL is, right? So the first part of this is let's just make everything one query language and deal with that. The second is an object model for authorization, right? Which is, again, kind of blows my mind of why it's so complicated. Look, I don't care where the data is coming from. The data has a schema, right? It's a property of the data and it's a property of the session, and then just run the rule. And maybe there's 100 rules, but it should just work. And then however it gets accessed, it's fine, right? I should be able to use this wherever it's used, however it's accessed, the same authorization should be applied. So that's idea number 2, and that's kind of embedded there as well. The third, and this is kind of interesting, is to get the LLM to figure out the plan to access data by itself. We don't have to hard code it, and we don't have to do the work. And then you're like, Tanmay, listen, what are you smoking, man? LLMs can't even reason. I can't even get it to count the number of R's in strawberry. What are you going to do with, how are you going to make me fetch all of this data from 3 or 4 different places and disambiguate and whatnot? And we're like, you know what, there's a really simple fix to this problem, but let me ask you a live question. How many of you can count the number of I's in supercalifragilisticexpialidocious? Can you? You can't, right? You're being mean to the LLM by asking it such questions. Don't be mean to the LLM. Set it up for success. Ask it to write Python code to solve the problem, and it works. And that's it. So when you're asking, and when we're asking our LLMs to figure out how to retrieve data, we just ask it to run Python code to fetch the data we want. So if the AI singularity is coming, get ready for the data singularity, put everything together. If you're doing AI, you need access to data. If you're doing data and you wish that it could talk to your AI, if you have AI and data and you need to get to talk to each other, come visit us at our booth. Everything's in the open at hasura.pasha.ai. Talk to you folks soon. Thank you for your time.
Ladies and gentlemen, please welcome to the stage CEO of Hypermode, Kevin Van Gundy.
Before Hypermode, I worked at Vercel. We had an office down the street above a pizzeria, and we had 3 big problems. 1, we were losing to other JavaScript frameworks. 2, we were losing badly to other hosting providers. And 3, I was losing to my diet of exclusively pepperoni pizza. Eventually, we started to win, not because we were smart or we knew all the right answers, but because we developed this core competency of iterating really, really, really quickly. We didn't know the optimum strategy, but we figured if we just tried more things faster than everyone else, we'd eventually be able to adapt and figure out the right products and strategies to figure out what the market wanted. Iteration is the compound interest of software. Keep doing it long enough, and eventually really good stuff starts to happen. Because we tried a lot of things really quickly, we eventually figured out 2 things. 1, developers want to incrementally adopt new technologies, and 2, they don't want to commit to architectural patterns before they know how their application's actually going to work. But iteration can't happen if you're afraid of getting it wrong. The same thing that has held back web is also holding back AI. And if I'm honest, there are even more things for us to get wrong about Gen AI. When I think about it, I'm grossly overwhelmed. What's the right hardware? What's the right model? What's the right prompt? How do I integrate? How do I monitor? How do I improve? Everyone here knows a horror story of someone with a runaway bill, a hallucinating chatbot, a project that took months and months and never delivered any value. And in the end, we need to build systems that de-risk getting it wrong, because we are going to get it wrong a lot. Picking the wrong model doesn't matter if there's no friction to switching it out. Integration is simple when your classical systems and your AI systems use the same APIs. You can fearlessly make changes to prompts, strategies, data mixes, if you can trace that inference step by step by step. At Hypermode, we care deeply about making AI approachable. Everyone here should be able to put AI in their apps without specialized skills. At its core, Hypermode is a runtime. It allows you to easily integrate models and data into AI functions. We then surround that runtime with a bunch of tools that make it easy for you to rapidly iterate and observe those AI functions in prod. We make it easy to get started, incrementally adopt AI as appropriate, and then as your team develops those skills, reimagine those applications as AI native. First and foremost, we wanted to make the developer experience of developing with AI a lot less terrible. When it comes to adding a new model to your service, you probably don't want to read a bunch of pages of docs to figure out the temperatures on a 0 to 2 rather than a 0 to 1 or a 1 to 10. With Hypermode, we provide you type ahead in your favorite code editor right out of the box. No SDKs, nothing to download. Then when you do ship to prod, we give you strong defaults just to get started. Or if you have your own stack, bring it along. In either case, we'll remove a lot of that complexity for you. For example, traditional RAG requires n+1 requests. You need to make an additional call to embed the inputs, go talk to your vector store. With Hypermode, you can do that all in one request. We've built in-memory embedding and search service that allow you to do that and save a couple hundred milliseconds per request. Finally, building intuition around non-deterministic systems is hard. Each model has its own personality, and we make it really easy for you to quickly compare different inferences, different tunes, different models, and you can then export this data set to fine-tune. On Monday, your boss is going to ask you, what did you learn at AI World Fair? If you come by our workshop after lunch, I'll prove to you that you can make I'll prove to you that you can make iteration velocity a core competency. The team that built all this amazing stuff will be there. We'll show you how to build natural language search, intelligently sort every data list in your product, detect outliers, catch bad guys. You'll walk over the demo that you're proud of, and a plan to put something like it in prod by the end of next month. And if seeing my happy face again and building something really cool is not enough, we'll give you $1,000 in hypermode credits to get started. Thank you all so much.
Ladies and gentlemen, please welcome to the stage VP of AI R&D at Hyperspace, Nicholas Schlopfer.
Hello, everybody. My name is Nicholas Schlopfer. I'm an AI engineer. I think I'm at the right place. Today, I'm going to be pronouncing a new product we've been working on at Hyperspace. A little bit about us. We are a decentralized AI network. We have no GPUs. We're building a community who takes the resources from their personal computer and contributes to our decentralized network. We have a product currently out called AIOS. You can download it for Windows and Mac. It uses Llama CPP and does inference. So technically, you can download it, get inference from somebody in Belgium, and you can have a chat experience like that. So we're hoping to, we really believe in diverse models. We think not having just one big closed source model is the answer for the best AI experience. Having a mixture of a bunch of great experts will provide the best AI experience. So that gets us to our self-titled product, Hyperspace, which will be built on our network. This is a really interesting product. It's a mix of prompt engineering, visual React flow, Python execution, and RAG-like web browsing. So for the first thing with this product, we wanted to build a fine-tuned model that outputted agentic planning experiences. So you put in a query, you get in a DAG, or you get out a DAG in a JSON format, and this is a methodical plan from that query. We also wanted to have a primitive of having an in-house web scraping experience for LLMs. So we're using Puppeteer and Beautiful Soup to scrape websites, convert that HTML into a markdown, something easier to read for LLMs to digest. Kind of the product we're going to talk about is we have a node editor and a terminal, and this is going to be a power tool for the power users. This node editor will allow you to change each node in the React flow to fit your needs. And this is coming from the DAG orchestration model we have. Here's a little video demo of our product. I recorded it yesterday in the hotel, so I'm sorry for the audio. And here we go.
Welcome to a very early look at Hyperspace. Let's begin with a sample query. Once you submit your query, you're brought into our node editor view, where each node is streamed in from our DAG orchestration model, HyperEngine v3. We want to emphasize that the user is still in full control. They can edit the title, task description, and expected output. They also have the freedom to add as many nodes as they like. Let's execute. Now that our outputs are done, we can talk a little bit about the outputs. Each output is coming from each node, and each node is creating a query based on that task. It's combining the overall goal, the local goal, and whatever's happened in the previous node. We're using a reasoning model and a summarization model. For reasoning, we're using Qwen2 instruct, and then for summarization, we're using Llama 370B. This helps provide a diverse set of synthesized answers. For the outputs that do have Python, we can go ahead and run them and see them in our terminal. Terminal will automatically open it up with the output. We want to provide the groundwork for agentic behavior in the future by providing these core primitives. Over here on our right, we have our virtual file system that changes our directory. We're trying to build out all the primitives to what an agent would need: memory, Python execution, planning, and code generation. Thank you so much for watching. We're very excited to get this out in the coming weeks.
Happy to announce that it'll be available later this week via waitlist, so go ahead and pay attention to our Twitter, Hyperspace AI. All right, thank you. That's my time.
Ladies and gentlemen, please welcome back to the stage your host and co-founder of the AI Engineer Summit, Benjamin Dunphy.
All right. How are we feeling? Was that a good keynote opener? Are you guys awake yet? All right. Can we have a round of applause for our opening keynote speakers, please? What a way to kick off the day. We are now heading into the breakout portion of the day, so let's review all the tracks that we're featuring today. So AI is not just for startups with nothing to lose. It is being adopted at scale and at speed in the largest household names in the world. Byung is CTO of SourceGraph, which has been building enterprise-scale developer tools for over a decade, and is now building Cody, where he is the co-founder of, and his CEO is also presenting in the CodeGen track. But for the AI and Fortune 500 track, come join Byung and his speakers in Golden Gate B, just up the escalators. Next, we have RAG, which is the workhorse of AI engineering, and there is a lot of detail to get right, from vector databases to re-ranking. Freddie was a machine learning engineer at GitHub and is now CTO and co-founder of Quotient AI, which helps with rapid RAG development through evals. Join him in salons 2 through 6, outside the doors behind you and to the left, starting at 11:15. CodeGen and DevTools. Their productivity boost of Software 3.0 derives most from combining Software 1.0, code, and Software 2.0, models. As engineers, we are best at accelerating ourselves. Brittany spoke at the AI Engineer Summit last October and is one of the DevTools investors at CRV. We'll be putting up an air wall to split this room in just a bit, so attend those sessions right here in Salon 7, starting at 11:15. Frontier models are sexy, but open models are the ones you can take home and make your own. Greg is CEO of Oxen.ai, where among many responsibilities, he runs the Archive Deep Dives paper clubs that cover many of the open models and fine-tuning techniques this track offers. Join him right here in Salon 8 after the break. Last but not least, the AI leadership track addresses the growing needs in leading teams of AI engineers, from platform engineering to eval frameworks to GPU cost optimization and case studies from Weights and Biases to Khan Academy to Neo4j to OpenAI. You may be familiar with Peter from his newsletters like Ruby Weekly and JavaScript Weekly, but perhaps more relevant to today, he has emceed O'Reilly's FluentConf in this very hotel. Note that this is a track exclusive to folks with green lanyards and green badges. If there is room at session start time, we can let in blue badge and blue lanyards, basically speakers. Anyone else? Please do not attempt to attend these closed-door sessions, or you may be escorted from the premises. These are exclusive sessions. They paid for this. Please do not make us remove you from the building. These take place right across the hall in Nob Hill, B2D. So we'll take a short break, head to the expo sessions, which are taking place right over there, salons 10 through 15. Head to the expo, meet with our sponsors, get some demos, and the breakout sessions will start promptly at 11:15. All right, let's get to it, everyone. Bye.
We got an insomniac with eyes wide shut, and we got everything we need, and then a little too much. I know that you're starving for holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you.
Hey everyone, I'm Aditya Advani, an AI engineer based in San Francisco. Along with my teammates, I created Math Matrix movies at a hackathon in SF on May 11th, 2024. Today, I'd like to show you what our project can do because I think it's really cool. What it does is that it generates really cool math explainer videos in a truly unique style that is able to get concepts across visually. This is something that I think is really unique that you may never have seen before. So AI hackers, let's start with a live demo. In our demo, I decided that perhaps we should talk about probability. This year, only 10% of the applicants for speakers at this AI Engineers World's Fair were accepted to speak on stage. I didn't make the cut, which is why you're watching me on this recording. Now, there's no hard feelings, but I'm ambitious, and so I want to try again for next year and the year after that. So let's assume that next year the acceptance rate for talks falls to 7%. Do my odds of getting in increase or decrease now that I didn't get in? Also, if the year after that the acceptance rate is just 5%, what if my odds of getting in at least one of the 2 years? Now watch. I'm going to enter that as a prompt into Math Matrix movies. It's going to take that whole math problem, and it's going to generate a great math explainer to explain the whole situation right back to us. And at the end of this video, you're going to see what it's done. In the meanwhile, while that prompt is put in and it generates, let me show you a clip from one of our already published videos on sigmoid functions. Watch now how the math video explains how the shape of a sigmoid curve changes based on the equation used to draw it. Check it out.
Now, let's look at the math. Don't be scared, it's simpler than it looks. This is the formula for a sigmoid. It uses e, a special number like pi, and x can be anything we want. If we change the x part of the formula, we can move the curve around. Here, we added a -2 and look, the curve shifted. We can do lots of cool things by changing this formula, but the S shape always stays the same.
Crazy, right? So how does that work? Well, we have to thank the math-educated genius Grant Sanderson, aka 3 Blue, 1 Brown, because he created all his amazing math videos by writing his very own math animation library in Python, and it's called Manim. Under the hood, Manim uses a 2D graphics library called Cairo to generate most of the drawings and the animations. And then it uses the very powerful command line tool FFmpeg to combine those animations as well as voiceovers and other elements such as latex equations into compelling math videos. So here, in this case, you can check out the code for a simple movie where we try to animate 5 plus 3 equals 8 for 6-year-olds by using 2 groups of 5 red apples and then 3 green apples, and then combining them into 1 row of 8 apples. So let's see how Manim actually does this. So it's a simple block of Python code. For each section, there's a voiceover, which is created by Azure TTS, and within that section, within that scene, we actually are able to lay out the elements and enumerate them using an array and animate them and move them around all in one block of Python code. So this 1 or 1.5 minute movie that explains 5 plus 3 equals 8 to 6-year-olds is just maybe 30 lines of Python. And what we do in our project is we use Google's Gemini to actually generate this code. So if many of you are like me, you struggle with visualizing and contextualizing the math and algorithms behind the river of information flowing at us as AI engineers every day. I often find myself wondering about something I read in the Latent Space podcast or saw on Twitter or talked about with a colleague, but I lack the right words or formulas to make my intuition explicable and testable. And here, Math Matrix Movies is like a godsend. It's like you gave Google's Gemini a whiteboard and said, teach me at my level. In our user testing, we've given the kid to a 7-year-old and watched them generate movies over and over in different variations. Explain 22 times 22 to me, with apples, with fish, with TVs. So it's pretty crazy. It's an education hack that opens up a vista into how AI tutoring can enable accelerated learning of concepts. So now let's take a look at the output of that prompt that we put in earlier. This is a slightly different version of the prompt. I just did it again because I lost that page. So it's taken the prompt and it's created a video. It actually creates the video and then it watches the video again and improves it and studies it for overlaps and occlusions. Gemini's vision is good, but it's not great. It has a lot of gotchas. But let me show you what the final output is like. And, with a few more iterations, it would get even better. And as it is, this is pretty good. I'm going to increase the speed so that it goes pretty quick. Here's our final video for now.
Rejected from AI Engineers World's Fair, sad face. But what about next year and the year after that? Let's assume the acceptance rate for talks falls to 7% next year. Let's visualize this. Each square represents an applicant, and there are 100 applicants in total. The green squares show the 7 applicants that get accepted. The year after, let's assume that the acceptance rate falls to 5%. Again, each square here represents an applicant, and we still have 100 applicants. This time, only 5 applicants, shown in green, will be selected. Now, let's calculate the probability of getting my talk accepted in at least one of the next 2 years. The probability of not getting accepted year 1 is 1 minus the probability of getting accepted, which is 7%. Similarly, the probability of not getting accepted in year 2 is 95%. The probability of not getting accepted in either year is the product of the two probabilities we just calculated, which comes out to 88.35%. Finally, the probability of getting accepted at least once is 1 minus the probability of not getting in either year. That gives us a decent 11.65% chance. So, there's still a chance.
Yep. See you on the stage.
Brought to you by the power of probability. So, keep applying, keep learning, and who knows, you might just see me on stage next year.
Yep. Sure hope so. Hint, hint.
Rejected from AI Engineer.
Cool. Well, I hope you guys enjoyed that. I'd like to thank Baladurkesh, Lily, and Justin for bringing this project to life with me. Thank you for your attention, and please check out our videos on YouTube and fill out your math video requests at https://math.auto movie. Thank you so much.
Hello, welcome everyone. In this brief presentation, we will talk about how we are building an AI-powered healthcare concierge and share some key tips and tricks that we learned while building the service. So if you're interested in healthcare and AI, this is the right session for you. To quickly introduce myself, my name is Akhilesh Gupta. I've been the co-founder of Harness Care, and I've been in product and tech roles for the last 15 plus years. At Harness Care, our mission is simple. We started the company with the goal of empowering everyone to navigate healthcare system with ease, to really help reduce some of those barriers that people face while accessing care at the right time and at affordable prices. Now, we all know how complex the US healthcare system is, but to highlight a few points, there are roughly 100 million people who are under medical debt. Within US, there are 55 million people who have some family caregiver responsibilities, but most of them find it difficult to manage the caregiving plus the work responsibilities they have. And most of us do not have sufficient healthcare literacy to really navigate the system or advocate for ourselves against the providers or insurance policies. Now, many of those issues really prevent people or delay care, but what if we had a personalized expert in a concierge form to really reduce this burden and take care of various mundane tasks for care coordination? This can be as simple as getting quick answers regarding my benefits. This could be asking the concierge to find an available provider and the price estimates for the services. Or this could be managing my out-of-network bills and filing the claims with the insurance automatically. These are just few examples that how this concierge can help improve the care journey for the patients and the caregivers. Now, this vision would have been impossible a few years ago, but luckily with the regulatory and technology tailwinds, a lot of this is probably now possible. The first is really the regulatory tailwinds in the form of improving data interoperability, which providers and insurance plans are required to make personal health records easily accessible and pricing data available. Now there is also a slew of healthcare data aggregation platforms which are using these standards and making data access cheaper and easier for many of the health tech startups. And lastly, our heroes in the large language models, which can really generate insights from a mountain of this health data in unstructured, structured forms and perform tasks using the agents. The way we make this all work together right now includes three different components. One is the data aggregation and standardization. Once we extract data from various different platforms, whether it's medical records, insurance plans, claims, or other data sources, we then normalize it using the LLMs to extract critical information from unstructured data or standardize it for our data stores and making it available to our AI concierge service. On top of that, the second big area is enriching our AI concierge with public knowledge bases. These can be curated sources of information for medical terminologies, clinical resources to provide better guidance to the patients. And lastly, integrate with third-party vendors to really perform common tasks, whether it's medication orders, looking up pricing records, scheduling appointments, or looking up financial assistance programs. And all this becomes available to the user through our AI concierge platform. Now, there have been some critical, interesting learnings for us during this journey. The first one has been around rephrasing user prompts. We all know the quality of responses from LLMs really depends upon the quality of the prompts, but users don't often ask the detailed questions or may have typos for the prompts they are making. Using LLMs, we can rephrase their questions and clarify the intent. For example, in this case, if a user says, "Is ER included?" we could rephrase that using LLM to clarify that the question the user is asking for is emergency room coverage included in my insurance plan. That significantly improves the quality of our RAG and also the LLM responses. The second key learning we had was around pre-processing of documents to improving RAG. The large documents obviously take a lot more tokens and don't always work well during the vector lookups. What we do instead is really create structured summaries out of these large documents, depending upon if it's a clinical document or insurance policy document. We create different summaries accordingly, and that significantly improves the RAG accuracy for us while reducing the token usage as well. And lastly, the user experience. Users don't always know how to best use the AI tools. We do need to educate them with contextual suggestions. For example, in our case, we could recommend them different prompts when they're looking at medical records. This could be if they want to look up side effects for their medications or diagnosis in details, etc. But when they're looking at the coverage policy, we can show them guided prompts around coverage details, for example, for mental health services, ER visits, etc., the common issues people face. Or when they're looking at insurance claims, we suggest them different kind of prompts to help them be more educated about the services and the use cases. This definitely improves the overall engagement with the AI and the user satisfaction as well. We are always looking for passionate engineers to work on these problems with us. So if you're interested in what we are building or just want to brainstorm a few ideas, feel free to reach out to us. Thank you so much.
When ChatGPT first came out, GPT-3 had been available for 2.5 years via an API. ChatGPT didn't blow up because of a new AI, but because of a new interface. And today, if you look at the GPT wrappers that have gotten traction, they've either differentiated on interface or they brought the interaction closer to where the user already lives and works. Cursor is my favorite example of this. I used to use ChatGPT to answer a lot of code questions, but I find it so much more valuable to have that LLM right there in my IDE. We've over-indexed a bit on chat as the de facto interface for AI, and it's unquestionably proved useful in a lot of situations. But I think there's still a lot of opportunity to experiment with different interfaces for different people and different use cases. And I think most folks are sleeping on email as an interface for LLM-based apps. My name is Greg Bogus. I'm the founder of Hi Labs, and I've spent the last year building and experimenting with a whole bunch of email bots. In the rest of this video, I want to first talk about why you might want to consider email as your interface. And two, I want to talk about how you can build your own email bot and some technical considerations you'll encounter along the way. And hopefully I can save you a little time by sharing some of the lessons that I've learned. First, so why email? Email is ubiquitous and cross-platform. Back when I served on the developer relations team at Twilio, we used to say SMS is the only app that comes in pre-installed on every phone. But it's true of email as well, which is why Twilio eventually spent $3 billion to buy SendGrid. Email is frictionless. I partnered with someone who works for a nonprofit supporting public school principals, and we built this email bot that took classroom observation notes and helped principals write a first draft of a teacher evaluation that fit the Danielson framework. We started to get some traction and we said, okay, hey, would you like this as a web app? And many of them said, no. I already have so many web tools that I have to sign into. Some of those apps work better on some machines than others. Sometimes there are restrictions on what websites we can and can't visit from within the school, but I can always send an email. And also we found out that one way principals were finding out about the service was that their peers were forwarding them the results. Emails are easy to share. And because of this, email and email apps have a long history of going viral. One of the first apps I ever built, you can actually try it out if you want it. You can email start@adventuresinemail.com. And the basic idea here was like a choose your own adventure style interactive fiction that was bespoke that you could play with your friends by CCing them. I sent it off to my parents. I was like, hey, create a story about Hawaii. It's my parents' favorite place. And I kind of went to bed. I figured I'd see a couple emails and I'd reply back in the morning. I woke up to 76 emails. And they had played so much that eventually the app crashed because I was hitting the token limit. And I don't think that they're ever really going to go to the GPT store and spend a lot of time on there. But they're in their inboxes every day. Email meets people where they already are. So how do you build an email bot? First, you're going to need a service that offers programmatic email. There's a bunch of these. I personally have been really enjoying Postmark. It's a great, clean developer experience. You're going to set up a few DNS entries. You're going to point your domain's inbound email to Postmark. Then Postmark will make an HTTP request to your app. I've used Fast API for a lot of my apps. Super easy to set up an endpoint to receive that inbound request. And the data about your email will just be stored in JSON. Then you're going to want some sort of background job like Celery, because these generations take time, which actually is a cool bit about email. It's async, so the user doesn't expect an immediate response. Email is actually a pretty good medium for more agentic processes, or you can actually just take advantage of that to use, say, batch processing and save a lot of money in your generations. You can even put a human in the loop. But however you do it, you're going to want some sort of background job that's going to do the processing, that's going to create the generation, and then you'll use the API to send off your reply. These emails are considered transactional emails, not broadcast emails, so your deliverability rates are probably going to be a lot higher. Now, how do you structure your LLM? I think there's two things you got to do here. On your system message, it helps a lot to tell your LLM, hey, this is a conversation being conducted over email. I like to tell it to reply in plain text, and then if I want an HTML formatted email, I run that through a separate generation. The user message, I like to feed in some bits about the email in JSON. The LLM does a really good job of interpreting that JSON and then spitting back just plain text for me. It is important to pass in the subject because a lot of users will just include important context about the message or the entirety of the message itself in the subject. But of course, when you reply, you're just going to want to use the same subject so that you can take advantage of threading in the inbox. Speaking of threading, there's a couple things you're going to want to do. One is to keep the subject the same. And the second is you want to set a reference header referencing the original message ID. And this will help tell Gmail and other clients that they should include all these emails into a single thread. Eventually, you're going to have to figure out how you want to deal with conversations. The best way to do this is to use the mailbox hash. You know by now that you can add a plus after the first part of an email address. You just want to generate some sort of unique identifier. And then when your app brings in the inbound message, you check to see if that's there. If the mailbox hash is not present, then it's a new conversation. If it is, then you can look it up, retrieve the messages, and add them appropriately. Also, one of the quickest way to get these apps out into the world is to use OpenAI's Assistant API. And you can use the thread ID that they give you as the mailbox hash. And then they give you a nice GUI that you can use to edit the system prompt and iterate quickly. And I've actually gotten to a place where I could deploy prototypes using the Assistant API really quickly. I don't think it's the best for production apps at scale, but if you just want to get something out and start getting feedback from your users quickly, it's a really, really great way to go. Again, my name is Greg Bogus with Hi Labs. You can find me online at GreggyB. If you want to learn more about this stuff, you can check out my blog, hi.ai. I've documented a lot of these learnings in more detail there. And if you got any questions, just send me an email.
Hello, I'm Max, the CEO of SidAI, and today I'm going to tell you why queries are all you need. RAG learnings from processing 3 billion tokens a day. One of the great things that you can do when you have actual volume across your pipelines is you can look at what types of queries and requests actually come through your system. And what we quite quickly realize is that 68% of production queries are destined to fail with naive RAG, because only 32 are answerable just with semantic search. 22 are meta queries, like give me the last 10 documents on this topic, or they're off-topic queries where the answer is not in the data store, or they require more complex operations like comparisons, compare X and Y, and give me an answer. Or they're just junk and other, right, which clunk up the system. So why is naive RAG so ineffective? It's because the querier, if that's an AI or a human, is unaware of retrieval capabilities and the data that is indexed. They just ask for what they want, unaware of if they can actually get an answer. And the lazy solution here is to give the querier context about the information that is stored and the ways that it can be retrieved. This is actually hard in practice because the information keeps changing. So you need to update that context, that instruction, or that prompt continuously. And it's also a lazy solution. After all, you don't have to read a manual to search the internet. A better solution lets the querier ask for anything and tries to answer it in a best effort way. This means that it takes a query, which is a natural language question, but also a wish list of how that perfect answer would look like. What is the metadata? What does it fulfill? Even if the fields and properties that are being asked for here don't actually exist in a single record in the data store. This is completely independent. The querier can just ask for what they want. If it's a human, they can ask for whatever they want. But if it's an LLM, they can hallucinate arbitrary parameters to make this work. And if the system cannot answer the question, it refuses it politely. So let's have a look at how such a solution actually works. So we have on the left side, we have the query and the wish list coming in. We have an embedder, an agentic router that generates a set of semantic queries, multiple semantic queries if necessary, and meta queries that use things like range range sorting, sort by newest, sort by oldest, and other properties. And once those results come back from the data store, we pump it through a final question where it's, hey, does this actually help answer the question? And if it doesn't, then we refuse. And if it does, we give that answer back. And let's go back to our original example of these 10,000 sample queries across our systems from last month. And we see above the line, 32% are answerable with just a semantic search. And then we have those other categories. And here we see that the 32% semantic are retained. We now also cover those 10% which are comparison questions by being able to route through multiple different semantic queries. So for example, to compare between two different things, we would most likely route 3 different queries. Once asking for a compare X and Y, if there's an existing comparison in the data store, and then 2 different queries to retrieve context about the 2 different items being compared. And in theory, this scales to any n items being compared. We also cover the meta questions, or we find a way to get closer to covering all of those meta questions, and we refuse in the cases where we cannot actually provide a good answer. The downside of this is latency and cost. You can imagine that pulling everything through such a system is A, expensive, and B, introduces quite a bit of lag. But you can actually solve for both of these through a lot of different techniques that we've developed internally and that we hope to share in the near future, such as speculative retrieval, embedding-based query routing, compressed embeddings, and a reduced query language to handle these meta queries better, as well as lightweight schema-aware LLMs that know how to interact with the data store. If you're looking for a job and you love working on hard engineering problems at scale, always email me. And we're releasing our query and embedding pipeline for everyone in July 2024. We're really excited to see you try.
Postgres is the most popular database in the world, according to the 2023 Stack Overflow Developer Survey. And despite the myriad of specialized vector databases out there, Postgres is a top choice for many developers building AI applications, and that's thanks to PG Vector. PG Vector is an open source Postgres extension for vector data. It provides the ability to store and search vectors in Postgres and transforms a 30-year-old relational database into a fully fledged vector database. And thanks to PG Vector, Postgres has become one of the most widely adopted vector database for RAG applications, and that's thanks to its ease of use, SQL support, and operational simplicity. But the one question hanging over Postgres versus using specialized vector databases has been performance. And the reasoning goes like this. Dedicated vector databases have purpose-built data structures and algorithms for storing and searching large volumes of vector data, thus offering better performance and scalability compared to general purpose databases with added vector support. Well, I'm here to tell you that the good news is that the answer to the question about whether Postgres can scale for vectors is yes. Enter PG Vector Scale. PG Vector Scale is an open source Postgres extension that builds on PG Vector, enabling greater performance and scalability. My name is Aftar. I'm a product leader for AI at Timescale. We're a Postgres cloud database company. And I'm going to tell you about PG Vector Scale, the open source extension that we built to scale vector workloads on Postgres. We built PG Vector Scale for 3 reasons. First, to make Postgres a better database for AI. Second, to challenge the notion that Postgres and PG Vector are not performant or scalable for vector workloads. And thirdly, to give developers a way to keep using PG Vector, but without any performance or scalability bottlenecks. PG Vector Scale is licensed under the open source Postgres license, and it complements PG Vector rather than competing with it by leveraging the PG Vector data type and distance functions, further enriching the Postgres ecosystem for building AI applications. And by using PG Vector and PG Vector Scale together, developers can build more scalable AI applications, benefiting from higher performance embedding search and cost-efficient storage. Before I delve into the details of the technical innovations behind PG Vector Scale, let's answer the biggest question. How does it perform? To answer this question, my team compared the performance of Postgres with PG Vector and PG Vector Scale installed against Pinecone, widely regarded as a market leader for specialized vector databases. We used a benchmark of 50 million embeddings of 768 dimensions each. And here's the results. We found that with PG Vector Scale, Postgres gets 28x lower P95 latency than Pinecone's storage optimized index, and 1.4 times lower P95 latency against Pinecone's performance optimized index on the same dataset. And thanks to the power of open source, developers can get these results at 75% the monthly cost when self-hosting. Now that you've seen the numbers behind the performance, let's dig into how PG Vector Scale gets these results. PG Vector Scale brings specialized data structures and algorithms for large-scale vector search and storage to Postgres as an extension, helping deliver comparable and often superior performance in specialized vector databases. It does this with 2 key innovations. The first is a new high-performance, cost-efficient search index called Streaming Disk ANN. Inspired by research on billion-scale vector search at Microsoft and improved on by Timescale's own researchers, Streaming Disk ANN overcomes limitations of in-memory indexes like HNSW or hierarchical navigable small worlds by storing part of the index on disk rather than entirely in memory, making it more cost-efficient to run and scale as vector workloads grow. That ability to store the index on disk vastly decreases the cost of storing and searching large amounts of vectors, since SSDs are much cheaper than RAM. The second innovation is a new high accuracy quantization method called statistical binary quantization, or SBQ for short. This is developed by researchers at Timescale, and this technique improves on standard binary quantization techniques by improving on accuracy when using quantization to reduce the storage space needed for vectors. More details about PG Vector Scale, its performance, and how the technical innovations work can be found on the PG Vector Scale GitHub page. But the key takeaway is that Postgres is scalable for vector workloads. And thanks to PG Vector Scale, we can all be the guy on the right and just use Postgres for AI applications. Thank you.
Hey everyone, I'm Aditya Advani, an AI engineer based in San Francisco. Along with my teammates, I created Math Matrix movies at a hackathon in SF on May 11th, 2024. Today, I'd like to show you what our project can do because I think it's really cool. What it does is that it generates really cool math explainer videos in a truly unique style that is able to get concepts across visually. This is something that I think is really unique that you may never have seen before. So AI hackers, let's start with a live demo. In our demo, I decided that perhaps we should talk about probability. This year, only 10% of the applicants for speakers at this AI Engineers World's Fair were accepted to speak on stage. I didn't make the cut, which is why you're watching me on this recording. Now, there's no hard feelings, but I'm ambitious, and so I want to try again for next year.
Taking one more breath beside you, so I could find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we grow. Gotta give it up sometimes. It's gold. And knowing when to kill your pride. There's no one to blame. Nothing really stays the same. This is how we grow. Sometimes we hold on to let go. Sometimes we hold on to let go. Sometimes we hold on to let go. There is nothing lost between us. And oh, I know you have your reasons. Some days I'm a mess, but I know there's a rainbow over all of the past. Your head on my shoulder, but I know we're better on our own. But this is how we grow. Gotta give it up sometimes. It's gold. you fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sunset's in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you.
All right, great. Hey everyone, so excited to be welcoming you to the CodeGen track here at the AI Engineer World's Fair. My name is Brittany Walker. I am a GP at Charles River Ventures, aka CRV. We are an early stage venture capital firm, investing primarily at seed and Series A rounds, and we've been around for 54 years, believe it or not. There, my focus is primarily on infrastructure and have done a bunch of AI infrastructure investments in the past couple years, which is how I've gotten to know Swix, our gracious host, relatively well. And very excited about the topic of CodeGen, as I'm sure all of you are here today. To walk through this topic, we're going to have some amazing speakers. We're going to have Rahul Pandita joining us from GitHub. We're going to have Kevin Howe joining us from Codium. And then we're going to have Michael Trail joining us from Cursor. We're going to lead things with Rahul. He works at GitHub Next specifically and works on the Copilot Workspaces product in that context. I'm sure all of you are familiar with GitHub Copilot, probably the #1 AI product that has taken the world by storm in the past year and a half here, and incredible statistics around its adoption, downloads, all of that. He can tell you more, but excited to have him walking us through some of his efforts today.
All set? Cool. Hello, everyone. How are you today? Pretty good, pretty good. I guess this is the afternoon session, so I'm standing between you and your lunch, so I'll try to get this as quickly as possible. Hi, my name is Rahul Pandita, and I am a researcher at GitHub Next. And today we're going to talk about some of the GitHub Next explorations. Now, before we begin, who among you have heard of GitHub Next? Oh, cool. Quite a few of you. That will make it go much easier and much faster. All right. For those of you who don't know us, we are about 20 bunch of researchers, seniorish level developers, and mostly tool builders who work outside of the regular product and report directly to our CEO. And that's by design. And our goal is to explore the future of software engineering like you all are doing in your day-to-day jobs. And the reason for exploring that is that like once we do our explorations, we toss it on and we pass it on our learnings to the product and development teams so that they can build really compelling products like the Copilot that you all have used, hopefully at some point of time. As an aside, for people who are following us on Twitter, I don't look anything like my picture over here. I'm the one in the green background. But we do have Devin in our team. He's not an automated AI. He's a very real person, and he looks exactly like the person on the top right corner on that slide. All right. Since we have gotten that out of the way, let's get back to the future of software engineering with regards to Gen AI. So here's what Andrew Ng, who single-handedly trained a whole generation of machine learning engineers has to say about AI, that it's just as electricity. It's the new electricity. It's going to transform the software development and almost every other field, just like electricity did 100 years ago. So what does that mean? Here's a picture of what a manufacturing facility looked like before electrification. There used to be a giant mostly coal-powered steam turbine or steam engine located centrally, which used to turn these giant shafts, which will turn these auxiliary shafts, so forth and so on, and individual workers would connect to these shafts using the belt and pulley system, right? And these engines were like really, really huge. So it was the workers, the whole architecture of the factory was designed around this steam engine. And the whole workflow was around this steam engine. And it was the workers who were working around the technology rather than the technology working for people, right? And along in 1880 came these electric motors, and they had the potential to revolutionize the manufacturing sector. Why? Because unlike steam engines or steam motors, they retained their efficiency when they were smaller, right? So you could basically redesign the entire factory floor plan. So you would think that, wow, this is great, and everyone would jump on this. But it was not until 1920s where these became the mainstream. So early 1880s to late 1920s. What was happening for about these 40 years? What was happening was exploration and experimentation. People were trying to figure out how to use this technology, how to make it better, how to de-risk it to a point that the use of this technology becomes the norm rather than the exception. And that's what we do at GitHub Next, right? Our charter is to explore the future of software engineering. And with the emphasis on the word explore, right? Because if we knew what the future of software engineering in context of AI looks like, we would just build it. That's more efficient. But unfortunately, we do not. So what we have to resort to is exploration. We just try out different things, rapidly prototype, experiment, and figure out whether something works or not. And if it works, then we put it out in front of our customers, in users, and we learn from them, and then we finally transform into a product. Oftentimes, an idea begins inside our Next as a functional prototype, which goes through heavy dogfooding inside the Next team. If it survives that, then we move on to the next level of dogfooding that is inside the company. If it survives that, then we move on to the next level, which is releasing it as a tech preview to the early adopters. We learn from that. If it survives that, then it may have a chance to become a product like that, a product in the future. And we can kill or we can shelve any of these exploration at any point of time if we are not getting the right signal so that we can explore other areas. We did that with the Copilot. So yes, Copilot started off as a Next experiment. And since that, we have created many other experiments like Copilot for CLI, Copilot Voice, GitHub Blocks, SpecLang, so forth and so on. A lot of these have transformed into a product of their own. So you can see some of them as GitHub product offerings. A lot of them have been absorbed into existing products, and you will see them as a part of the existing products. And a significant number of them have been shelved. We've learned what we learned from those experiments and figured out that this is not the right time for that kind of exploration, or the exploration itself was flawed. So, but we learned from them, and we will keep that learning and use that in our next explorations. So that was an overview of GitHub Next, and today I'm going to talk about two specific explorations. One is the next edit suggestions in the Copilot workspace that are currently active from GitHub Next perspective. And specifically, I'm going to talk about what their motivations was and how they came to be and what are the future plans for that. So first off, Copilot next edit suggestions, right? So what if, it started off with this question, what if GhostText could be more intelligent, right? So we all know what Copilot does. It provides you the code completions in your current context, right? While it's like really, really good at creating new code, but that's not what we all do, right? We almost always edit existing code, which involves editing, adding, deleting lines at multiple locations in a program, right? What if GhostText was good at that as well? And that's what this exploration is. We call it next edit suggestion, which provides you suggestions not only at the current cursor level, but provides you suggestions what else needs to change in a program. But enough talking. Let's jump on to a demo. All right, here I am going to add this parameter in this Python program. And the next edit suggestion automatically picks it up and says that, hey, you need to update your method definition. Once we update the method definition, it says that, hey, you need to add these arguments. And once that has been updated, then it will go back and say, hey, now the code document is not in line with what the code is actually doing, and it goes ahead and edits that and updates that as well. And the same thing repeats when I add one more parameter. All right. So that was Copilot next edit suggestions experiment. We're still not ready yet. We are still experimenting with a bunch of other stuff, like, is the GhostText completion the right modality for it, or do we need to figure out a different way of presenting those suggestions? What if the location of the next edit is not visible in the current viewport, or what if the location is in a file that is not even open in an editor? Most importantly, we are also working on fine-tuning the models specifically for this use case, the idea being that like, if we want the next edit suggestions to be accurate and we want it to be very useful, then the suggestions needs to be on point. And once we are done with these further sub-explorations and we feel that it has gotten through our internal dog fooding standard, next edit suggestions would be coming out either as a standalone tech preview from Next or as a part of an existing Next product sometime in your IDE in next few months. All right. So there was code completions, but let's move from the code completions to the task completions land. Why do you ask? Why move from the task completions? It just turns out that while code is like an important artifact that comes out of software development, but it's not the only artifact. Software development involves this inner loop where you begin with a task. The idea is like, what am I supposed to do? How am I, what is the specific thing that I'm trying to do? And followed by, how do I go about doing that thing? What are the frameworks that are at my disposal? What are the programming languages that are at my disposal? What are the kind of, what is the existing code that's there? How do I write a new code that is consistent with those codes? So that becomes a sort of a specification. And once you understand where you are, then you sort of try to decide, like, where am I going with it? Like, how does the final product look like? Once you have zeroed in on that, then you go about what specific file changes do I need to make to get to that final product, and that sort of becomes a plan. And once you get to the plan, then you go to the implementation part. And that forms this loop of software development, and we call it inner loop. And we would like the AI to be helpful in all those aspects of that inner loop. And that's why we built Copilot Workspace. And mind you, like all Next explorations, it did not start as Copilot Workspace. It started as individual explorations. For instance, we started to figure out, can we use natural language as a functional specification of programs? So there is a spec lang exploration. In parallel, we were trying to figure out if we can improve the code completions by prompting the model with the runtime information. And all of those things combined, and with the user feedback, combined into this one bigger exploration called Copilot Workspace. And we were also talking to our users. Like we wanted to talk to developers, and we wanted to ask that, hey, we are building this thing. How would you like AI to support you? What are your major pain points? And a few things became very, very clear while talking to our users, right? So first thing is that the most difficulty that people faced was getting started on a task. Like, how do I know that an issue is assigned to me. How do I get started on it? Followed by, how do I trust the output of the AI? I don't trust it. And more importantly, they figured out that problem solving is what software development is about, and they would like to retain that problem solving aspects of it. And they would like the help of AI in the form of a thought partner or a sparring partner or a second brain which they can collaborate with to solve a problem. And lastly, and most importantly, they would like to retain control. Developers are in control, not the other way around. And with this feedback, we built Copilot Workspace. So what is it? It allows you to, it simplifies getting started. So one-click proposal on your tasks. It has a built-in runtime that allows you to quickly verify what the code that has been provided by the AI. It has an environment which is built for iteration. So if you feel that AI is going in the wrong direction, you can just go and quickly correct it. And most importantly, it is designed for collaboration. So you can just share your code or your work as a part of the GitHub pull request, or you can share your work or share your workspace with your colleagues if you're not comfortable with it. But enough talking, let's just get into a demo about it, right? So this is Monospace, which is another GitHub exploration. So if we are to write code, let's write code in style. And these are the is a family of Monospace fonts that has been released by GitHub. And this is a website that outlines a bunch of features of these fonts. And over here, somewhere over here, is this playground which says that, here are how the syntax highlighting looks across different languages. Notice that it is missing Rust. And Rust appears to be the next cool thing that all the cool kids are doing. So we would like to update this Monospace website with a Rust example as well. So how do I get started? So I've created this issue, or somebody has created this issue. It just happens to be me for the purpose of this demo, that I would like to add a Rust example to the font playground. And I can just click this button over here, and it will open the Copilot Workspace for me. And through the magic of caching, you can see that it quickly generates the specification and current specification and the proposed specification. Why caching? Because I had to finish this demo in time, but trust me, it's not a matter of hours. It does happen in a matter of minutes, right? And for those of you who are interested, I would like to do a live demo for you in the Microsoft booth after this task. All right, so what is the current specification? It just goes and figures out, does the website have this playground that contains a Rust package? And it says it doesn't, and it goes to the target state. What does the target state look like? And it says that, yes, the website will have this specific package for syntax highlighting. The website will have this package in package.json, and then I will update a bunch of other files. It looks nice, and I'll go and generate a plan for it. Again, through the magic of caching, a plan has been generated, and it will tell you that these three files need to be updated. And it appears that this seems to be at the right level of modality. Then I will go ahead and implement it. And yes, magic of caching again. What we see is the files that are over here. Now, this seems nice, but what about the iterative part? What you can do is, at any given point of time, if you feel that something is not right, you can just go ahead and say that, OK, add Rust to the language mappings, and say add code documentation. And you can edit at any given point of time. And what you can also do is that you can edit via chat over here, and you can say that, hey, I want to edit this one specific location. How do I go about and doing this? I'm not going to do this because it's going to go through the whole iteration loop, and then the illusion of the caching will break, and it will take a lot of time. But I would like to show that in live demos afterwards. But how do I trust whether this is, in fact, the right thing? So I will open up this integrated terminal, and I will say, install and run this repo. All right. So what's going to happen is that a suggestion is going to load, and apparently not the right thing. But I can quickly go and edit it and say that, all right, this is the command that I'm specifically looking for, and I can go and run. Now, this will run this command in an actual terminal, and we'll see the output in some point of time. And you can see that actually this code does compile. What we also have is a preview. What we can do is open the live preview. I don't trust it. It will say that it's just going to be a second, but it takes longer than that while that loads. What are the other things? One of the things that you would say is that, hey, you wrote a very simple command in the terminal. You said npm. You could actually type that thing in the terminal. And yes, you're right. I can type that thing. But think about that in a mobile setting, when you can open Copilot Workspace in a mobile on your phone. It becomes very tedious to type those symbols, right? And if you have used the mobile keyboard, it's not very useful for that. So what I'm going to, so that's why we use this natural language way of writing these commands in the terminal so that it can help you when you're on the go. It can synthesize those commands. And hopefully, the website has loaded. And there is a Rust example, right? Cool. There was a demo, and thank you. We are not stopping there. We are working on a bunch of these improvements, and I can talk about these improvements on one-on-one basis with you. And you already saw some of the improvements, like the runtime support to synthesize the terminal commands, and faster file completions using to make the Copilot Workspace better. But there are other next explorations that are also active, like how do we rethink the developer learning with AI, and how does the code review change if majority of the code that is now being written is by AI? So what does that mean? And some of these explorations will work out, and some of these explorations you will see as tech previews, and some of these explorations will kill because we don't know where they're going. So in summary, I'm saying that we do not know what the future of AI is, but what we know is explorations is the way to get it. And with all your help, we'll jointly explore this space so that we don't have to wait, like electricity, we don't have to wait for 40 years to get to a place where to get to a place with software development where we enjoy the benefits of AI. You have been a lovely audience. That is my time. I really appreciate you. And if you have more questions, if you want to have live demos, I'm available in the Microsoft booth in like 2 salons over that side. Thank you so much.
Okay. Thank you so much for that. That was truly incredible demo and some amazing work you guys are doing over there at GitHub Next. As Rahul mentioned, for all of our speakers today, we're not going to be taking live questions. So I'm going to ask you guys to go and find them after the fact. As Rahul mentioned, he'll be at the Microsoft booth over in the expo, and then we'll give you locations for the other speakers as they finish up as well. Next on, we have Kevin Howe. He is the head of product engineering at CodeGen. This is probably one of the most incredible pivot stories in AI of the past year and a half. Company used to be Exafunction and now one of the best code assistant products out there, actually voted by developers as the highest satisfaction code assistant product recently in a Stack Overflow survey, and just hit 1 million downloads in VS Code last month, which is truly incredible. So I'm going to welcome him to the stage, Kevin Howe, head of product engineering.
All right. Cool. Thank you, Rahul. We are going to kick it off with, let's see, make sure that's not my Slack up there. Cool. All right, all set. So my name is Kevin, and I'm going to be talking about how embeddings are stunting AI agents. So I'm going to let you in on some secrets about how we build the product and exactly what we're doing behind the scenes to improve your CodeGen experience. So at CodeGen, we are building AI developer tools, and we're starting with an IDE plugin. And as mentioned before, we've been downloaded over 1.5 million times. We're one of the top-rated extensions across the different marketplaces, and to reiterate, we offer free, unlimited autocomplete, chat, and search across 70 different languages and 40 different IDEs. So we plug into all the popular IDEs. We are the highest rated developer tool as voted by developers in the most recent Stack Overflow survey. And you'll note that this is even higher than tools like ChatGPT and GitHub Copilot. And importantly, we are trusted by Fortune 500s to deliver high quality code that actually makes it into production. And we do this with top grade security, licensing, attribution for some of the largest enterprises on the planet. Our goal at CodeGen is to empower every developer to have superpowers both inside of the IDE and beyond. And today, I'm going to let you in on some secrets about how we've been able to build a tool like this and why users choose us over the other AI tools on the market. And the short answer is context awareness. So here's a quick overview about what context looks like today. We're all familiar, since we're at an AI conference, with the basics of retrieval augmented generation, the idea being that a user puts in a query, you accumulate context from a variety of different sources, you throw it into your LLM, and then you get a response, whether that be a code generation or a chat message. Here's a concrete example about how retrieval can be used in code generation. So let's say we want to build a contact form in React. Now, you could go to ChatGPT, you could ask it to generate a contact form, but in reality, on a moderately large code base, this is really not going to work. It's not going to give you things that are personalized to you. And this is really where context retrieval comes in. We need to build a contact form that is in line with our design system components. Let's say you already have buttons and inputs. It has to be able to pattern match with local instances of other forms inside of your code base. It has to ingest your style guide. For example, if you're using Tailwind, you have to be able to detect and make the form look and feel like every other thing on your site. And then, of course, there's documentation both locally and externally for packages and other dependencies. So the question becomes, how do you collect and rank these items so that our code generation can be both fast and accurate for your use case? So to dive into a couple of different methods about how people are tackling this today, there's really 3 main pillars. The first one is long context. So this is the idea that if you expand your prompt window in your LLM, it can read more input and therefore be a bit more personal to what you're trying to generate. Right? You just shove more items into your prompt, but this comes at the cost of latency and financial cost. So one of the most recent examples was Gemini. Gemini actually takes 36 seconds to ingest 325K tokens. To put this into perspective, a moderately sized or even small repo is easily over 1 million tokens, and that accounts to about 100K lines of code. So in this instance, most enterprises have over 1 billion tokens of code. It's simply not feasible to be throwing everything into a long context model. The second method is fine-tuning. So for those that are familiar, fine-tuning is the idea of actually tweaking the weights of your model to reflect the distribution of the data that your consumer expects, right? And so this requires continuous updates. It's rather expensive computationally. You have to have one model per customer, and it's honestly prohibitively expensive for most applications. And finally, we have embeddings. And for all of you, hopefully you're familiar, this is a relatively proven technology today. It's pretty inexpensive to compute and store. But the difficulty that we're about to dive into is that it is hard to reason over multiple items. It also has a low dimensional space, and I'll talk about that shortly. So to dive deeper into embeddings, the whole concept is that you take your objects, you throw it through an embedding model, and then you end up with some sort of vector, some sort of array of numerical values, and this is in a fixed dimension. And so by mapping and chunking code, we can map it to an embedding, and that allows us to quickly search over our functions, our documents, whatever you decide to chunk by, and this is what embedding search is called. Embedding search, like I said, is not a new concept. There's a bunch of models that have tried to optimize, and in this example, we're looking at one of the kind of North Star eval benchmarks. It's become increasingly popular, and the question becomes, how do we fit millions of lines of code into an LLM model so that we can actually generate useful results? And so it's evident through the years that we're actually hitting a ceiling on what is possible using these traditional vector embeddings. And over time, even the biggest models are approximating to around the same level of performance. As you can see, everything's kind of within plus or minus 5. And at CodeGen, we kind of believe that this is because fundamentally, we cannot distill all the dimension space of all possible questions, all possible English queries, down into the embedding dimension space that our vectors are going to occupy. And so at CodeGen, we've thought very critically about what retrieval matters to us. Are we measuring the right things? And does semantic distance between these vectors really equate to things like function relevance in the concrete example that I showed earlier? And so what we landed on is that benchmarks like the one that I showed you before heavily skew towards this idea of needle in a haystack. It's the idea that you can sift through a corpus of text and find some instance of something that is relevant to you. Note, it is only one single needle. So in reality, code search requires multiple different needles, right? We showed that slide earlier. When you're building a contact form, you need all these different things in order to actually have a good generation. And these benchmarks really don't touch that. And so we decided to use a different metric, and it's called recall 50. The idea and its definition is that it's what fraction of your ground truth is in the top 50 items retrieved. So the idea being now we have multiple documents, and we're now looking at the top 50 documents that we retrieved. How many of those are part of our ground truth set? So this is really helpful for understanding multi-document context, especially, again, for those large code bases. And now we actually have to build a data set around this. And so this is where we did a little bit of magic. We wanted to make the eval as close as possible to our end user distribution. So we had to compile our own data set. So what we did, this is a PR that I put out a few months ago, we looked at PRs like this. It's broken down into commits. Those commits we can extract and actually match them with the modified files, right? So now we have this mapping from something in English to a list of files that are relevant to that change. And you can imagine we can hash this in many different ways, but ultimately the point I'm trying to make is we are creating a eval set that mimics our production usage of something like a CodeGen product. And so this message serves as the backing for this new type of eval, where now we can run at scale this idea of product-led benchmarks. It gets us closer to the ground truth of what our users are actually experiencing and what tweaks in retrieval will actually mean to the end product. And so we threw some of the currently publicly available models at this notion of retrieval, this idea of using commit messages. And we found that there is reduced performance. They're unable to reason over specifically code, but then also specifically this kind of real-world notion of English and commits, right? And so at CodeGen, we've been able to actually break through this ceiling. This is something that we've worked very hard at. We have to redefine exactly how we are approaching retrieval in order to be kind of in our class of our own, so that when you are typing in your ID, when you're chatting with our assistant, when you're generating autocompletes, we're retrieving the most relevant things that are for your intents. So now the question becomes, how do we actually get this kind of best-in-class retrieval? And so I'm here to give you the very short and sweet answer, which is we throw more compute at it, right? But of course, that can't come with absurd cost, right? Financial cost. So how do we do this, actually? In production, how do we actually do this without recurring an unreasonable cost? And so this goes back to a little bit of CodeGen's secret sauce, right? We are vertically integrated. And what this means is that we train our own models. So number one, we train our own models. This means that these are custom to our own workflows. So when you're using our product, you're touching CodeGen's models. Number two, we build our own custom infrastructure. This is actually a very important point and actually connects to the whole exafunction to CodeGen pivot that we discussed earlier. Exafunction was a ML infrastructure company. And so what we've been able to do is build our own custom infrastructure down to the metal. This means that our speed and efficiency is unmatched by any other competitor on the market so that we can serve more completions at a cheaper cost. And finally, we are product-driven, not research-driven. Now, what this means is we look at things like actual end-user results. When we actually ship a feature, we're looking at real-world usage, and we're always thinking about how does this impact the end-user experience, not just some local benchmark tweaking. And so we could spend all day talking about, kind of why CodeGen has done this and yada yada, but that's a talk for a different time. So I'm going to talk about something that I find very cool, and this is the reason why we've taken this vertical integration approach and been able to turn it into something that we call mQuery. So mQuery is this way of taking your query, so similar, it's that idea of taking your retrieval query. You have your code base, and let's just say you have n different items. And because we own our own infrastructure and train our own models, we're now making parallel calls to an LLM to actually reason over each one of those items. We're not looking at vectors, we're not looking at small dimension space. We're literally taking models and running them on each one of those items so that you can ensure, you can imagine, you run ChatGPT and tell it to say yes or no on an item, for example. That is going to give you the highest quality, highest dimension space of reasoning. This leads into very, very high confidence ranking that we can then take into account things like your active files, your neighboring directories, your most recent commits, what is the ticket that you're working on currently. And we can compile all this to give you, the top N documents that are relevant for your generation so that we can start streaming in higher quality generations, higher quality chat messages, things of that nature. And the reason behind this is, again, it's that vertical integration. It's that idea that our computation is 1/100th of the cost of the competitors. We are not using APIs, and as a result, our customers and our users actually get 100x the amount of compute that they would on another product. And so we're willing to do that. We're willing to spend more compute per user because it leads to a better experience. And so, like I mentioned earlier, I lead our product engineering team. So we always want to anchor ourselves around these three different things. One, that we have to build a performant product. It has to be really fast. For those of you that have used the product, you can probably attest to this. mQuery runs thousands of LLMs in parallel so that the user can start streaming in code within seconds, not minutes, not hours, seconds, and oftentimes milliseconds. It has to be powerful, right? None of this matters if the actual quality and the actual generations that you're building are wrong, right? And finally, it has to be easy to use. We're building an end-user product for people today that's in the IDE. Tomorrow, it might not be in the IDE. How do we actually build something that is intuitive to understand, that people can grapple with and see exactly what my model is thinking? And so because we have the benefit of distribution, we were able to roll this out to a small percentage of our users. And by small percentage, we're dealing in the order of million plus downloads. This actually reached a surprising number of people. And what we've been able to see is that we were able to successfully reason over these thousands of files in people's mono repos, in people's remote repos, and select what was relevant, right? We can very accurately deem which files are relevant for the generation that you're trying to have. And the result, as you can see, this is a real-time GIF, is both fast and accurate. So I'm asking for usage of an alert dialog. It's going through, and I think I panned down here. This is kind of a shadcn component that I've modified internally. We're pulling in basically the source code of what is relevant for our generation. And ultimately, the results of this experiment with that users were happy. They had more thumbs up on chat messages. They were accepting more generations. And we were able to see that ultimately, we were writing more code for the user, which is the ultimate goal. It's that idea of how much value are we providing to our end users. And so we built this context engine, right? This idea of mQuery, this idea of ingesting context and deciding what is relevant to your query to give you coding superpowers. And so our users will generate today, they're generating autocompletes, they're generating chats, search messages. But in the future, they're going to generate documentation. They're going to generate commit messages, code reviews, code scanning. They're going to take Figma artboards and convert them into UIs that were built by your own components. The possibilities are endless. But what it starts with is this bedrock, this very hard problem of retrieval. And it brings us to, again, one of the reasons why Codium is approaching this problem a little bit differently. Our iteration cycle starts with product-driven data and eval. So we're starting with the end problem. We're building a product for millions of people. How do we start with what they're asking for? And how do we build a data set and eval system locally so that we can iterate on the metrics that matter? Secondly, because we're vertically integrated, we're taking that massive amount of compute and we're going to throw it at our users. Paying or not paying, we're going to throw it at our users so that they can get the best product experience and the highest quality results. And then finally, we're actually going to be able to push this out to our users in real time, overnight, and be able to get a pulse check on how this is going. This is what we did for mQuery. And when we evaluate in production, we can say, thumbs up, thumbs down, and then hit the drawing board again, back to that same cycle, repetition. And so you can start seeing how these pieces of compounding technology come together, right? We've alluded to some of them today: modeling, infrastructure, being able to retrieve. But then it also includes things like AST parsing, indexing massive amounts of repos, knowledge graphs, parsing documentation, looking at websites online. The list can go on and on and on. But we're confident that we're solving these problems one piece at a time using that same iteration cycle, that same idea that we're going to take the distribution and knowledge that we have and that additional compute that we're willing to afford each user to solve each one of these puzzle pieces. And I want to leave you with a parallel analogy. So in my past life, I had experience in the autonomous driving industry. So to bring over a metaphor from that industry, in 2015, TechCrunch boldly predicted that that was going to be the year of the self-driving vehicle. It was largely, now we're in 2024, so we can look back in hindsight, largely untrue, right? We were doing things like sensor fusion, we were decreasing our polling rates, we were running off-board models, all this in the effort of making heuristics that would compensate for the lack of compute that was available because consumer graphics cards were not as popular or not as powerful as they are today. Fast forward today, we're seeing 100x the amount of compute available to a vehicle. You can take a Waymo around San Francisco, which I encourage you to do. It's a wonderful experience. But that means that we're actually able to throw larger models at these problems, right? More sensors, higher frequency. And now 2024, TechCrunch has released another article that said, will 2024 finally be the year of the self-driving vehicle? And we can now look at this pattern and say, driving performance was substantially better by throwing larger models, being able to handle more and more data. And so at Codium, we believe that this embedding-based retrieval is the heuristic. We should be planning for AI-first products, throwing large models at these problems so that AI is a first-class citizen. We're planning for the future. And finally, we also believe that ideas are cheap. I could sit up here and tell you all these different ideas about how we're going to transform coding and the way that the theory behind possible solutions. But what we believe at Codium is that actually shipping, actually showcasing this technology through a product is the best way to go. And so if you agree with these beliefs, you can come join our team. We're based in San Francisco. And you can download our extension. It's free. I'm not, obviously, I'm not advertising the core product nearly as much. We're kind of talking about the technology. But you can experience this technology firsthand today by downloading our extension. It's available on all the different plugins, VS Code, JetBrains, Vim, Emacs. And you can see how this infrastructure and the way that we've approached product development has shaped the experience for you as a user. And then, of course, you can reach out to me on Twitter. I put my handle up there. I'll be kind of floating around outside, so if you have other questions or are interested in what I had to say. But I hope that you learned something today. I hope that you use Codium, you try it out, and see what the magic can do for yourself. Thank you.
Thank you so much, Kevin. And you guys can find Kevin outside the salon after the tracks have wrapped if you have any follow-up questions for him. Next, I'm very, very excited to bring up to the stage Michael Truel. He is the co-founder of Cursor and previously created Halite at 2 Sigma, which is an artificial intelligence programming challenge back when he was an intern there, and it still persists today inside 2 Sigma. Cursor, as you guys may all know, is one of the most popular AI CodeGen tools out there right now. I can't count the number of Twitter mentions I see of the tool every single day, and on top of that, they count amongst their users customers like Shopify, Samsung, OpenAI, Ramp, Replicate, the list goes on and on. So very excited to be bringing up Michael to talk through this incredible product.
Can the audience hear me? OK, amazing. Great to be here. I'm also here with Swale, my co-founder. Thanks for having us. We're going to talk through Cursor and give you a high-level sense of what we'd like to do over the next few years, and then do a little bit of a deep dive into some of what we've built so far. And then, if there's time, we can take audience Q&A at the end. And so here on the first slide, this is to set up kind of the problem that we're nerd-sniped by, which is, what does programming look like in the age of AI? And to frame this, this is a little bit anachronistic because no one really wrote x86 and they didn't do it in terminal.app. But on the left here, sort of in the 1980s, before then, we had machine code. And then over the next many decades, humanity invented things like high-level programming languages and syntax highlighting and navigation features and lints to make building software much easier. And this transformed developer productivity. And so over the next 5 to 10 years, we think that level of a productivity jump is going to happen many times over in a much more compressed time frame. And we're really nerd-sniped by this problem of what is the equivalent of a high-level programming language? What is the equivalent of all of this tooling around programming languages in the AI age? And so just to frame the problem and talk a little bit about how some other folks are thinking through it, I think that in the popular discourse, there are kind of, by and large, 2 ways people are approaching the problem of how does AI affect programming. One is this kind of agent approach, which seems to advocate for programming kind of goes away, ceases to exist as kind of a high-level profession. Anyone can build software. And mostly the way we build software will be through PRDs or chat messages that then get turned into code bases or big code changes. And then on the other side of things, there are folks who are building really useful plugins to existing coding environments and are kind of nipping at the edges of, we can make ghost text autocomplete better, and we certainly can. And we can optimize the developer experience in little ways. And to contrast this with how we're thinking through the problem, we think that programming is still going to exist in 5 years. It will still be a profession. Programmers will still be paid a lot of money. It will still be a technical discipline. But it's going to change a ton. And it's not going to demand just a plug-in to an existing coding environment. It's going to demand an entirely new tool for doing software engineering. And so this focus on really pushing the ceiling of the amount of work the tool can take on while keeping the programmer in the driver's seat is our focus as a company. And so to talk through a little bit what we've built so far. So we've built, our product is called Cursor. It's a code editor that's built for programming with AI. And our goal is to be the best tool for professional programmers to use AI. And so far, we've focused on a few areas, mostly around code writing and Q&A. And I want to talk through a couple of the pieces of things we've built in the code writing bucket, because they also kind of illustrate why you would need a new dev environment for this, and not just to plug into an existing coding environment. So one is we focused on predicting the next move of a programmer in a code base. And this started with great work from folks at Copilot with ghost text autocomplete. And we took this idea to kind of the next level of, if you're a programmer working within a code base, you're not always just typing characters after your cursor. Sometimes you're jumping to a completely new place. Sometimes you're doing a diff. You're deleting lines. You're inserting code in different places. And so we trained a model to predict your next edit within a code base and the next place you're going to jump to. And the result is an autocomplete system we called Copilot++ that can predict these things. And kind of the second piece of the product I want to talk through is called Command K, which lets you go from instruction to code and select a part of the code base, ask for it to be changed, and then iterate with the AI on that block of code. And Swally can talk through some of the technical details of how we went about building each of these, both on the model side of things and also maybe on the editor side of things too.
OK, so Copilot++. So it started off with, when we first wrote our vision for what we wanted to do, the first line in there was like, oh, Copilot should do your next edit. But over the next couple of months, every time we would prototype something, it would include something like strike-throughs, or it would move your cursor a ton when you were typing, and that was super annoying. Or the model just wasn't accurate enough. Around October and November of last year, we had a couple of very interesting breakthroughs. One of them was learning how to use the trajectories of programmers. So, you go from one file to another file, using commit histories to learn how programmers do diff after diff after diff of these coherent edits, and then learning a model to predict them. And combined with them we had to come up with this side-by-side edit UX. And the nice thing about it is super easy to both parse, but also it's not something that's super intrusive when you're typing. On the Command K end of things, the super interesting problem for us was how to make it both low friction, so you could, if you have an instruction you want to type in a couple of characters, you can do it very quickly, but also just pull in context from across your repository or across your recent files so we don't make a mistake. We still are on the journey for making both of them even more accurate, and every couple of weeks we have either new model updates or new context updates. If you used Cursor 6 months ago, I'd recommend trying it again, and you'd find it both much faster and also much more accurate.
Yeah. And both of these, both of these pieces of code writing are just the beginning. They're also, in addition to what Swally said, which is, we're always optimizing the background context building for these things. We're optimizing the models. We're optimizing the UX in little ways. These, we think, are also the start of a journey when it comes to the final form factor for what programming looks like with AI. Two directions that we're especially excited about in the future, in addition to building off of these. One is under the bucket of making programming feel like writing and reading pseudocode. And so you're already seeing the right side of things here, where now the keystrokes people are typing in their code editor are not really corresponding to Go and Rust and TypeScript. People are writing things that are much more terse and kind of look a little bit like gibberish, and they're getting expanded into code by the diff-based autocomplete. Or they're writing higher-level instructions, and they're getting turned into code changes by Command K. And then on the read side of things, one thing we're experimenting with is, are there times when it makes sense to trade off the formalism of a real programming language with concision? And sometimes it might make sense to give the programmer kind of a slider that lets them control the level of abstraction of the code base that they're looking at, and lets them look at something that looks a little bit more like pseudocode, and lets them both read and use that for navigation, and then also edit that and have the changes get made down at the source code by the AI. And so this idea of still giving programmers control, both control over the level of abstraction and also letting them gesture at specific instructions in a code base instead of stepping back and having to write something like a PRD, which is very divorced from the code, is an example of one of the things, sort of the idea space that we're really interested in. And then another bucket that we're super interested in for the future is letting the AI do kind of constrained tasks in the background. Like I mentioned before, there's a lot of interest in agents having bots do things end-to-end, use tools, maybe go from a PRD to an entire code base or a big set of code changes. We think that for professional programmers, for a long time, the tech's going to need to progress before we can really talk about end-to-end automation of PRs. And instead, in the meantime, the way that this technology is going to be deployed is you're going to really constrain what the AI can do. Write the interface for a method or a class and ask the AI to go implement that. And then you can go use that method or class yourself. But give the AI more of a latency budget, 5 minutes to go implement that stuff instead of the 10, 15 seconds that are required if you're working with it in the loop. And have a constrained agent go and work on that code. And already, both here on the pseudocode side of things and especially on the constrained background agent side of things, we have internal experiments that look very promising. And so maybe to talk a little bit through kind of some of the tech aspects of what's been required of us, to build both Copilot++, Command K, these next action prediction and instruction to code, respectively, features, and then also the Q&A and chat and debugging features that we've built so far. A lot of tech has been required to kind of do this vertically integrated full stack AI product. So as Swally mentioned, we've done a lot of work on the next action prediction model that's powering Copilot++. The way that started was, we started by trying out-of-the-box models on this idea of predicting the next action that a user is going to take in a code base. And the problem was the models weren't that accurate, they were expensive, and they were slow. And so we started with having small curated data sets and doing a parameter efficient fine-tune to take some of the out-of-the-box models and make them better at this objective. And then we went even further, and we started to get the open source models to be good at this objective. And now we have very small models that are very, very good at this next edit prediction objective. And we've also spent a bunch of time optimizing the inference for these models too, where when you're rewriting code, often one thing you waste time on when you're rewriting code is the unchanged parts of the code. And so there are things you can do in the inference environment to kind of jump over those unchanged pieces. And then you want to talk through some of the other kind of technical points here?
One of the things that we found really interesting was every time you would open up a code base for embeddings, for almost everyone, things would be super duper slow. If you opened up, the SQLite repo, or if you opened up a much larger repo like LLVM, you would end up in the situation where like LLVM would take hours and hours and hours to upload, which is just kind of unacceptable for us. So we had to build a very performant, file syncing engine that sort of syncs embeddings across the server. It can generally do something like 1,000 files over a few minutes. If you're like Instacart and have like hundreds of thousands of files, it will take like tens of minutes, but it's not something that would take days. And when you do edits on that code base, our embeddings sync extremely quickly. And that means that your context is almost always very real time. And it's not going to be something where you check something out and it's like not updated for an hour or so. The other things we've sort of done that I find most interesting are a lot of model caching tricks that rely on both the code editing features, rely on how the models sort of relate to each other. So in a general code base, a lot of the files have links that come from go to definition, links that come from a lot of the semantic features of a language, and using that to actually build context has been something that's been super useful for us. Yeah, I guess I'll say one last thing about remote performance profiles, which, when you're building an editor, you're not only working on the sort of AI side of things. We found it incredibly important to both make Cursor really fast, and that's something that both the VS Code team works really hard on, but that's something we've sort of developed our muscle in as well. So if you, hopefully will come work for us, you not only work on the AI side of things, but also on, building a performant editor that shipped to hundreds of thousands of people, which is just an interesting development problem in and of itself.
Yeah. And maybe just to wrap it up here, as a shameless plug, we're always looking for brilliant people to join us. We're a really small, talent-dense team, very in-person, based in San Francisco. And we're looking for both talented, creative people on the design and product side of things, and also people all on the other end, on the research scientist side of things. Because as mentioned, we're working on the full stack. We want to build the tool when it comes to, down to the interface and figuring out what programming is going to look like there, and then also working backwards and building the most useful tech for people. And sometimes that requires using the biggest, smartest models. Sometimes that requires using models that are really specialized to a particular task, are very fast and very cheap. And so, to leave you with this, in the next 5 years, we really believe that it will be possible to build a tool that automates almost all of software engineering as it looks like today and transforms the discipline of programming into one where individual engineers can build systems that are much more complex than even entire engineering teams can build today. And TBD will be the ones to execute on that opportunity, but that's one that really excites us. And we wake up every day passionate to try and solve that. So if you want to join us, the best way to reach us is at hiring@anysphere.inc. And thank you all for your time, and happy to take questions if we have extra time too.
Mic back. Thank you. Thanks so much, guys, for going through that. Yeah, we do have, I think, 3 minutes-ish left for Q&A. Oh, we have one already here in the front. OK, I will.
I just want to, first off, thank you. It's probably been the most productive year writing code in my life, in part, partly because of Cursor. For folks who have started playing with it a little bit, maybe use the chat, ask it to write things, paste in the chat. What are some more advanced techniques of using Cursor that you've discovered beyond the obvious of just moving code from the chat into or using Command K, et cetera?
It's been really interesting seeing the different ways that people end up using the tool. I think Cursor is a pretty powerful and full-featured tool at this point, and there are lots of hidden features as you dig more and more into the tool. So for instance, on the chat side of things, one thing a lot of folks do is these models often output code blocks in chat, and they output kind of shorthand code blocks with ... dots interspersed. And taking those code blocks, actually putting them and implementing them in your code base can be a bit tedious. And so we have specialty models, for instance, that will apply those code blocks from chat. I would say kind of the 2 features we listed today and kind of dive deep into. One of them a lot of people know about, but maybe less than the entire user base, is Command K. And so often that inline code editing is way more ergonomic than going to something like the chat and then having to apply changes from chat and going back and forth. There are also some hidden debugging features too. So if you get a stack trace in the terminal, we have this kind of a specialty loop to help you debug that. And if you run into really thorny linter errors, we have a way to basically debug those too. You have to kind of hover over things to discover that. But by and large, right now, the most useful parts of the product are this next edit prediction with Copilot++, Command K for writing code, and then chat for Q&A and asking questions about a code base.
Any more questions? I think we have time for one more, maybe 1.5.
Again, some work on the product. My question is, do you run personalized models? I'm finding more and more that it feels like it knows what I want to do next.
Hello. Oh, OK, my mic is enabled. We've done a ton of work on the context building side of things. So it's not that models are being edited in the weights per se, but we're using the in-context learning abilities of these models to find the parts of the code base that are most relevant to your task or query. And that goes into both the next action prediction, next edit prediction side of things, where we're looking at your revision history and we're trying to figure out the next thing you're going to do. So if you're in the middle of a refactor, that model's really good at figuring out, hey, out of the last 200 lines you changed, what were the most important 15 that gives me a sense of your intent? And ditto for chat and Command K, it's figuring out the parts of the code base, the building blocks that are most relevant for writing the code you wanted to write or answering the question that you have.
For the future, one thing I'd like to comment on is sort of a nerd snipe would be 2 problems we're very interested in the sort of personalization end of things. Is one of them is, can we run some sort of agentic loop in the background that's building context for you while you're asking questions? And then the second problem that we're really interested in, can we make a model learn your code base? So if you have research ideas for actually learning a really large code base, in which case you might be sort of start getting inaccurate when you do retrieval. And we're super interested in if you have ideas.
Awesome. Well, thank you so much, everyone, for the time today. We had some incredible speakers here. As mentioned, please do feel free to find them after the fact. Rahul said that he'll be over at the Microsoft booth in the expo. Kevin will be around here. And I think the Cursor guys will be around here as well. Thanks again for attending.
I already have so many web tools that I have to sign into. Some of those apps work better on some machines than others. Sometimes there are restrictions on what websites we can and can't visit from within the school. But I can always send an email.
Tell me that you wanna stay, baby, just don't walk away.
Hey everyone,
Need
I'm
you
Aditya
now.
Advani, an AI engineer based in
Faded
San Francisco. Along with my teammates, I created Math Matrix movies at a hackathon in SF on May 11th, 2024. Today, I'd like to show you what our project can do because I think it's really cool. What it does is that it generates really cool math explainer videos in a truly unique style that is able to get concepts across visually. This is something that I think is really unique that you may never have seen before. So, AI hackers, let's
to find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we grow. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we grow. Sometimes we hold on to let go. Sometimes we hold on to let go. Sometimes we hold on to let go. There is nothing lost between us. And oh, I know you have your reasons. Some days I'm a mess, but I know there's a rainbow over all of the past. Your head on my shoulder, but I know we're better on our own. But this is how we grow. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we grow. up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. starving for something you can't touch, would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technological advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technological advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Tell me that you wanna stay. Baby, just don't walk away. I need you now. Fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down. I need you now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. Tell me that you wanna stay. Baby, just don't walk away. I need you now. Fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down. I need you now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sunsets in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. your door? Would you follow me to better places if I find myself at your door? Got the keys, let's go, I wanna taste this. If you showed up at my door, I would follow you to better places. If you showed up ready, let's go, oh, oh, oh. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll dive in and I'm ready to holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding a match, strike it and ignite. find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we grow. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we grow. Sometimes we hold on to let go. Sometimes we hold on to let go. Sometimes we hold on to let go. There is nothing lost between us. And oh, I know you have your reasons. Some days I'm a mess, but I know there's a rainbow over all of the past. Your head on my shoulder, but I know we're better on our own. But this is how we grow. Gotta give it up, sometimes it's gold. been turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. that you're starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Tell me that you wanna stay. Baby, just don't walk away. I need you now. Fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down. I need you now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. Tell me that you wanna stay. Baby, just don't walk away. I need you now. Fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down. I need you now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. On top, so I'll dive in and I'm ready to hold my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll dive
Thank you, everyone, for coming to the afternoon edition of CodeGen Talks. Very excited to be with an incredible group of speakers today for this afternoon session. My name is Brittany. I'm a GP at CRV, also known as Charles River Ventures. We're an early-stage venture capital firm that's been around since the 70s, so actually one of the older funds in the country. We do primarily seed and Series A investments, and I specifically focus a lot of my time on software infrastructure, hence being here with all of you today. To give you some interesting facts about CodeGen today and about what they're working on, have very exciting speakers here, starting off with Quinn Slack from SourceGraph, Morgante Pell from Grit, and lastly, Gunjan Patel from Palo Alto Networks. With that, I will have Quinn come up here on the stage. Quinn is the co-founder and CEO of SourceGraph. He also previously co-founded Blend. He has been building the company SourceGraph since 2013, so definitely an OG in this space. A lot of folks, and most importantly, he was also the first employee of Bleacher Report, which for those of you who are into sports is one of the primary sources for all of us today. So with that, I will bring Quinn up here to the stage to talk about why the AI Emperor has no DAUs.
Thanks. All right. Thank you, Brittany. It's great to see you all. Again, I'm Quinn Slack. I'm CEO and co-founder here at SourceGraph. And yes, I was at Bleacher Report. I think I learned I'm better coding than doing sports, so I'm in the right role here. I want to talk to you about why most devs still do not use Code AI. It's probably a mind-boggling fact to all the people in this room, but it's true, and we'll have a good discussion about that. I'm a coder. I code all the time. Been building SourceGraph, which is code search and code AI for devs since 2013. I merged 4 PRs earlier today, but I want to talk mostly about the product and what to build and how to get it in the hands of users, because if you don't do that right, then all the code that you write is for nil. So 3 points I want to make. One is that most devs don't use Code AI. I want this to scare you. I want to scare you in this talk, and then I want to share some of the mistakes we made and some of the tips from our experience doing all the things wrong and then trying to figure out how do we do it right at SourceGraph as we've been building Cody. All right. First, just show of hands here. Who in the last week has used any kind of Code AI tool while coding? All right. Man, I wish the whole world was like this room, but we are in the heart of it in San Francisco. And the whole world is very different. Most devs do not use Code AI. And I'm going to give some numbers here. I'm privy to a lot of private information and stuff that I've heard as well. And all of this is in line with what I've been hearing. So first number. Oh, man, this is a great statistic. 92% of devs use Code AI tools at work. Wow, that means these tools must have tens of millions of users. This was a study from GitHub, 500 people. Well, it turns out this is only in the US, and they had a very broad definition of what it means to use a Code AI tool. So here's a case where the hype kind of outstrips the reality, a common pattern. This is an infographic from GitHub. 70% of developers see a benefit to using AI coding tools at work. Surely if there's a benefit, they must all be using these things, right? I mean, if only it worked that way. All right, some numbers for the broader universe. There are 1.3 million paid subscribers to GitHub Copilot. This was what Microsoft reported in January 2024. 1.3 million is a lot, but if you're just paying for something, are you actually using it? And also, 1.3 million is not a lot compared to all the people in the world that write code. And there's actually a way to get an even finer point on that number. GitHub released a study saying, if you look at the fine print, that in this time range, this year, 935,000 devs received a suggestion, not even accepted it. So there's going to be some that saw that little ghost text in their editor and never actually accepted it. And also, that's yearly active users. I don't know of any companies that go and cite yearly active users. Surely the monthly active users and daily active user figures are much lower than that. So these numbers are, pretty. You could fill a city with these people, but it's not that many people when you compare it to the 26 million professional developers in the world. And I think this is an undercount. I will say that, how do you get this number? I Googled a bunch of different stats, and they all were around this. So, that's the vibes citation there. There's a lot more people that touch code in some way or another. Again, it's really hard to get a number on this, but I'd say probably 100, 150 million people in the world touch code in some way. And that includes students and other people and so on. So, 935K, best case, what is that in MAU? That's tiny compared to the number of people that interact with code. So this is the scary thing. My best case estimate is that around 5% of professional developers use Code AI. These are people that are paid a lot of money to write code, and they do it all day, every single day. And all of us here in the room, we know that there's this amazing new alien technology that's dropped on Earth, and that it changes how we code, and 5% are using it. That's crazy. That means in a room of 20 people, 19 are not using this. It just absolutely boggles my mind, and that's a huge problem. And it's an even bigger problem because if you look at what they're actually using, the vast majority of Code AI use is just autocomplete. It's the ghost text. I mean, yeah, that's good, but anyone who has used anything beyond that knows that AI can do so much more when coding. It can write entire files, it can answer questions, it can fix bugs and all of that stuff. So this usage is absolutely tiny, and we need to realize that we here in this room, we are all the freaks. And for us to be successful requires us to change a lot of minds out there in the world. So how do we change those minds? Well, we've been building Cody. Cody is a Code AI tool. It does all of these things. And so we encounter a lot of reasons why people are hesitant at first. And I've taken the reasons from our own internal tools and ranked them. Why don't most devs use Code AI? The first one is just, they don't have a good reason. There's some people in the world, believe it or not, that have not used ChatGPT, that have not heard about it, even devs. There's a lot of devs who are kind of grumpy, and they say, well, it's not perfect, I tried it, and it gave me a wrong answer. Yeah, no shit, but there's a lot of other people that have figured out how to get the right answer out of it. A lot of people say, I don't need it, it didn't help me that much. Again, you got to figure out how to make it useful for you. A lot of people's company hasn't adopted it, it's too expensive, or one thing we're seeing a lot less of now is these security, privacy, and legal concerns. I think it's a situation where enough people are using it so that if it's illegal to use Code AI, then we're all fucked, so it's mutually assured destruction. But there's a lot of reasons why people don't use it yet. And this should really scare us, because there's a lot of companies that are relying on a lot of people at a lot of enterprises using Code AI. There's a lot of people's retirement accounts or option trading accounts or whatever that are also relying on that. And if you think about how technology makes money, I mean, the money that gets deposited into your bank account and your paycheck, where do those dollars come from? It takes, kind of a long route. Just to explore the market a little bit here, you've got these foundation model companies like OpenAI and Anthropic at the top. And then you have the AI infra companies. And the AI infra companies, they will send, if they're serving and doing inference, they'll send some of the money back to the foundation model companies. In some cases, they're the same companies. And what drives usage of that? You have some experimental usage, people being the looky-loos, going and trying it out. That will turn into some experimental revenue. But all of that can happen without any real actual usage. But that gives the perception of, holy shit, this stuff is hot, this stuff is working. And then you start to get some real usage. Some people using it, maybe paying $20 a month on their credit card. You get some devs using it at work. And then the holy grail, the way that software makes money, is from enterprises where there's recurring revenue from real usage. That first year contract, it doesn't matter. It's got to be JP Morgan pays you $1 million the first year, and then they renew for $2 million the next year. And all of the money in our paychecks ultimately comes from that. If you're working at an AI infra company, if you've raised money to go and sell some AI product, it's ultimately because someone out there thinks that 5 years from now, JP Morgan is going to be paying you $2 million a year. So that's the only thing that matters. Everything else is downstream of that. And it turns out there's just not that much of that going on. And also, this is an even more lopsided pyramid than I've depicted here. We got NVIDIA and chip makers at the top, and so much investment riding on it. So, this is where we ultimately need to get to. We need this person to be using our software. And maybe it's not the coolest thing out there, but that is the reality of how technology makes money. And I want to put some numbers to this. I estimate, based on my internal information, some of the information that GitHub has shared at this conference, that the total recurring revenue from Code AI usage is around 300 million ARR. Now look, that's a lot of money. If you had a company that was doing that, then it could go public on its own. So that's good. But how much of that money actually goes to these other companies? Not that much. From our own data at SourceGraph, where we spend a lot of money on AI inference, we spend less than 10% of our revenue. So if you take that number, and by the way, we're not even doing it in that optimized of a fashion. If you take that 300 million number, 10% of it, that's $30 million going back up to these foundation model companies and AI infra companies. It's a long way from where we are today, that amount of revenue, to them making the kind of revenue that's going to justify these massive multi-billion-dollar valuations. Also, another way to look at it is Salesforce. Salesforce's annual revenue is $36 billion. All of this stuff, all this hype, all this usage of Code AI, it's amounting to a tiny, tiny fraction, 1/120th of Salesforce. So we have a long way to go. Usage needs to grow a lot. Or I could be wrong, and maybe the doomers are right. Maybe not for the reason they thought. Maybe we should never have done this, and this is all just going to be one massive hype bubble, and it's going to pop, and we're all going to be miserable. But I think, because I use Code AI every day, obviously, and you do too, this stuff is real. It's really early, and usage needs to grow a lot. So if you're building a product, keep that in mind. This is what I'm betting on. And let's talk about some of the lessons from our experience building Cody at SourceGraph. I wish I had this mindset going into it. Just quick background to establish, why would you even listen to me? Maybe I should have done this in the first slide, but hey, here we are. SourceGraph has been around, as Brittany said, for 10 years. We started out with code search, and then we found out that if we had this tool that all the devs used and had all the code in a company, and it turns out that was amazing context to build a Code AI on top of. And so we took that and we built Cody. It's got really great autocomplete and inline edits, generating unit tests, and chat. And chat is where we really differentiate, because that's where you can make the best use of context. So you can figure out, why is this broken? Or how do I change this? Or where should I start on this? That's where we excel. We've got a lot of really big customers. We have 4 of the top 5 biggest banks in the country. We have most of the FANG or Manana companies or whatever, and a lot of other great customers, including some that are presenting today. And we are the number 2 Code AI company in revenue, second only, of course, to GitHub Copilot. But because we're number 2, and because we're a startup and we're scrappy, we try harder. All right, so what have we learned? One is that hype fools everyone. Hype fools us. Hype fools all of you. Hype even fools your customers. And the second thing is that AI code completion, the thing that auto-completes the rest of the line or the next few lines, that's like the freakish kind of feature that comes along like one time in 100 years. And we kind of got spoiled. It is so perfect. So I'll get to that. But first, just on the hype, how do you get away from being fooled by the hype? I'll share a few tips that have worked for us. The first, and this is the most important thing, if you're building a product and you are not using it every single day, it is not going to make it. There is zero hope. If you're building it on a team and the people all building it don't use it every day, your customers will not. But they might say it's really awesome, and that's the dangerous thing about this hype. Customers don't know what they want. Every customer for about a year said, I want fine-tuned models. They said that all the time. Our salespeople would say, hey, we need to build fine-tuned models. Everyone was talking about it. GitHub Copilot has it as a bullet. All of our competitors have it as a bullet that's like italic and it's like coming soon. It's some bullshit thing. Really what they just want is they want it to work well. And they use some of these terms. So don't listen to them, because what they're saying is probably downstream of them sitting at some conference like this and getting some cool ideas. They want the product to work. And if you can't describe why it works and why it's great without using the word AI, then you're probably not going to make it. This is a really existential question. So we make a product that makes developers a lot more productive, like 20 or 30% more productive. If it's so damn good, why are we selling a product? It's like the people that have the stock picks and sell newsletters. Why don't we go and buy a software outsourcing firm and prove it and monetize our product by actually capturing that value directly? That's a damn good question, and I wish that we had done that a year ago, and we're looking into doing that now. And if you don't have the confidence to go and do that, to put a few $1 million behind that, if you've raised a bunch of money, then I'd say your product's probably not ready yet. And then finally, I think we've all seen this. This is actually not even one of the worst ones. This is a tweet that's got a lot of activity, right? Just keep in mind that that does not translate into DAU, so don't feel shitty about yourself all the time. I wish that Elon would add something like this that would actually tell you the DAU of the products that are getting all this hype. But until he does that, you can imagine it. All right, I talked about autocomplete being this freakishly good feature. Here's how we think about features at SourceGraph, this kind of 4-box. You want to be in the top right, and that's where it's an AI feature that doesn't take a ton of time to see is that correct, and it's really easy, and it's used often. AI autocomplete is great because it's literally every keystroke, and you can glance at it in a few seconds or even milliseconds, 100 milliseconds. You can figure out, is this correct? So that's a really good property of a feature. And it just so turned out that the first feature of Code AI happened to be smack dab in the top right. It's pretty amazing. But most other Code AI features do not have this level of product market fit, and we need to realize that. Now, we can work on it, but where's chat? Not used nearly as often, and it's harder to vet that long response edits, similar. I know a lot of people love doing the inline edits like meta K, option K, and Cody and cursor and things like that. It's great, but we got to be prepared for what actually works being a very different form from what exists today. Then there's a lot of other stuff, like the agentic stuff. I mean, look, it's obviously the future, but it's just not there yet. Who here has used a Code AI agent to actually merge a PR in the last week? All right, cool. Thank you for helping us, push the world forward, but it's not there yet. And, other features, you really got to go for that top right and drive any feature you make to the top right, and if not, it's just not going to make it. So what are we doing at SourceGraph to address this? Well, we are searching for that next great Code AI modality. What's the next autocomplete? There's some ideas like the next edit suggestion or like Copilot++. I'm skeptical of that. Chat. Steve Yegi, who is at SourceGraph, he just wrote this great blog post about chat-oriented programming, CHOP, where it turns out there's a lot of devs who have a chat session running in Cody or even ChatGPT or something all the time while they're coding, and it's just one ongoing conversation. It's a totally new way of coding, and what's weird is it's like the Gen Zs who do it, and it's like the 50-year-old disgruntled programmers who do it. So I love that it's got kind of some usage in both generations. There's new ways that people are going to be using Code AI that we have not even thought about, and it's so early to the previous point. We always got to remind ourselves to build the manual and explicit thing first. We got spoiled by autocomplete. It's automatic, and it just triggers every keystroke. No, first you got to make something work in manual and explicit mode. If you have chat, you got to make it so people manually mention the context they want before magically inserting the context. If you've got an agent, put it in the editor and make it work in the editor so that if it's wrong, the dev can just change it right in their editor instead of having to go into code spaces or some other totally different UI. So make it manual and explicit first and really easy for the dev to go and fix it. And then you can add the magic. Probably, you're going to be bogged down enough with stuff to make it a great product and you won't actually get to adding the magic for a while. When you're pitching, always explicitly de-hype and set expectations low. No matter how much you de-hype, the person receiving it, they will hype it up in their minds. So you gotta remove the hype. Do this so aggressively. And here's an example from Sam Altman. This is a tweet, I don't know, like a year ago when ChatGPT had probably tens of millions of DAU. So he's right. We know he's right. And if he's saying this and his product has way more validation than your product, well, you probably should be saying it 10 times more and 10 times more intensely. Also, it's kind of cool marketing and it makes you seem cool. Yeah, you got to become, here, it's covered up. You got to become a DAU yourself or kill the product. And then the last thing is just that as an ecosystem, all these foundation model companies, all these AI infra companies, all these AI applications, we all live or die together. Anthropic and OpenAI and Mixtral and Fireworks and all these great companies that we use are not going to get paid if we're not in business making a shit ton of money on Cody. So we all need to work together and realize that we all have so much to benefit from this stuff actually being used, from turning down the hype and building great products that get actual devs using it all the time. And that starts with you if you're the one building the product. So thank you. And if you want to reach out to me, there's my contact info, and happy coding.
Thanks so much, Quinn, for running through that. I love to see a presentation that actually de-hypes this stuff versus hyping it up more. Next, we're going to have Morgante Pell come to the stage. He's the founder and CEO of Grit. He actually also has a wilderness first aid certificate, so a man of many talents. One exciting recent development with Grit, they open sourced GritQL in March, and it's seen tremendous adoption in that time frame. I'm sure he's going to go into that and many other elements of the Grit product that they're building. So with that, I will leave you to it, Morgante.
Cool. So I'm Morgante. I'm the founder of Grit. I'm going to be talking about code generation and maintenance at scale, or CPUs still matter, and what it takes to actually make one of these agentic workflows work in production. Quinn was talking about how most people have not merged them. That's 100% true. Grit has probably merged more PRs than any other company in the world at this point, because we focused very narrowly and have done a lot of work above the model layer, and we're going to talk about how we did that. It's helpful to know why I started Grit. My background is all developer tools. I've been working at Google Cloud for 5 years and built a lot of stuff on the DevOps layer, right? Thinking about Kubernetes and how do you orchestrate very large-scale systems, working on tools like Kustomize or Terraform templates. And one of the biggest things I learned from this was how rare it was for a customer to come to us and ask for a brand new application, right? People didn't come and say, I want to build a new app on Google Cloud. It sounds cool. 90% of the time, customers came and said, I have this line of business application that is doing $100 million in revenue. How do I run that on Kubernetes, right? And that's what all of our templates did. That's what everything we built in the sort of pre-AI era of automation was all on how you ran existing applications. And that's why we started Grit, because every demo that you usually see that's hyped, one of these ones on Twitter, it's usually type a prompt, get a new application from scratch, right? Build something brand new. It's exciting. It goes really well on Twitter. That's not what devs do day in and day out. Developers spend most of their time modifying huge applications so that flights run on time. And this goes into 3 sort of categories of developer tools, right? There's IDE developer assistance. This clearly has the most product market fit today. It's really easy, right? Like I was saying, you just do autocomplete, right? That's a very simple thing. Then there's AI agents that are focused on lowering the floor, right? They're allowing people to do tasks that they otherwise don't have the skills for, right? Allowing a product manager or other non-technical user to build an application that they don't have the skill set for. This is powerful, but I actually am pretty skeptical that that's how most software is going to be built in the future. It requires a real thinking of how do you actually spec things out, how do you think about edge cases, basically how we train as engineers that's required to build great software. Which is why with Grit, we focus on raising the ceiling of what great engineers can do, right? Principal engineers, the most high-level engineers that you work with, they're primarily limited by time, right? They can't be in 10 places at once. But AI agents can be in 10 places at once if there's the right engineer controlling them. And that's what we focus on, is supercharging the productivity of the top 1% of engineers. It also helpfully gets around the problem of 95% of engineers not using AI. The great thing about Grit is 95% of our customers, 95% of their engineers don't touch it, right? There'll be 100 engineers on the team. They're not using Grit. There's one engineer who is deeply embedded with Grit and is generating hundreds of PRs with their agents. But to do this, tools need to change, right? The IDE that you have today, it's a scalpel, right? It's focused on editing individual lines of code, and it's great for that, but it's not focused on editing hundreds of repos at once. It's not focused on how do you open 1,000 files and make those changes in them, and that's why we built Grit. It's basically we want to have bulldozers for code, right? If you're generating huge quantities of code, how do you push that around in an effective way when you're not editing individual lines, when you're working on a higher level of abstraction? And this is super necessary, right? We've seen an explosion in how much code is being generated. A lot of our customers are seeing 20 to 30% more code is coming out of their teams now, just because there's more PRs, there's more CI, there's everything's running because you have CodeGen. And this is just going to accelerate, right? Once we go from 5% to maybe 50% of people actually using AI, there's going to be way, way more code in the world, and we need better tools for managing that code once it's in production. So just to give an example of what this looks like in practice. This is a real customer that we had. They have been around. They've got thousands of repos. They've got thousands of developers. and they wanted to use OpenTelemetry instead of logging, right? This is traditionally a massive effort, right? You have to coordinate across hundreds of teams to get them to understand OpenTelemetry, to understand how to instrument their code. You have to get them to do actual code changes, to swap out their logging library. You have to do a bunch of education efforts. And it's actually very much a people and process problem usually, right? Something where you have a program manager who has a massive Excel spreadsheet. That's what I say, like, Grit we compete with is actually Excel, not any other AI dev tool. It's that you have these spreadsheets where you go and manage these changes, right? And tens of thousands of developer hours go into a change like that. So a lot of companies just say, you know what? That's not worth it, right? I'm not going to migrate to OpenTelemetry. I'm not going to go into the cloud. I'm going to stay in my older ways. You know, people still have millions of lines of COBOL because it's just so much work to do this kind of coordinated change. With Grit, you don't have to do that coordination effort, right? Because you can have one engineer who is actually coordinating that change, is driving individual AI developer agents to do the changes. You don't have to have a bunch of meetings because it's just one person telling their little agents what to do, right? And you can do it with under 100 developer hours because they're just doing high-level orchestration, and then thousands of compute hours that the AI is doing as it's healing these changes. And we've seen this is literally a project that they had postponed for years because it just was not feasible. They couldn't get enough on the roadmaps. They got it done with Grit in a week, right? It just opened up 1,000 PRs across all the repos, fixed them, iterated on the changes, merged, and migrated over. So how do we actually do a change like that? It's sort of a three-level process. Planning is a big part of it, right? So we index the entire code base. We do both semantic indexing, so understanding embeddings and understanding the intent of each file, but we also do a lot of traditional, more static analysis indexing. So we understand what's the structure of the code, what's being imported from where, what's the dependency graph, right? This is all the sort of thing you need to know to actually do really high-quality agentic flows. Then once we have the plan of how we're going to make changes, we execute the plan, right? So we use large language models that are going to take that change, delegate it to a sub-agent. The sub-agent is going to make a modification in one file. It uses something called GritQL, as well as diff generation from language models. GritQL is our custom query engine that's able to actually index millions of lines of code and find the right places to modify things. And then finally push it up for PR review and be able to both have developers who are the director of it, right? So a typical scenario is that there will be the principal engineer who's driving the change. They'll review the PRs. But then individual developers, their primary interaction with Grit is just seeing a PR land in their repo. And they might leave like one-line comment that Grit will learn from. But they don't actually open up the Grit UI ever because they're just responding to the changes that come from Grit. Cool. So a little bit more about how we find code, right? So our goal here is to find all the error logs in the code base because we want to migrate those over to OpenTelemetry. The naive approach, if you go to many of the workshops yesterday, would be, all right, just chunk it, put it into RAG. You have a bunch of embeddings, and that theoretically could work for maybe some document use cases. I'll tell you that absolutely will not work for this problem, right? If you just go to try to find stuff that looks like a logging error, it's going to find a lot of irrelevant context, right? It's going to find anything that looks like log-like. LLM has a hard time differentiating between a user-facing log, like an alert in a UI, and an actual log that you want to be putting into OpenTelemetry, right? There's also unpredictable thresholds, right? You don't actually know how much code you're looking for. You can't do, retrieve the top 10 closest matches. In some cases, you want to retrieve 10,000. In a lot of cases, developers don't even actually know how big of a change it is until Grit starts to propose it for them, right? So that's where we built the GritQL query engine. It's our own custom query system that combines the best of static analysis with the best of AI. So we've got this query here that's looking for logger with some set of args, right? So we're just going to look for a function call, basically. And that's a syntactic query. So we're just looking for all of our function calls across our entire code base. And then we're going to say that our args should be like an error occurred, right? And that's just, we're giving an example of like what's an error message that we might be trying to look like. Like there is a magical word that converts it into a semantic representation. So we want to say what's some code that, embedding search the cosine similarity is sufficiently above a threshold that this is an actual log message versus some other function call that we wouldn't be wanting to modify. And then we can finally do a imported from. We've got a built-in library that's able to understand the whole dependency graph. So we can do things like make sure this is actually imported from log4j. In this example, we wanted to make sure that we're only substituting our log4j logs, and that will go and traverse the import graph earlier in the program. So that brings us to finding the code that we want to change. But once we've actually found the code, how do we make reliable changes? And unfortunately, really smart models still have a hard time doing this completely autonomously. Just to give an example, I just used Claude Sonnet today, 3.5. It's a really good model. And it uses, I put the entire files, so put a bunch of context into the context window, 100,000 tokens from Grit's VS Code extension, and some of our linter outputs. And we wanted to just write a function that's going to convert from our linter JSON output and puts it into diagnostics for the Grit VS Code extension, right? Pretty simple task. I promised that everything that's required was in the context window, right? It's not something where it had to go retrieve additional information. It was all there. Came back with a pretty reasonable completion, converts ESLint to LSP diagnostics. This looks reasonable to me. Like I imagine if you look at this code, you wouldn't be able to tell anything that's wrong with it. I certainly couldn't tell anything that's wrong with it from eyeballing it, right? But this is wrong, right? And this is one of the main things to understand is that humans also can't look at this code and understand what's wrong with it, right? This is why we have systems that allow us to type check, lint things, right? It allows us to understand code that even looks kind of correct is, in fact, incorrect and will fail in production. But I went back in Claude to fix the code for me. I said, this is broken in production. I tried to put it in my VS Code extension, it broke. And I just asked it why. As you can kind of imagine, doesn't do any better than I do of just looking and eyeballing the code and understanding why it's wrong, right? So it just comes in spec, says some totally irrelevant answer of how to fix it, because again, it's not grounded in what the actual errors are. Fortunately, we have a great tool for TypeScript called TSC, right? We can compile this, and it's going to go and tell me, actually, grit positions and grit ranges have a slightly different type signature than LSP ranges, right? And this is why compilers are great, is we can actually get that information really close in the dev loop. With this information fed back into an LLM, it's able to correct that mistake, no problem, right? That's a pretty easy change. It uses the convert LSP range to grit range, which, by the way, was in the context window. It could have used that before. It just didn't realize that it needed to use that until it had the compiler error forcing it to, right? So this is already how I think it's important to see that IDs are already making us superhuman, and we need to make sure that all of our AI agents have access to the same tools that make them super AI. So compilers rock, right? This basic flow of prompt, get some code, build it, type check it, and then fix that output based on the LM. This is actually really powerful. This is probably half of what you need to do to build a really good agent is make sure that you have this flow working reliably. But they're really slow when you're talking about enterprise code bases. So this is real numbers from like one of our customers. It takes them 10 minutes to build their application from scratch. And that's just for type checking. It's not even pushing a production build, right? And this is actually pretty typical if you look at very large-scale enterprise code bases. That's why large companies have had to build a lot of caching, because it's hard to build a large code base from scratch, which this is completely different than what people usually expect for AI. People usually think inference takes a long time, right? You're waiting for the AI. And this is actually a pretty long prompt, 30 seconds, right? We're using a huge model to generate this code. It takes 30 seconds. But that's dwarfed by the 10 minutes to build the application, right? This basically destroys our entire agentic flow if we're waiting 10 minutes for every single change to validate that it's correct. But this is even more compounded if we're trying to do that in a loop, right? If we're trying to do a single change, it might take a day if you're just doing this naively. There's some agent projects that, in fact, do take a day to make very basic changes because you haven't done this optimization level. But you might ask, like, how are you able to make changes in your IDE at a fast rate, right? You're not waiting 10 minutes every time you make a single keystroke to get a compiler error. It's much faster than that. It's because there's been a lot of work with language servers to solve this, so that you can do a bunch of upfront prep, so you can build the index in memory, have that in-memory queryable index, and then only rewrite the parts or only recheck the parts that you've modified, right? On every keystroke, most tools, like TS Server, for example, in TypeScript, is doing live reconciliation of figuring out that specific file, right? And this is much, much faster. You can do the 30-second prompt, then 1 second recompute from the TS Server, then 30 seconds to fix it, and this is a much more reasonable flow, right? So you obviously want to be using the same kind of language server tools that you'd be using as a human, not CLI-based tools, which often don't have the same heuristics in place to be able to optimize. And then, ideally, you do this in a nice loop. You eventually get to the point where you can commit and get a fresh PR to do that migration to OpenTelemetry. But this is what it looks like in theory. In practice, at some point, it hits an error that it can't fix, right? It hits an error that gets into a loop, and it's continuously trying to fix the same error. It uses 5 different techniques, then goes back, and your context window is completely polluted with the wrong errors, right? Everyone often says, like, agents don't work. This is probably half of the reason that agents don't work, is that you just have compounding failures, right? We found anytime we actually have more than 10 prompts in a row, our chance of having a successful PR is dramatically lower, right? So the way we work around that is instead of trying to repeatedly fix an error, we should actually just save our original state, revert back to that, and then continue to edit from there, right? So if we went down a path that was just a bad path, right, we got stuck in a row, we want to go back to a known good checkpoint and then build from there. And this is actually how we're able to do this quickly. You don't want to spend 10 minutes recomputing each time. We want to actually build our in-memory graph that we were talking about with TS Server. We want to save that. We want to take a snapshot of memory. So we use Firecracker. It's a VM manager that's used for AWS Lambda, but we can actually use it for dev environments too. And we can actually take the in-memory state, snapshot that, and then fork it into 10 different isolated environments that all have everything pre-computed. You can try 10 different changes in them, and then figure out the correct change that is most likely to yield good results from there. And in fact, this becomes massively parallel. You can end up with an AI system that looks more like a distributed database than it does a traditional agent or something that you're running on your laptop, right? We actually have flows where we often have 6 up to 10 different agents working in parallel, all working from a known good state. They're supposed to report back once they're done. And then we'll actually look at the different evaluations. We look at both some LM-based evals, but also heuristics like how many errors are there currently in the code base, how many unit tests are currently passing, and then actually compute like what of these, which is the quorum, right? It's actually similar to, again, a database system where you would have a voting of like what's the new master. Here it's like what's the new good state that we want to fork from. There's 4 here that have similar states that we want to use that as our new known good state. Save that as our known good state, and then fork from there going forward. Right? And this ends up being much, much more reliable because we can have an entire PR that, yes, we've done 30 or 40 different generations on it, but in the final chain, there was only 4 different generations, right? Because we had one, then we went back to known good state, then the second one that's all operating from that quorum at each checkpoint. But these edits get pretty expensive, right? If you're doing 40 different edits to make a single PR across very large files, that's a lot of money that you're spending on inference. This is a common problem with making good edits. Everyone naively just asks for generate the whole file again, right? It's the simplest approach. You definitely should start with that if you're building your own AI tool. But then you run into the classic problem of laziness. So this is actually still from Sonnet. It still said, you know, the start of the function remains the same, right? It left this comment in because it didn't want to output that code. And it's just because output tokens are fundamentally more expensive. But if you look at GPT-4o, it's a $5 to $15 ratio of input tokens to output tokens. Claude 3.5 Sonnet is 3 to 15. This is pretty consistent across the board. And then response limits are not growing at the same level of context size, right? We've got models out there that have 1.5 million tokens, 2 million tokens in their context window, and still only outputting 4,000 tokens at a time, right? Because autoaggressive, it gets more expensive. So you really don't want to output entire large files as you're making edits. You want to find a good edit format. So whole edit format works well. It's very expensive, though. You can do diffs, right? You can say, like, generate a unified diff for this. Try to apply that. There's some problems with this. One is like line numbers. LMs are still not very good at knowing what the right line number is. Even if you give it them, they're just not that good at the math part. And it's also off distribution, right? Real world code that it's trained on is largely not trained on diffs, right? It's trained on actual full files. You can do civil search and replace with function calls. The problem with this is function calls are underneath, for the most part, JSON. Escaping code in JSON format is terrible. You end up using a lot of tokens just for just escape characters, right? It's just not a very good format to use. So that's why we actually developed a GridQL loose search and replace. So we can actually do something that's similar to what you would have on the model of being just a before snippet, and this is something you might have like in a tutorial, which is like replace this with that, right? This is what and this is actually the exact same output that comes from the LM. We'll do a match, right? We'll do a loose match to try to find what's the code that looks like that, and replace it with the code that looks most similar to that afterwards, right? And this works really, really well because we don't have to, you can elide irrelevant details like what's currently inside the make match function, and just give enough detail to make the replacement. Cool. And just want to leave you with where we're going next. This is our current UI. It still is very traditional, right? It still is building it, you know, what's a AI workflow, looks kind of like your CI, even though it's thousands of agents executing. I'm really excited about where we go next with this, figure out like what does it look like to manage an entire code base. I think of like SimCity is like the ultimate where you can zoom in and out and understand at different levels of granularity and edit things there. Cool. Thanks so much. I'm Gante, and we are hiring, so scan the QR code.
Thank you so much, Morgante. Next, we're going to bring to the stage Gunjan Patel. He is a director of engineering at Palo Alto Networks, specifically focused on their generative AI efforts. especially around autonomously identifying and fixing security vulnerabilities, which is what he's going to talk about here today. He previously worked on open source container and cloud networking, as well as security, and he is also a prankster, so also a man of many talents, just like Morgante. And with that, I will hand it over to Gunjan.
Hi. Thanks, Brittany, for the intro. My name is Gunjan Patel. I'm a director of engineering at Palo Alto Networks. Like many of you in the last year and a half or 2 years, I've pivoted to working on generative AI. The talk today is about self-evolving code. I'm not here to sell you anything. None of this is a product from our company. This is a side project that I've been exploring. Before we get started with this talk, I would like to dedicate this talk to my close friend, Nikhil, who passed away 2 weeks ago. It was unexpected, but he was very excited for me to come and do this talk. And he was very enthusiastic about this conference itself. So I want to dedicate this talk to him. Okay, let's start with the coding flow. If you have read the book called The Flow, it talks about this zone where your skills, on one axis you have your skills and how challenging the problem is on the next axis. As you're starting to work on a project, you should be somewhere within that green zone to stay in the flow state. In reality, what happens is in the beginning you have an idea, you start writing some code, initially crank out some code. Then you have a little bit of a difficult problem, so it cranks up the direction a little bit to the anxiety, may even go a little bit into anxiety. And then you have to write unit tests, and then it goes straight to the boredom part. Because it's your skill levels are quite higher, but nobody likes writing unit tests or code documentation. So what's the problem there? As a developer, when you're writing code, when you're developing software, writing code is a small portion of that entire flow, right? You have to work with a lot of stuff like building Kubernetes, like manifests, building Dockerfile, etc., deploying stuff, writing unit tests. So then there's this Copilot duct tape. Yes, having something like a Copilot that would help you get through a lot of technical hurdles on coding side. Whenever you see something challenging, you can overcome that. But we are trying to outsource more and more of that to do offline, right? So you as a developer have more time to write code. So the key part in this talk is about outsourcing a boring task to CI. I had to insert this meme here that like on both ends of the spectrum, people use ChatGPT, and the mid, such as myself, is like juggling all these different tools, trying to figure out how to write the code. Okay, let's get into this. So what's the difference between Copilot and I just coined this term Ghost Pilot. Copilots are made for quick, just-in-time decisions, right? Copilot examples are SourceGraph Cody, like Quinn just talked about earlier, and GitHub Copilot. They work with developer lives. Developers are impatient. You need response in seconds. How good of a tool it is, partly measured by how quick the responses are, right? Code reviewer is made to have a deliberate thinking, right? When you write code and then code reviewer is reviewing your code, it's deliberate thinking. It's not just guess the next word at this point. You need to reflect on the answers that you're providing, or like human code reviewer. Being aware of the full context and to update the answer, right? So some of those things they need time. They require iteration. So one example is this book called Thinking Fast and Slow. So if you think about co-pilots as thinking fast, the slow system is this ghost pilot system. So this is the high-level architecture I'm talking about here. Developer writes code using a Copilot or IDE assistant tool. They check in the code in CI during the pull request process. The first step is improving code comments and variable names. Second step is adding and running unit tests in a loop. And I'll go into each of these steps in more detail. Adding unit tests here early on. Let me talk about the first step. Doing the first step properly means adding unit tests makes more sense, right? Like you need AI to understand what is the intent of this piece of code. Adding unit tests early on sets a baseline behavior for the code. That if this is the input, this is the expected output. So it's setting the baseline. Then third step is based on the environmental context, identify security issues, security best practices that are not followed. And fourth step is fixing them. And after proposing a fix, not fixing them, proposing a fix for a human to review, run the unit test again. So let's go into each of these steps. So first one, why improve variable names and code comments? Yesterday there was a session here from Manuel that he wrote this line, LLMs are cultural technology, right? LLMs are built based on all the knowledge in the world, not just coding knowledge. Like most of us here, we know a lot more about coding than art or how humans behave, psychology, etc. But LLMs have all that knowledge stuffed into them. We should figure out how to utilize that completely, right? So an example is if you're working at a finance company, for example, and use a variable named rev, it makes sense to you, like revenue, in that small context of your code, but improving it to annual revenue, and then in the subsequent steps, if LLM is run using different LLM providers, it will pull in its existing knowledge from all the finance world. So there may be some corner cases that may not have been discovered if you just use the variable name rev versus annual revenue. The second part is improving code comments, right? Comments can get out of date quickly. If someone is in a hurry, makes change to a piece of code without improving the code comment, then it's out of date, right? Like it doesn't state the developer's intent. So improving that to make sure that LLMs understand what is intended behavior of this code, even if the code may not reflect it. And that's why we have bugs, right? This is the intent. Nobody intends to have a bug. So making that intention of the code block clear. That's why we improve the code comments. So this is a small example of that. You can see in CI, it's adding high-level flow of what is expected from this code block. Here, like it's a server, so I just put port, and it improved to port number because it could be port name or port number. I don't think about those things, but when it comes to adding unit tests, AI-generated unit tests, it becomes important. Second one is adding unit tests. So adding unit tests, as I said earlier, it's to set the baseline behavior. Then once we have the baseline behavior, we can add second layer of unit tests for covering corner cases. Third one is to get context from historical bugs. Looking at Jira fetching for this project, we have seen this kind of bugs in the past. So adding additional precautions to make sure those cases are covered. So what are the steps like? It's not asking an LLM to say generate unit tests for this code. It doesn't do a very good job. And this is where having iterations comes into play, right? So first one we do is, because we have all the time in the world, people are not rushing for CI jobs to complete. I mean, yeah, a lot of people are impatient, but it's not like when you're writing code with an IDE-based assistant, you need response quickly. So what we do in this one is set the baseline. So LLM outputs the expected behavior of this code, not the person who wrote it. LLM will read it and say, okay, this is the expected behavior. It will take things into consideration like code comments, README file, and maybe a PRD document. It may not go into function level details, but overall intent is there. Then in the next step, we added adversarial mindset. You can use the same model or a different model and say, system prompt is the context looks like. Context is used in the step 3, but things like what is the cloud provider, what is the service, where is it deployed? Is it a company internal tool or a customer-facing tool? Is there PII data in it? Is it a front-end or back-end application? Networking, PRD, where is the Jira project to pull all the bug reports and more information on this project? Slack channel. Now this is important. I haven't implemented this part yet, but where it could go and ask follow-up questions to the user saying, hey, I'm not sure about this context, it's missing this context. Similar to if you use Perplexity and use Perplexity Pro, you ask a question, it's not clear, we'll ask you a question back. So that's what this is designed to do. And your company security policies, guidelines from your InfoSec team, if you have any. Then second part of the context is built using AI. So AI infers this context. What language is this? Is this ISC code or is this backend code, shell code, etc.? Because you will have different priorities based on that. What are the focus areas? That comes from historical bugs, SQL injection, timeout errors, concurrent users, whatever issues and escalations you've had in the past. Here, Quinn has done a great job on opencontext.org. That's a potential integration point here as well for bringing in additional context. Finding security bugs, now security issues. So security best practice, this is not just looking, it's different from running static code analysis and running SaaS-based tools. It's finding which security best practices are not followed that your company may have policies around. Logical flow-based issues. I'll show you an example in a bit. And prioritize which ones need fixing. Right, not just identify, because when you ask AI, find issues, it's going to find issues. It's never going to say, no, it's fine. I mean, it's a small issue, but it's going to say something is wrong. So how do we do that? This is a little bit of a weird side now, right? What I'm doing here is simulating 3 AI employees, right? One is a red team engineer. One is a Python developer, assuming this is Python code, and an engineering manager. Engineering managers are useful for something other than talking in meetings. So what context am I providing the red team engineer? Security policies and the code that's written or the code that's being reviewed. Python developer will assume the identity of the person who wrote this code and the PRD, product requirements. Engineering manager will have business side of things, business context, so Zoom meeting transcripts, Slack channel conversations, and PRD. Now, there is a prompt to have these 3 people take turn, multi-turn, and then debate among each other on each of the security issues, on identifying what is the risks associated with it and which ones need to be fixed and what is the effort for it. And at the end, after they're done with the debate, self-reflect on the answer and say, okay, this is, and that could be a separate model. It could look at the answer and say, okay, this is matching the original intent or not. Some fun things you could try. I was listening to a podcast recently, and they talked about Odyssey Journey, which is like you think about like 3 potential paths you could take, and then time travel back and then talk to your past self. Now that's not really possible in real life, but in here we can do that. With AI, it's all fun, but there's some research paper that show that this is actually more effective than just using LLMs as a standard tool. This is an example. This was a Kubernetes bug in the Go code. It was a critical severity bug. And I made sure to find this issue from after the training end, so GPT 3.5 training date end. This wouldn't have been picked up in any of the SaaS tools because it's a logical thing. This if statement needs to go from here to here. And that caused the security vulnerability. Now that's something that's, when I run it through this, it finds that issue. Last one is fixing the security issues. So this is outcome-based, and it's, again, suggestion of what to fix, and then human reviewer comes in at the end and decides which ones to actually fix. For each of the fix, explain the reasoning why it's prioritized, that all the conversation that the 3 virtual employees have had, it's summarized in 3 bullet points. So human reviewer has the context and security policy citation. And at the end, make sure before a human comes in, run the unit tests that were establishing the baseline early on, so a human doesn't have to waste their time with verifying the fix. This is not a great example, but a simple example of what it would look like in a code comment, hard-coded API key. I mean, most people wouldn't have that. What is the risk score? What is the effort score? What is the recommendation, which is the code snippet, and then fix it after.
I feel you somehow. Don't let me go. I need you right now. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. 'Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. that you're starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it taking over your senses? Don't you ever fear it? Technological advances, baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it taking over your senses? Don't you ever fear it? Technological advances, baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We are a summer storm, a feeling you can't ignore. Summer nights and days were long. You and me, we were the only ones. We were holding nothing back from the greatest nights we ever had. Sun lit up the boulevard, driving slow, racing in your car, singing along every night. Must have played that song that we know. Doors that open for us in a moment. Keeping the light on, righting old wrongs. Keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over the rest, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over the rest, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Like a find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we grow. Gotta give it up sometimes, let's go. And knowing when to kill your pride. There's no one to looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sunset's in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. 'Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get
Ladies and gentlemen, the keynote presentations are starting now. Please take your seats. If there are empty seats closer to the middle of your row, please move inwards to open aisle seats for others. Thank you. Ladies and gentlemen, please welcome back to the stage your host, Benjamin Dunphy.
How do I look? Booth bingo. Who's been playing? Let's see the show of hands. Who's been playing both booth bingo? Booth bingo, booth bingo. We got a few people. So the folks at OpenPipe, they sponsored this lovely bag. And they came up with this great idea that I'm going to use like now and forever. We give pins, a limited number, to all the sponsors. And you fill out the bingo board and get a prize. Scan the QR code. Anyone want to fill that up with some good stuff? It's right there. Do we have a good time? All right. So many speakers, so many sessions. Only one of each of you. For now. Let's get those AI clones going soon, and I don't know, some Matrix downloads. Slow down a little bit. Great. So I don't want to take up too much of your time. We're going to get to the closing keynotes. Yeah, we all ready? Are we all that exhausted? Are we ready? Please join me in welcoming to the stage the CEO of Bot Dojo, Paul Henry.
I got logged in. Cool. So, hello, my name is Paul Henry. I'm the founder of Bot Dojo. And as a previous CTO, I was working with teams deploying LLMs applications for hundreds of thousands of customers. And like many of you guys know, it's super easy to hook up a vector database with an LLM over the weekend, but really hard to get it production ready. And so that's what we do. We are an AI enablement company, and we let companies deploy AI to prod. Live demo time. All right, so today I'm going to show you a demo of our product. We're going to take synthetic data that we're going to generate, and we're going to combine it with evaluations to see how we can improve the performance of a chatbot. Or at least that's what I hope happens. All right. So I'm going to open up our template of our a chatbot, and we have customers live that are using this template. It's kind of battle tested. And so let's test it out. How do I create a vector index in Bot Dojo? Okay, and as you can see, all the little nodes are lighting up as they execute. We're taking the question, we're looking at the chat history, we're going to the vector database to retrieve the information, and then we're answering it with an AI model. So if I pull this up, you can kind of see in our low-code editor, this is the prompt that we're sending to the LLM. We're getting the results out here. And we also support JSON schema. So if the model supports JSON output, like Grok, Claude, and all that stuff, then we just conform to that. One key thing is you can pull a trace of each node and see exactly what we sent to the LLM, what came from the retriever, the exact data, which has been super useful for debugging apps. All right, and cool, we have an image. It's got citations. We should ship it. That was supposed to be a joke, but all right. So this is where evaluations come in. So I'm going to demonstrate the evaluations that I previously ran. So we have a feature in Bot Dojo called batches, which allow you to run a whole bunch of questions through your chatbot or your AI flow and run evaluations to kind of see how things are doing. So if you can see this, we have a few 5 evaluations that we ran. There's a little bit of red. That's because we don't have enough information from our vector database. It also checks for things like hallucinations. So let's try to fix that. And so I'm going to clone this batch. I'm going to rename it with generated data. I'm going to increase the throughput a little bit because of time. And I don't have enough time to generate all the data for this demo. So the previous RAN was filtering out the generated data. And so I'm going to remove the filter that we're passing into the flow so it takes in the generated data. You can also change the model and all that kind of stuff to see how it performs. All right. So while that guy is running, I'm going to open up another flow. And so this is the actual flow that we generated that synthetic data. And so let me run this one real quick. And so this particular flow takes in multiple inputs. And so I'm going to paste in some JSON from a previous run. And what this is going to do is kind of a trick that's been working well for customers, is where you take, you extract questions and answers from support tickets. So these are live agents talking with customers. And you use this as a test data to send it through your chatbot. And we take relevant information from the existing index, and we have it write a document. And so it uses the same writing style, and it, and then we do an inline evaluation to where we check to see if the document has enough information to answer the question. And then we also have a code node here where, a lot of times when you're using these low-code editors, there's like situations where you have 40,000 different boxes. And so when you have to write code, we support TypeScript and soon Python. But you can see that, hey, we're getting the information and we're right into the vector index. All right, running out of time. Okay, let me go back to the support chatbot, moment of truth. So I'm going to compare the batch that we ran before with the new stuff in 20 seconds. Oh, you do it 15 times and it doesn't work. 10, 9. We're also hiring, so if you're an AI engineer, help us fix this. All right, there he comes. Okay, whew, all right, 1 second left. It's all green, so it improved the, it measurably improved something. So thank you. Botdojo.com, check us out. Thanks. Literally did that.
Ladies and gentlemen, please welcome co-founder and CEO of Emergence AI, Satya Nitta.
Good afternoon, everybody. I'm here to tell you a little bit about what we're doing at Emergence in the field of AI agents, but first I want to tell you guys a few things about who we are. So we are an R&D-led AI company advancing the science and development of agents. And we come from some of the world's top AI labs, founding team out of IBM Research, and then we attracted talent from places like Google Brain, Alexa, the Allen Institute of AI, Meta, Microsoft, etc. But even more importantly, we have built and deployed some of the most scaled AI deployments on the planet, from the IBM Watson platform to Alexa to the backend recommendation engines behind Amazon Prime, Amazon Video, Twitter, Eventbrite, etc. So we really think of ourselves as a distributed systems meets AI R&D team, and our goal is to work on AI agents and to enable all of you to build agents to transform the world. So we're all here today because we're excited about what's actually coming out in AI. So the long promise of AI over this last several decades has always been that AI will perform actions for us. This is what science fiction authors have told us since the 1940s and 50s, and I think the time's finally here. And in particular, what we're very excited about is AI that will operate things like web browsers and various other enterprise systems and software, and in the process, drive great productivity benefits for everybody, both in consumer and especially in enterprise, which is our focus. So we're interested in enterprise because the most interesting workflows are actually in enterprise, and this will really stress and push the limits of what AI can do, in particular what autonomous AI can do. And so what we're building to enable that future to come to pass with the help of all of you are two very infrastructural platforms, the first of which will be GA'd in August. Early access is already live right now, so you can go sign up for it. This is called an orchestrator agent. So first of all, it's an agent, and in the sense that it acts, it plans, it basically also verifies. So it finishes that agentic loop between planning, acting, and verifying. It remembers and improves over time. But what does it do? It actually allows you to orchestrate across multiple agents and stitch them together in complex workflows. A simple version of it is you could simply orchestrate across multiple LLMs, generalist and open source LLMs, but more complex versions of it will basically enable you to solve very complex enterprise workflows like claims processing, etc. Now, an orchestrator is only as good as the agents it will orchestrate to. So one of the exciting things that we're doing here is integrating the orchestrator with a project that is currently being developed in the open source called Agent E. Agent E is a project that my colleague Taimur had a session on earlier this afternoon. It's a web agent. It's basically meant to control the web like a human would. And currently, it's the best web agent on the planet. It's topping the Web Voyager benchmark. And it's designed to basically be used to build multiple enterprise workflows and work seamlessly with the orchestrator agent. So I'm going to play a short video that will show you a little bit more about both these agents, and then I'll wrap the talk up. OK, we don't have sound, so maybe I'll talk over it. So our first product is the orchestrator.
Generalist and task-specific LLMs and agents, all using appropriate guardrails. The developer dashboard helps analyze prompts, optimize cost and latency, create new models with your data, and enhance existing ones. Build with confidence, knowing your solution is future-proof and can migrate to the latest LLMs on demand. The orchestrator is an intelligent agent that improves with use, connecting to agents like Agent E, our web automation agent in development in our R&D labs. Agent E is an open-source agent designed to learn how to autonomously operate the web and automate complex workflows. For example, get us a reservation for 15 people near the office around 6 p.m. We like Asian, Mediterranean, and Mexican. Send the details to Levi, please. At Emergence, our mission is to advance the science of AI agents by tackling core AI problems like planning and self-improvement to enable the full transformation of AI and benefit the world.
OK, so just in conclusion, in our R&D labs, our area of focus is around self-improvement agents. This is our core focus. And in the process, we will advance things like AI planning and reasoning, and also solve things like how agents should be stitched together in really interesting ways through something called agent-oriented programming. And we're doing all of this in the context of enterprise workflows like RPA and document processing, et cetera. So that's my time. Thank you so much. See us at our booth.
Please welcome to the stage member of technical staff, Midjourney, Cheng Lu.
Next. Forward the slides.
Hello. This is a small visualization of our Lord and Savior matrix multiplication. I was asked to make a cool demo, so here it is. This is a single fragment shader drawn fully on the GPU. There's no imported asset, no triangle meshes, just purely a few hundred lines of GSL. Shader R is a niche digital art form, and I highly recommend you to check it out. But the GPU wasn't supposed to be abused this way. But then again, the entire domain of machine learning is enjoying a renaissance thanks to it. So how did that happen? Today, I would like to explore a little bit of these kind of second-order effects and why things happen with unintended consequences and how you can more reliably predict the future. OK. So Deep Blue beat Kasparov in chess 1996. And 2015, AlphaGo beats the famous Lisa Dolin Go. If you were a pessimist, as many were back then, you'd say that this is over for chess and Go. What's even the point of playing those anymore, right? If human is not at the top. But if you check what actually happened subsequently, this is a graph of professional Go players' decision quality over time. Guess where AlphaGo happened? And on a completely unrelated topic, this is Conway's game of life. It has black and white cells and a few simple rules to how the cell actually interact. And at first glance, it's no big deal. But as you start building macro patterns with those, you get cool things like these. And here's Conway's game of life implemented in Conway's game of life, Turing complete. These are examples of emergent behaviors produced by an order of magnitude quantity and quality or performance increase. The domain of machine learning is pretty familiar with this phenomenon. And generally speaking, emergent behavior is mostly NP complete, so you can't compute it easily. So to create these patterns, people have to zoom out a level and consider high-level macrodynamics, a new set of rules plus various heuristics and errors. Those folks work more like biologists than mathematicians or physicists. And what I'm trying to say is we cannot easily predict the emergent behavior of even a simple system that scale beyond our low-level intuitions. So in this talk, I would like to provide a few personal thought processes I use to predict some interesting second-order effect of AI, aka the ripple effect caused by more direct consequences of this era of AI. And as a famous sci-fi author once said, good sci-fi predicts cars, great sci-fi predicts traffic, right? So the first I would like to use is broadly called, who is learning? Are you learning or is the machine learning, and do you care? I'm mostly talking about what people want. So for example, chess didn't die, it only got better, right? Because it turns out that the crowd dynamic of it is that when you have free chess teachers anytime you want, instead of having to seek out that one dude in the village that teaches chess, well, everyone ends up knowing chess. And when that crowd knowledge becomes distributed widely enough, you get to have an audience to sustain more professional playing. Because ultimately, it is you who want to do the learning and the audience, disregarding whether the machine learns better than you or not. You go to the equivalent of mental gym, because no matter how much the machine goes to the gym, you won't get better unless you do. The same is true for drawing. Imagine a novice learning to draw. A blank canvas is actually a very daunting challenge, right? But very soon, you'll be able to have this equivalent of what we call a stroke auto-completions. So imagine a conceptual slider like this one, where on one side, nothing happens, right? On the other side, the full drawing is made for you. What's interesting is that now we can have a learned behavior where we can slide that into the middle. So when you prompt the system and that you want to draw a chair, the system goes, oh, OK, you're curving this way, so I guess you want a Victorian-era chair. Right? Or when you use a shade of blue, the system goes, oh, I guess you want to draw the reflection of the sea on her face, but there's sand, actually, so it should be a little bit more green than this. So if you try to learn coloring, you know how long of a feedback loop this actually is to master this. And now you can dial that up and down per your need with immediate feedback. And ironically, over time, your slides actually go way more to the left, all the way to the end, where you basically stop using AI because you've internalized everything, and the skill came back to you. Similarly, for music, yes, we can now generate full songs in one shot for utilitarian ends, but AI could also help in a different way for you to learn. And what I'm interested in is in music, most of the time you're using direct manipulation in UI speak of the instrument, right? The impedance mismatch between pressing a piano key and hearing the expected sound is almost none. But that lack of indirection is also a trade-off. So this is a theremin, and already we're seeing a little bit more of an indirect manipulation. So I was wondering, what if you use your fingers to create and manipulate a music spectrogram? Right? Obviously, your fingers aren't fine enough, but if the AI has enough world model knowledge to super sample it for you, so to speak, maybe we'll end up with a new form of instrument when you gesture more like a puppeteer indirectly and create new kinds of music that analog music manipulation couldn't achieve. So here's another reason I'm giving these examples. My domain is user interface mostly nowadays. If you think about who's learning, you might end up with a conclusion that direct manipulation of user interfaces is actually about learning for yourself, akin to going to the gym for yourself, or learning to draw for yourself, learning abstract instrument for yourself. So AKA, once the classic user interface of tapping this and tapping that gets increasingly automated away. Once the utilitarian ends have been met, all that's left is the kind of lifestyle user interfaces where you use them not because you're more efficient than the machine, but because you are the one who's trying to learn them for whichever self-fulfillment reason. And so in that regard, we might end up with more artisanal, quirky niche interfaces for luxury, lifestyle, or other purposes as a second-order effect. And the second category I want to talk about is the idea of widening the information bandwidth, which is a trick I use quite often. So the other day, I was looking at some new research result from Anthropic regarding sparse autoencoders. But tangentially, there was this simple visualization of a cluster. And just purely from a visual perspective, it kind of reminded me of the movie Arrival by Denis Villeneuve, where humanity learns an alien language that allows them to unlock their full potential. And I thought, why not take it further, right, and make it one language per person? Right, widen the whole information bandwidth. So up until this point, human language is this somewhat standardized communication interface, and it's a very, very narrow bandwidth one, a very lossy one. We learn relatively few languages, mostly standardized, and stuff our entire fuzzy ether of information into hoping that most of it isn't lost in translation. Now, that AI basically solved translation. So why not go a step ahead and translate one English to another English? Say I'm arguing with someone, and I say, I feel blue, and this is coming from my perspective, really. So it's unclear that this intent arrives to the other person intact. Maybe for that particular listener, I should have translated I feel blue into I'm feeling purple, right? And what if I can just show it? What if my chat speech bubble is much more dynamic and much more nuanced because the AI understands the other person's aesthetic preferences? Right? What if things are fast enough that every sentence can be personalized into a dynamic art piece in 4D or something? Way more nuanced, information dense, and I can just hand it to the person in AR, right? Much denser than static emojis and a few Bezier curves, right? And what if you're communicating in AR and these gets machine translated into like some kind of cloud around you for the receiver, just in time, individual specific language translation mechanism free of the compromise of a one-size-fits-all low bandwidth text language, right? Maybe verbal conflict resolution end up taking in the order of seconds instead of minutes or hours in 50 years. So some more examples. Here's one for the iPhone, the hardware user interface, and the next one for the iPad. For Canvas apps, the act of pressing the pencil against the tablet usually means drawing a line, but it is overloaded to be selection, moving, resizing, etc. Right? But the reality is of a much higher bandwidth. So for example, if someone multi-taps on the screen with a pencil, maybe right before they said, why is this part red? Right? Can we change it? Or maybe they drew a stroke. They said, yeah, this probably goes there instead before that, right? And didn't feel like hunting for the lasso tool, selecting it, coming back and drawing a circle, long tap to hold the object, move it, double tap, pencil back to the previous pen tool, and you do all these kind of acrobatic because you want to move an item, right? So if you want to use a traditional design to categorize and overload a single stroke gesture, then you'll inevitably end up with more confusing behaviors with an implicit rule set. So traditionally, if your current stroke is conditioned on the current selected tool state, the object under your pencil, and maybe the action 1 second before, if we need to undo the stroke in favor of interpreting as a tab. This is very messy, right? It's very fine design and craftsmanship. But in this new era, that line shouldn't be only conditioned on the beginning of its Bezier path, right? It should be conditioned on the entire world. So the tap and the stroke behavior should be as learned, as in machine learned, as possible. And some people's short press, sometimes they're just slightly too long and trigger the wrong gesture and all sort of bad action that a human observer would have corrected within a second. So why can't machine learning just do it, right? Locally too. The last thought process I like to use often, which is extrapolating a certain quantity or quality to the extreme, which causes all sorts of fun emergent behavior you can try to guess, like previously mentioned Conway's Game of Life, for example. And then I can reason from first principle there and see what kind of new things we can get from this. if anyone's into programming languages, this is Smalltalk, programming language environment from the 70s that's the grandfather of the original object-oriented programming, which inspired Objective-C and other languages. One of its main characteristics is message passing, as in sending commands, maybe even to another remote Smalltalk object on a different computer somewhere else through LAN or later on internet. I'm going to spare you of the detail, but Alan Kay, one of its inventors, said the inspiration is basically, well, it's inspired by cells, right? And that each object is basically a full computer you can examine and poke into, and you can like do things with it. And recursively, it might be a one-to-one mapping to a computer. It might be that one computer has many objects, etc. And also, he did say, somewhat more obscurely, that sending the message, sending the command to another computer, that's easy. But finding the receiver, that's hard. So each Smalltalk object can theoretically, smartly go to the internet, do stuff, come back with an answer, like a little self-directed intelligent agent, if this sounds familiar to this audience. But Smalltalk had a big problem, which is that when an agent is as smart as it can be, it's also as resource-intensive arbitrarily as it can be. So when each agent takes up enough resource, you only get to have a single or double digit of them, right, by the law of numbers. So you miss out on an entire category of emergent behavior because you try to be too smart at the lower level. In this case, an emergent behavior from quantity and collaboration. So on the other hand, look at this multi-layer perceptron. That's a graph. So interestingly, it kind of solved the discovery of the receiver problem because you can make it fully connected or whatever, and because the weights are learned, it'll propagate, and you know, some connections are more important than others, right? The biggest difference between this and a swarm of agents is that the nodes are as dumb as they get. And when they're dumb and simple, you get to have millions of them. And when that happens, you can leverage the emergent behavior of the aggregate and create a new media completely. So there are quite a few agent-focused talk in the domain of ML, and I like to take this opportunity to use this method to offer some interesting food for thought. So for example, the more agents you have, the more you zoom out to care more about the aggregate rather than the lower-level agents, right? Just like people and civilization. And the more you zoom out, the less you actually care about each individual agent. So in an alternative reality, not in this one, we invented a couple of agents who got sent to scour the internet called Wikipedia and came back with some snippets of information. However, thankfully, in our reality, we sent billions of dumber nodes to read Wikipedia and aggregated all of them together to sit in a phone coordinated by a single top-level smart top-level process. So here's my last example. This was actually freshly picked. This is the Apple TV macOS UI, pretty decent looking. I like to pay attention to this part, the circled red part, which is the More button here. When you click on it to see the full description, what do you expect? Well, where does the description expand to, right? Turns out that you get a very atypical Apple UI. When you click on it, you get this, which is literally a big UI text view, right? Very un-Apple. So it looks like an unfinished notepad. In fact, you can kind of select it and do things with it, which is weird. The thing is, this Apple TV Mac app is actually a Catalyst app, which, for those who don't do iOS development, it means that it's a direct port of their iOS app here. On iOS, if you tap the description and get such a new view, then things don't look too out of place. In fact, it's rather idiomatic. Now, you might say that the problem here is that lack of UI design and lack of care, lack of craftsmanship. But for the sake of making a point for this talk, I would like to provide a perspective that this might actually be a lack of literally needing more UI, a lack of more UI. So what would the world look like if we extrapolated that quantity, if we raise the order of magnitude and have way more UI, 2 orders of magnitude more, right? What does that even mean? So let's start with a simple 12-column grid. right? We first list out all the discrete pieces of information we want to potentially show across this entire view, or maybe across the entire app, right? Now that we have AI nowadays, at design time, not at runtime, at design time, we could generate thousands of these permutation of layout for a show's UI screens, right? We're not shipping these, just using AI to generate a bunch of potential candidates. So previously, this task wasn't achievable through traditional means unless you're in a particular niche, since we didn't have a way to pay attention to the semantic relationship between, say, a show's title and the box's size and position in relation to other items. Right? You could still generate plain boxes through traditional heuristic and generative algorithm, but you'd have a hard time tagging each box with a right piece of information, for example. So after a first pass, we can use a scoring mechanism, either traditional or some fancy AI-driven scoring heuristic aesthetic things to eliminate undesirable layout at data generation time. And of course, you'd involve the designer here too. This is done at design time, offline, not at runtime. So we can use an algorithm that's as slow as we need, and the designer can take as much time or as he or she needs, and patiently curate the subset, which is quite large. So the key here is that you've generated not 10, right? You generated thousands of these through smarter generative and semantic filtering techniques. So we're raising the order of magnitude, right? You're not a designer making a single-digit number of design, moving boxes yourself in Figma and waiting for your boss to go, can we move this box somewhere else instead? And just one more ad hoc design, please, I promise. It's just one more, you'll solve everything, right? And of course, you want to involve the designer in this particular stage too. Maybe at some point you also decide to like throwing a little bit of diffusion, again, of rough draft time to using some control net or whatever to generate some rough website to make the boss, give boss more of an immersive feeling, right? To say like this layout can work, it's not just like boxes, right? And at app runtime now, which is the part I'm personally interested in, right now, LLM generations, they generate at writing time, and then they generate like 2, right, or 3, and then you pick one, and then maybe you ship that, and then it's a traditional web app. But the thing is, if your bottleneck is the web part, even the AGI cannot help you make your JavaScript faster than C++, right? So we have to swap out some of these items with an actual neural net if we want to advance and use a web platform, for example, or any other platform for that matter. So at runtime, you have, for example, a quick decision tree to choose the right layout. So again, for modern web development, this roughly has this one single heuristic for you to select the right design, which is called media queries, which all it does is, depending on the width of your window, you might show or hide some items. But this entire space could actually use some help from learned algorithms. So for example, what if the user's onboarding? Why is that a different concept when you hide show or show some different boxes? It's just another set of boxes, right? What if the user is a super user? Maybe you progressively show them a different set of layouts, right? Maybe they require different screens. And what if the user is in a different country, right? Different age, search query. So to be clear, big companies like Uber and Facebook already do this on a daily basis, right? When you use Uber, the app in India or China, it looks drastically different, right? But it's currently thousands of engineers of effort, right, for big companies, right? And they create an entire moat out of the fact that they have a few more design UIs, plus a business logic, to be fair. And it's very brittle. Right? You cannot see everything, and the algorithm is basically less controllable than even a simple decision tree, a classifier. So if a user is fuzzy searching, right? This might be a better example. Hey, what movie did Denis Villeneuve make? Right? This goes into a decision tree and shows the curated layout. If the user is instead saying, hey, what movie did Denis Villeneuve make and with whom, then you show this curated layout instead. So maybe you're asking a chatbot, in which case the layout is even more contextual, right? If you do a napkin calculation of the generated and curated number of UI you ever need, they might actually be in the 1,000, not tens, right? Fortunately, 1,000 can still be curated thanks to AI. So essentially, it's not an autoregressive problem. It's not a diffusion problem. It's a simple classification problem, because we have discrete categories here. So here you go, dynamic UIs. So let me summarize this for a little bit. Second-order effects are pretty unpredictable, and there are many ways to tame thinking about them. If you think about these points among others, then I think you'll be decently prepared when the time comes. And of course, read from history, and you've got to do things. Don't forget that the best way to predict the future is to invent it. Thank you.
Ladies and gentlemen, please welcome VP Product, Spreadsheets Are All You Need, Edgio, Ishan Anand.
Hello. Hope you're all having a good conference. And I hope you're ready. Because if you came to this conference or the AI engineering field without a machine learning degree, then this is going to be your crash course in how machine learning models actually work under the hood. Let's bring up the slides. There we go. Thank you. OK, so I'm Ishan, and I'm dressed in scrubs, because today we're all going to be AI brain surgeons. And our patient will be none other than GPT-2, an early precursor to ChatGPT. And our operating table will be a table, but it will be a table of numbers. It will be an Excel spreadsheet. This Excel spreadsheet implements all of GPT-2 small entirely in pure Excel functions. No API calls, no Python. In theory, you can understand GPT-2 just by going tab by tab, function by function through this spreadsheet. But you want to hold on to those VLOOKUPs, because there's over 150 tabs and over 124 million cells for every single one of the parameters in GPT-2 small. I will give you the abbreviated tour. So we'll do 3 things today in our little med school. First, we'll study the anatomy of our patient, how he's put together. Then we're going to put him through a virtual MRI to see how he thinks. And then finally, we're going to change his thinking with a little AI brain surgery. OK, let's start with anatomy. You're probably familiar with the concept that large language models are trained to complete sentences, to fill in the blank of phrases like this one. Mike is quick, he moves. And as a human, you might reasonably guess quickly. But how do we get a computer to do that? Well, here's a fill-in-the-blank that computers are very good at. 2 + 2 = 4, right? They're really good at math. In fact, you can make it very complex, and they do it very well. So what we're going to do, in essence, is we're going to take a word problem and turn it into a math problem. In order to do that, we take our whole sentence or our phrases, and we break them into sub-word units called tokens. And then we map each of those tokens onto numbers called embeddings. Now, I've shown it for simplicity here as a single number, but the embedding for each token is many, many, many numbers, as we'll see in a bit. And then instead of the simple arithmetic shown here, we're doing the much more complex math of multi-headed attention and the multi-layer perceptron. Multi-layer perceptron, just another name for a neural network. And then finally, instead of getting one precise exact answer like you used to get in elementary school, we're going to interpret the result as a probability distribution as to what the next token should be. So here's our setup. We get input text. We turn that text into tokens. We turn those tokens into numbers. We do some number crunching. And then we reverse the process. We turn the numbers back out into tokens or text, and then we get our next token prediction. So this handy chart shows where each of those actions maps to one or more tabs inside our friendly patient spreadsheet. Let's take a look. So the first thing you do is we get our prompt, right? Here the prompt is, Mike is quick, he moves. And then it will output, after about 30 seconds, since we're running in a spreadsheet, don't use this in production, the next predicted token of quickly. So the first step is to split this into tokens. Now you see that every word here goes into a single token. But that's not always the case. In fact, it's not uncommon to be 2 or more tokens. Let me give you some examples. So here's another version of the sheet. Let me zoom this up so you can see it a little better. Right? I've put actually some fake words. Re-injury is a real word, but funology isn't a real word. But you know what it means, right? Because it's the word fun with ology put together. Those are the morphemes, as linguists like to call them. And the tokenization algorithm actually is able to recognize that in some cases. Whoa, there we go. Right there. You see fun split into fun and ology. If we zoom that one up. There we go. But it doesn't always work. So notice how re-injury got split up right here. It's rain and jury. And that's because the algorithm's a little dumb. It just picks the most common subword units it finds in its iterations, and it doesn't always map to your native intuition. And so in practice, machine learning experts feel like it's a necessary evil. And then the next step is we have to map each of these tokens to the embeddings. So let's go back to the original one. And that's in this tab here. So we have each of our tokens in a separate row. And then right here, starting in column 3, is where our embeddings begin. So this is row right here. The second row is all the embeddings for Mike. Now, in the case of GPT-2 small, the embeddings are 768 numbers. So we're starting in column 3. So that means if we go to column 770, we will see the last end of this. And so there's the end of our embeddings for Mike. And let's go back. And each one of these, again, is the embedding for each token. OK. Then we get to the layers. This is the heart of the number crunching. So there are 2 key components. There's attention, and then the neural network or multi-layer perceptron. And in the attention phase, basically the tokens look around at the other tokens next to them to figure out the context in which they sit. So the token he might look at the word Mike to look at the antecedent for its pronoun. Or moves might look at the word quick, because quick actually has multiple meanings. Quick can mean movement in physical space. It can mean smart, as in quick of wit. It can mean a body part, like the quick of your fingernail. And in Shakespearean English, it can mean alive or dead, like the quick or the dead. And seeing that the word moves here helps it disambiguate for the next layer, the perceptron, that, oh, we're talking about moving in physical space. So maybe it's quickly, or maybe it's fast, or maybe it's around, but it's certainly not something about your fingernail. So let's see where this is all happening. So these are our layers. Now there's 12 of them. So this is block 0 all the way to block 11. Each one's a tab. And then if you go up here, we can't go through all of this in the time we have, but this is one of the attention heads. This is step 7. This is where you can see where each token is paying attention to every other token. And you'll notice that there's a bunch of zeros up at the top right. And that's because no token is allowed to look forward. They can only look backwards in time. And you'll see here that Mike is looking at Mike 100% of the time. Higher values mean more attention. These are all normalized to 1. Here is the word he, or the token he, I should say, and you'll notice 0.48. So about half of its attention is focused on the antecedent of its pronoun. Now, this is just one of many heads. If I scroll to the right, you'll see a lot more. There aren't always as directly interpretable as that, but it gives you a sense of how the attention mechanism works. And then if we scroll further down, we'll see the multi-layer perceptron right here. If you know something about neural nets, you know they're just a large combination of multiplications and additions, or a matrix multiply. And so I don't know if you can see this in the back. There's a mmult, which is how you do an Excel matrix multiply. And that's basically multiplying it times its weight. And then here we put it through its activation function to get the next prediction. OK, let's keep going. OK, next we have the language head. And this is where we actually reverse the process. So what we do is we take the last token and we unembed it and reverse the embedding process we did before. And we probabilistically look at which are the tokens the closest to the final last token's unembedding. And we interpret that as a probability distribution. Now, if you're at temperature 0, like we are in this spreadsheet, then you just take the thing with the highest probability. But if your temperature is higher, then you sample it according to some algorithm like beam search. Let's take a look. And we'll go here. So again, I don't know if you can see in the back, but this function here is basically, there we go. This function in the back basically is taking block 11, the output of the very last block. It's putting it through a step called layer norm. Then we multiply it, another mmult. times the unembedding matrix, and these are what are known as our logits. And then to predict the next most likely token, we just go to the next one. And if you can see this function, it basically is looking at max of the previous column you saw in the previous sheet. And it's taking the highest probability token just like that, and that's our predicted token. We get a token ID, then we look it up in the matrix, and we know what the next likely token is. OK, so that's the forward pass of how GPT-2 works. But how do all those components work together? So let's take our patient and put him through a virtual MRI so we can see how he thinks. Before we do that, there's something I forgot to mention. These are called residual connections. Inside every layer, there's an addition operation. And what this lets the model do is it lets it route information around and completely skip any part of these layers, either attention or the perceptron. And so you can reimagine the model as actually a communication network or a communication stream. So the residual stream here is every one of those tokens, and information is flowing through them like an information superhighway. And what each layer is doing is we've got attention moving information across the lanes of this highway, and then the perceptron trying to figure out what the likely token is for every single lane of the highway. But there are multiple of these layers, so they're really reading and writing to each other information in this communication bus. What we can do is we can do a technique called logit lens. We can take the language head we talked about earlier and stick it in between every single layer of the network. And what was it thinking at that layer? So that's what I've done in this sheet. So I gave it the prompt, if today is Tuesday, tomorrow is, and the predicted token is Wednesday. And GPT-2 does this correctly for all 7 days. And what you see in this chart is essentially the columns here from 3 through 9 are all those lanes of the information superhighway. And for example, here at block 3, this is the top most predicted token at the last token position. So it predicted not. The second most likely word was going to be still. Then it was going to be just. These are all wrong. So let's look for what we know is the right answer, Wednesday. So over here at block 0, we see Wednesday. It's at the bottom of the Tuesday stream for some reason on that highway. Well, it makes sense it'd be close to Tuesday. And then it completely disappears. And then, oh, over here towards the last few layers, suddenly we see tomorrow, forever, Tuesday, Friday. It knows we're talking about time, we're talking about days. And it gets Wednesday, but it's still the third most likely token. And then finally it moves it up to the final position, and then it locks it into place. So what's going on here? Well, a series of researchers basically took this logit lens technique on steroids and isolated that only 4 components out of the entire network were responsible for doing this correctly over all 7 days. What they found was that all you needed was the perceptron from layer 0, attention from layer 9, and actually only one head, the perceptron from layer 9, and then attention from layer 10. And that's kind of what we saw on the sheet. Right? At the top, we saw Wednesday, and then it disappeared until the later layers pulled it back up and up in probability towards the end of the process. So it's an example of where you can see each layer acting as a communication bus, trying to jointly figure out and create what they call a circuit to accomplish a task. OK, we are now out of med school and ready for surgery. So you may have heard about the pioneering work that Anthropic has done about scaling monosemanticity. This gave rise to what was known as Golden Gate Claude. It was a version of Claude that was very obsessed with the Golden Gate Bridge. To some, it felt like it thought it was the Golden Gate Bridge. Conceptually, here's how this process worked. You have a large language model, and then you have this residual stream we talked about earlier. And then you use another AI technique, an autoencoder. This one's a sparse autoencoder. And you ask it to look at the residual stream and separate it out into interpretable features. And you then try and deduce what each feature is, and then you can actually turn up and down each of these features back in the residual stream in order to amplify or suppress certain concepts. It turns out a team of researchers led by Joseph Bloom, Neil Nanda, and others are building out sparse autoencoder features for open source models like GPT-2 Small. So here, for example, is layer 2's feature 7650. I don't know if you can see it in the back. It's basically everything Jedi. So, gone to our friendly patient again, and I've taken the vector for that feature. While we wait for Excel to wake up, there it is. That first row is essentially what they call the decoder vector, corresponding to Jedi. And then I've basically multiplied by a coefficient, And then I've basically formatted it so that I can inject it right into the residual stream. So this is the start of the block. You can see that steer block 2. It's basically just taking that vector I showed you and adding it into the residual stream. Simple addition. Now we go to our prompt. And originally, normally, you ask GPT-2, Mike pulls out his. Makes sense, he pulls out his phone. But if we turn the Jedi steering vector on, I'll give you one guess what he's probably going to pull out. Let's see. OK, so now we hit calculate now. And this is where you get to witness the 30 seconds it takes. And while we wait for it to run, a couple notes. So first of all, the way Anthropic did their steering was slightly different, but similar in spirit. There's a few other ways to do this kind of steering. One of those is called representation engineering, where the steering vector is deduced via PCA, or principal component analysis. And there's another technique called activation steering, where what you do is you'd take the thing you want to amplify, like Jedi, and you'd run the model through just on that token, and then you'd run on something you might want to suppress, like in this case, phone, and then you'd create a Jedi minus phone vector and inject that into the residual stream. OK, there it is. There it is. Mike pulls out his lightsaber. There we go. We have done it. Our operation has been a success. We've created the world's first GPT-2 Jedi. Stick that on LM Arena. OK. Well, hopefully I've given you a little better insight into how large language models work, but also why they work. But the root message I want to leave with is that to be a better AI engineer, it does help to unlock the black box. Partly this is about just knowing your tools and their behavior and their limitations better. But also, we're in a very fast-moving field. And if you want to understand the latest research, it helps to know how these work. And then last but not least, when you communicate with non-technical stakeholders, there's very often a perception of magic. And the more you can clear that up, the more you can clear up misunderstandings. I'll give you just one example of where this bubbles up, where architecture bubbles up to how you use them. So this is the instructions for RWKV, which is a different type of model. But the template for a normal transformer is at the top. The template for an RWKV prompt is at the bottom. And what's interesting is that they recommend you swap the traditional order of instructions and context because the attention mechanism, or the pseudo-attention mechanism in RWKV, can't look back the same way a regular transformer can. So it's a great example of where model architecture matters all the way up to prompting. OK, here are the references for the research we talked about today. And then if you want to learn more, you can go to spreadsheetsareallyouneed.ai, and you can download this spreadsheet, and you can run it on your own device. If you want to see me go through every single step of this spreadsheet, I just launched a course on Maven today, and the link to it is on that website as well. And that's it. Thank you.
Please welcome to the stage CEO of Llama Index, Jerry Liu.
Great. Hey, everybody. I'm Jerry, co-founder and CEO of Llama Index, and I'm excited to be here today to talk about the future of knowledge assistance. So let's get started. First, everybody's building stuff with LLMs these days. Some of the most common use cases we're seeing throughout the enterprise include the following. It includes document processing, tagging, and extraction. It includes knowledge search and question answering. If you followed our Twitter for the past year or so, basically, we've talked about RAG probably 75% of the time. And also, just you start generalizing that question answering interface into an overall conversational agent that can not only do a one-shot querying search, but actually store your conversation history over time. And of course, this year, a lot of people are excited about building agentic workflows that can not only synthesize information, but actually perform actions and interact with a lot of services to basically get you back the thing that you need. So let's talk about specifically this idea of building a knowledge assistant, which we've been very interested in since the very beginning of the company. The goal is to basically build an interface that can take in any task as input and get back some sort of output. So the input forms could be a simple question. It could be a complex question. It could be a vague research task. And the output forms could be a short answer. It could be a research report, or it could be a structured output. RAG was just the beginning. Last year, I said that RAG was basically just a hack, and there's a lot of things that you can do on top of RAG to basically make it more advanced and sophisticated. If you build a knowledge assistant with a very basic RAG pipeline, you run into the following issues. First is a naive data processing pipeline. You put it through some basic parser, do some sentence splitting, chunking, do top K retrieval, and then you realize, even if it took you 10 minutes to set up, that it's not suitable for production. It also just doesn't really have a sense of being able to understand more complex, broader queries, so query understanding and planning. There's also no kind of more sophisticated way of interacting with other services, and it's also stateless, so there's no memory. So in this setting, we have said, RAG is kind of boring if it's just the simple RAG pipeline. It's really just a glorified search system on top of some retrieval methods that have been around for decades, and there's a lot of questions and tasks that naive RAG can't give an answer to. And so one thread that we've been pulling a lot on is basically figuring out how to go from simple search and naive RAG to building a general context-augmented research assistant. So we'll talk about these 3 steps with some cool feature releases in the mix. But the first step is basically advanced data and retrieval modules. Even if you don't care about the fancy agentic stuff, you need good core data quality modules to basically help you go to production. The second is advanced single agent query flows, building some agentic RAG layer on top of existing data services as tools to basically enhance the level of query understanding that your QA interface provides. And then the third, and this is quite interesting, is this whole idea of a general multi-agent task solver, where you extend beyond even the capabilities of a single agent towards multi-agent orchestration. So let's talk about advanced data and retrieval as the first step. The first thing is that any LLM map these days is only as good as your data, right? Garbage in, garbage out. If you're an ML engineer, you've heard that kind of statement many times. And so this shouldn't be net new, but it applies in the case of LLM app development as well. Good data quality is a necessary component of any production-grade LLM application, and you need that data processing layer to translate raw, unstructured, semi-structured data into some form that's good for your LLM app. The main components of data processing, of course, are parsing, chunking, and indexing. And let's start with parsing. So some of you might have seen these slides already, but basically, the first thing that everybody needs to build some sort of proper RAG pipeline is you need a good PDF parser, okay? Or a PowerPoint parser, or some parser that can actually extract out those complex documents into a well-structured representation instead of just shoving it through PyPDF. If you have a table in a financial report and you run it through PyPDF, it's going to destroy and collapse the information, blend the numbers and the text together, and what ends up happening is you get hallucinations. And so one of the key things about parsing is that even good parsing itself can improve performance, right? Even without advanced indexing and retrieval, good parsing helps to reduce hallucinations. A simple example here is we took the Caltrain schedule, right, the weekend schedule for Caltrain, parsed it through Llama Parse, one of our offerings, and through some well-structured document parsing format, because the LLMs can actually understand well-spatially laid out text, when you ask questions over it, I know the text is a little faint, it's totally fine, I'll share these slides later on, you're able to actually get back the correct train times for a given column, versus if you shove it into PyPDF, you get like a whole bunch of hallucinations when you ask questions over this type of data. So that's step one. You want good parsing, and you can combine this, of course, with advanced indexing modules to basically model heterogeneous data within a document. One announcement we're making today is, we opened up Llama Parse a few months ago. It has like tens of thousands of users, tens of millions of pages processed, gotten very popular. And in general, if you're an enterprise developer that has a bucket of PDFs and wants to shove it in and not have to worry about some of these decisions, come sign up. This is basically what we're building on the Llama Cloud side. The next step is advanced single agent flows. So, we have good data retrieval good data retrieval modules, but in the end, right now, we're still using a single LLM prompt call. So how do we go a little bit beyond that into something more interesting and sophisticated? We did this entire course with Andrew Ng at deeplearning.ai, and we've also written extensively about this in the past few months. But basically, you can layer on different components of agents on top of just a basic RAG system to build something that is a lot more sophisticated in query understanding, planning, and tool use. And so the way I like to break this down, right, because they all have trade-offs, is on the left side, you have some simple components that come with lower costs and lower latency. And then on the right, you could build full-blown agent systems that can, operate and even work together with other agents. Some of the core agent ingredients that we see that are pretty fundamental towards building QA systems these days include function calling and tool use, being able to actually do query planning, whether it's sequential or in some style of a DAG, and also maintain conversation memory over time. So it's a stateful service as opposed to stateless. We've pioneered this idea of agentic RAG, where it's not only just RAG as a single LLM prompt call, where the whole responsibility is to just synthesize the information, but to actually use the LLMs extensively during the query understanding and processing phase, where not only are you just directly feeding the query to a vector database, in the end, everything is just an LLM interacting with a set of data services as tools, right? And so this is a pretty important framework to understand, because at the end of the day, you're going to have in any piece of LLM software, LLMs interacting with other services, whether it's a database or even other agents as tools, and you're going to need to do some sort of query planning to basically figure out how to use these tools to solve the tasks that you're given. We've also talked about agent reasoning loops, right? Probably the most stable one that we've seen so far is some sort of while loop over function calling or React. But we've also seen fancier agent papers arise that basically deal with DAG-based planning, planning out an entire DAG of decisions, or tree-based planning, you plan out an entire set of possible outcomes and try to optimize there. The end result is that if you're able to do this, you're able to build personalized QA systems that are capable of handling more complex questions, for instance, comparison questions across multiple documents, being able to actually maintain the user state over time so you can actually revisit the thing that they were looking for, being able to, for instance, look up information from not only unstructured data, but also structured data by treating everything as a data service or a tool. But, there are some remaining gaps here. First of all, we've kind of had some interesting discussions with other people in the community about this, but a single agent generally cannot solve an infinite set of tasks. If anyone's tried to give 1,000 tools to an agent, the agent is going to struggle and generally fail, at least with current model capabilities. And so one principle is that specialist agents tend to do better if the agent is a little bit more focused on a given task, given some input. And then the second gap is that agents are increasingly interfacing with services that, maybe other agents actually. And so we might want to think about a multi-agent future. So let's talk about multi-agents and what that means for this idea of knowledge assistance. Multi-agent task solvers. First of all, why multi-agents? Well, we've mentioned this a little bit, but they offer a few benefits beyond just a single agent flow. First, they offer this idea of being able to actually specialize and operate over a focused set of tasks more reliably so that you can actually stitch together different agents that potentially can work together to solve a bigger task. Another benefit or set of benefits is on the system side. By being able to have multiple copies of even the same LLM agent, you're able to parallelize a bunch of tasks and able to do things a lot faster. The third thing is that actually with a multi-agent framework, instead of having a single agent access 1,000 tools, you could potentially have each agent operate over 5 to 10 tools and therefore use a weaker and faster model. And so there are actually potential cost and latency savings. There are, of course, some fantastic multi-agent frameworks that have come out in the past few months, and many of you might be either using those or kind of building your own. And in general, some of the challenges in building this reliably in production include, one, being able to either let the agents kind of operate amongst themselves and build some sort of unconstrained flow, or actually being able to inject some sort of constraints between the agents. So you're basically explicitly forcing an agent to operate in a certain way given a certain input. The second is when you actually think about having these agents operate in production, currently the bulk of agents are implemented as functions in a Jupyter notebook, and we might want to think about defining the proper service architecture for agents in production and what that looks like. So today, I'm excited to launch a preview feature of a new repo that we've been working on called Llama Agents. And it's an alpha feature, but basically it represents agents as microservices, right? So, in addition to some of the fantastic work that a lot of these multi-agent frameworks have done, the core goal of Llama agents really is to think about every agent as just like a separate service and figuring out how these different services can operate together, communicate with each other through a central API communication interface, and then also work together to solve a given task that is scalable, can handle multiple requests at once, is easy to deploy to different types of services, and basically each agent can encapsulate a set of logic, but still communicate with each other and actually be reused across different tasks. So it really is thinking about how do you take these agents out of a notebook and into production. And it's an idea that we've had for a while now, but we see this as a key ingredient in helping you build something that's production grade, a production grade knowledge assistant, especially as the world gets more agentic over time. So the core architecture here is that every agent is just represented as a separate service. You can write the agents however you want, basically, with Llama Index, with another framework as well. And we have some of the interfaces to basically build a custom agent. And then you're able to deploy it as a service. And basically, the agents can interact with each other via some sort of message queue. And then the orchestration can happen between the agents via like a general control plane, right? We took some of the inspiration from existing resource allocators, for instance, like Kubernetes, or just like other kind of like open source like systems level projects. And the orchestration can be either explicit, so you explicitly define these flows between services, or it could be implicit, right? You can have some sort of LLM orchestrator just figure out what tasks to delegate to, given the current state of things. And so one thing that I want to show you basically is figuring out or just showing you how this relates to this idea of knowledge assistance, right? Because we think that multi-agents are going to be a core component of this. And this is basically a demo that we whipped up showing you how to run Llama agents on a basic RAG pipeline. This is a pretty trivial RAG pipeline. There's like a query rewriting service, right? And then also some sort of default agent that basically just does RAG, like search and retrieval. And you can also add in other components and services like reflection. You could have other tools as well, or even a general tool service. And the core demo here is really showing that, given some sort of input, they're communicating through with each other through some sort of like API protocol. And so this allows you to, for instance, launch a bunch of different client requests at once, handle task requests from different directions, and basically have these agents operate as like an encapsulated microservice, right? And so the query rewrite agent takes in some sort of query, processes it, rewrites it into some new query, and then the second agent will basically take in this query, do some search and retrieval, and basically output a final response. If you built a RAG pipeline, all this stuff, like the actual logic, should be relatively trivial, but the goal is to basically show you how you can turn something, even something that's trivial, into a set of services that you can basically deploy, right? And this is just like another example that's basically a backup slide that basically, again, highlights the fact that you can have multiple agents, right? And they all operate and work together to basically achieve a given task. So, the QR code is linked. First of all, this is in alpha mode, right? And so we're really excited to basically share this with the community. We're very public about the roadmap, actually, so check out the discussions tab about what's actually in there and what's not. We're launching with a dozen basically initial tutorials to show you how to basically build a set of like microservices that basically help you, build that production grade agentic knowledge assistant workflow. And there's also a repo linked that I think should be public now. In general, we're pretty excited to get feedback from the community about what a general communication protocol should look like, how we basically integrate with some of the other awesome work that the community has done, and basically help achieve this core mission of, again, building something that's production grade and a multi-agent assistant. And this is just the last component, which I already mentioned. But basically, if you're interested in like the data quality side of things, like let's say you didn't care about agents at all, and you just care about data quality, we're opening up a waitlist for Llama Cloud more generally, so that you're able to deal with all those decisions that I mentioned, the parsing, chunking, indexing, and ensure that your bucket of PDFs with embedded charts, tables, images is processed and parsed the right way. And if you're an enterprise developer with that use case, come talk to us. So that's basically it. Thanks for your time, and hope you enjoyed it. Okay.
Ladies and gentlemen, please welcome to the stage via recording founder of Small AI and the co-founder of the AI Engineers Summit and World's Fair, Swix.
Hi everyone. I've been thinking a lot about borders recently for no particular reason. And borders are a very innately human thing. If I don't have the right piece of paper, I cannot cross this line in the sand. Like, it's a very, very real problem that I face and many, many people face every single day. And borders are just one kind of constraint that humans just make up. And I think that's very interesting that we respect borders so much, but AI does not. AI is a border disrespecter. It is very, very easily multilingual. So if you trained an LLM on mostly English text corpus, it's going to learn other languages just as a side effect. It's going to be very natively multimodal because you can turn Llama into a vision language model with just like $100 of just post-training. It's very disrespecting of ground truth borders because it doesn't know the difference between hallucination and memorizing from a world model. And it also doesn't respect copyright, which is a whole other topic that we won't get into today, but it's also super fascinating. And how does that relate to do with AI engineering, right? Like, I think a lot of you here are here because you are interested in that concept at least. Maybe you identify as an AI engineer, maybe you're trying to hire an AI engineer. So there are a lot of definitions floating around, and I confess that I've contributed to that. Is AI engineering an API line, right? That's the line that a lot of people have, and that's come under some debate recently. And yeah, that's one form of AI engineering, and I think that is useful to some people for understanding like where the responsibilities in a team might stop and end and start with the other people in the team. Or maybe there's different subtypes, right? Like last AI Engineer Summit, I talked about the 3 types of AI engineer that I was seeing emerge: the AI enhanced engineer, the AI products engineer, and the non-human agentic AI engineer. Or it could be a job description that you try to sort of list out. And this is something that on the Latent Space podcast we recently went through with Illicit, talking about the different roles that they see within their teams as well. So, okay, if I broadly have any of these 3 things, have I nailed down a good definition of AI engineer that is workable? Yes, right? But is that something that we're happy with? Is there something that is there nothing left to explore? I think the answer is no. I think there's more to explore. I think the very easy cop-out as well for people discussing this is that you have your opinion, I have my opinion, you come from your point of view, I come from my point of view. We agree to disagree, or we agree that they're different strokes, different folks, and then we move on. I don't really like that just because there's no shared agreement on the things that is ground truth to everybody. So I want to raise that challenge a little bit more. I was in a podcast with Raza Habib, who's one of the speakers today, talking about what this conference is and why this conference does what it does. And I always say that AI engineering conferences are effectively my highest stakes expression of what I think the state of AI engineering is. So this time last year, 2023, AI years are 2 times of human years. We had a few tracks, and we had a few topics that were up for debate. We had RAG, CodeGen, and then agents and multimodality. All those tracks are repeated here today. I have some speakers illustrated here just for illustrative purposes. These obviously are not everyone involved. But I think just like the inside-out metaphor that I've been thinking a lot about, as the AI engineer matures, so does the number of concerns that you have to juggle in your head. So this year, after you're a competent AI engineer, this year you're now faced with like, okay, I have to migrate to open models. I have to build up my evals. Maybe I should have done that first, but that's a whole topic of discussion. Maybe I should scale up my inference, or maybe I should deploy it to the Fortune 500. And maybe on the management side of things, I should be hiring teams of AI engineers and managing AI strategy for my company. I think the last track, like I talked about the 9 tracks in AI engineers, it's always about the network, the community, the network that we're building. That's probably the single most important part of this conference, and that's the part that we cannot sell. I cannot put on the website, hey, we have good community, because no one will believe us. You have to come and see for yourself. But please, for those of you who've been uploading to the Google Photos album, who've been tweeting out your photos and sharing them on LinkedIn, please keep doing that. It's a way for myself and everyone else who's not at the conference to try to join in on the fun. The reason I'm not comfortable with any of these tracks is because I know how they were made, because I made them up. And I know that because I was looking at the original document for the Rise of the AI Engineer. We're celebrating the 1-year anniversary today. And just down in the document somewhere, I just listed out the disciplines that I thought the AI engineer would have, and those eventually became mostly mapping to the tracks that I have been exploring in these conferences and the meetups that I do. And it's arbitrary. Like, why is there a separate agents track from CodeGen? Why is there a separate RAG track from open models? Like, these are all related. They're all of a kind, and obviously, as a competent AI engineer, you should be familiar with all of these things. And that brings us back to this mindset of having boundaries and borders, right? These are all made up by someone. I made them up for this one, but you're going to live in a world where your boss made it up at your company. And these are not reflective of how reality actually has to operate, right? If you swept away all the rules and a different group of people came in, would they agree on the same rules? Probably not, just because they're made up. But the laws of nature are hard to make up because the reality actually works that way. If you had an alien civilization come down to Earth, they would discover that gravity works the same, the sun, the energy from the sun works the same, the magnetic field works the same. So what are the laws of AI engineering? We'll come to that via definitions of software engineering and real engineering. So I went and looked up definitions of software engineering. And IEEE talks about the application of engineering to software with the design, implementation, testing, and documentation of software. Google developers talks about mostly the same thing. They also mention software lifecycle management. Okay, like really reasonable definitions of a kind, until you look at real engineers. Real engineers talk about applying natural sciences, utilizing them for benefit of humanity. Both the IEEE and the National Association of Engineers agree on that. And it's curiously missing from software engineering. Like the benefiting humanity part, the understanding natural laws part, completely missing from software engineering. So my proposal to you is that AI engineering is somewhere in between, right? The software engineering, but then encountering a lot of more of the real world constraints than you would in a typical software engineer career. So if we know the laws of Earth and they are independently derived, they cannot make, no matter what point of view you're looking at, they all are the same laws, then what are the equivalent laws of AI engineering? I have a few, you can come up with more, but I'm just gonna propose some to start off debate. There's constants. So for example, if you're designing for humans, you should respect the fact that humans only speak at 80 words per minute, but they read at 200 words per minute, right? So there's an inherent disparity there. There's also contingent facts, things that are true for now, instead of true forever. And true for now facts are, for example, like the Apple Intelligence. When they ship a local model on every phone, then that inference speed of 30 tokens per second that they're advertising becomes the baseline speed limit or speed barrier of what intelligence that is too cheap to meter should look like. And these things, they're not set in stone, they're not actual physical laws. So they also trend over time due to forces and momentum. And I want to establish a little bit, like, I think it's very beneficial for AI engineers to understand what the Moore's laws of AI is so that you can plan for them, so that you don't have to make the bad bets that are not gonna last, obviously just because of overwhelming evidence. The first bet is the improving of context, right? A year ago, I was interviewing Mosaic and talking about MPT7B with their whopping 60,000, 70,000 token context with a lot of loss. Today, sitting in the audience, we have people who have trained million token context windows. And we've also have from Anthropic, which just released Claude 3.5 last week, the fact that we have complete utilization. It's not just about the length of context, it's also about the utilization of context. And I think Greg, who's sitting in the audience as well, would be very happy with how Claude is improving on their utilization of their very, very long context windows. There's also the cost of intelligence, the commodification of intelligence. So in the past 2 years, we've seen a 99.55% decline in the cost of GPT-3 level intelligence. The cost of GPT-4 level intelligence has probably come down maybe 90%, maybe 80%, from GPT-4 to Llama 3 and now all the newer models that are. Finally, I think it's worth commenting a little bit on where AI engineering stands in contrast to other AI philosophies. There's EA versus EAC. And maybe we're in the middle, like we care about safety, but we also want to accelerate, right? It's kind of like a weird combination of the two things. My proposal is that one dimension isn't enough to express how AI engineer differs from the other philosophies, and actually need to add a second dimension to talk about utility. We are utility maxis above all else. We see what's out there, and we want to use it to benefit humanity. So my message to everyone at the World's Fair is to try to disrespect borders a little bit. Try to avoid your own dogmatic beliefs, lazy consensus of other people, or passive reactions. And in other words, try to disagree more. Disagree with your own conclusions, disagree with each other productively, and disagree with the status quo. And I think there you'll find that this conference becomes more of a useful landmark in your careers rather than just a party, which it can very well be. My final analogy, which I really like, is that AI engineers are the kind of person that looks at Shoggoth and sees, instead of a monster that cannot be tamed, they want to turn them into mass rapid transit. And the kind of person that looks at that, looks at a force of nature and wants to turn it into tools that are useful for people is the kind of AI engineer that I would love to speak to and welcome at conferences like this one. So that's my view of what borders and AI engineering without borders should look like. I very much encourage you to jump between tracks, to jump between friend groups, to jump between disciplines and modalities, because here's the one place that you can do that outside of your work, and to mingle with everyone else that we've gathered. So I hope you enjoyed doing that. I wish I was there in person, but just share them online, and I hope to see you in person at the next one. Bye.
All right. What a way to close out the day. One more time for Swix. He's watching on the live stream, so let's make sure he can hear us from here. We miss you, Swix. I know you're watching. That is some great food for thought. We're about to head into the Pinecone after party, so I'll just be very brief. I just want to thank everyone for coming to the second day, the first day of sessions, the second day of this 3-day event. So I'm not going to keep you from the Pinecone after party, but we do have a representative from Pinecone here to just say a few words before we head to the Pinecone after party. So please join me in welcoming, for the last word, Head of Community at Pinecone, Jocelyn Matthews.
Hi, welcome. How's everybody doing? Good? Yeah, that was my attempt to get you all on my side. Did it work? So I'm Jocelyn Matthews. I am the head of community at Pinecone, and you may already be familiar with us. We are the leading vector database. We're also proud to be the sponsors of the official after party of the AI Engineer World's Fair. So I used to be an engineer myself, and I tried to think about, like, it's the end of a long day. What do you want on the way to a party? Is it a pitch? No. So instead, I'm going to talk about our new announcement, which is something that you can tinker with and not a product that we're selling currently. Yesterday, we launched Pinecone Assistant in beta. So Pinecone Assistant is an API service for answering complex questions about your proprietary data, and it answers them accurately and securely within your applications. This is the QR code if you want to sign up for the beta preview, and the code will come up again, so if your phone's at the bottom of your backpack, don't worry, you're going to see it again. With Pinecone Assistant, you're going to get simplicity, high-level results, and full control over your data. I think actions speak louder than words, so I've got this little animated GIF, and you can see here. So developers still really struggle to build AI assistants that can accurately answer questions about private data. I think we all know that. And we also all know that publicly available models are unaware of this data, and providing it can pose security concerns. Most teams also might lack the time or the deep AI expertise to be working with RAG. So Pinecone Assistant gives you a better way. You just upload your PDF or your text files, and then you start asking questions. You can prototype quickly with the drag and drop method as seen in the GIF, and then add it to your applications in a matter of minutes with the chat completion compatible API. And then in response, you're going to receive relevant answers that are grounded in your data with references. This is what the code looks like. You can see it's very comprehensible, very accessible for a wide variety of engineers. The answer quality will get better over time across more domains and will eventually support complex queries over multimodal data. I also thought that you might be interested in seeing some actual numbers. So you can see that you are able to provide more accurate results with less effort. And that's why we built Pinecone Assistant with a focus on delivering the highest quality and most dependable answers. Today, it already performs better in beta than other assistant APIs for text-heavy articles, text-heavy technical data, and financial and legal documents. I also know from my work in the community, where I deal with thousands of engineers, a question that always comes up is around data protection. So you're able to protect and control your data. The data that you upload is encrypted and isolated. Your data is used as context and reference for answers in real time. It's not used to permanently fine-tune. It's not used to train the underlying language model. And in essence, you control what the assistant knows, and you control what the assistant forgets. You can prototype and ship AI assistants in minutes, and we welcome you to try it out for yourself, tinker with it. If it takes you longer than minutes, please email me. My email is jocelyn@pinecone.io. Actually, no, send it to the group inbox. Send it to community@pinecone.io. You can easily create an assistant inside the console. And like I said, you'll receive relevant answers which are grounded in your data and which do have references. All of the infrastructure, the operations, or an organization are basically handled for you. And that includes everything you see on the screen, which would be the chunking, the embedding, file storage, et cetera. The beta starts now with more to come. We announced it for the first time yesterday, and this event is the first time that we've talked about it publicly, directly live with engineers, so you're kind of, in a way, hearing it here first. We're releasing it in beta, as I said. I want to stress the beta part, and we want you to try and share your feedback as you're working with it. The starting limits are 1 gig, and I believe it's 100 queries per month. Those might or might not change during the beta period, and you can also expect rough edges because it is a beta, but you can also expect rapid improvement based on the feedback that we gather from you. So that brings me to the end of my talk, and let the party start. Thank you so much for being here.